You're probably wondering why we need another Python course on this channel. Well, Anil has an interesting approach to teaching Python. This beginner's course will help you learn Python by thinking in types. This course teaches basic programming concepts instead of just focusing on language syntax. It's always helpful to learn from different perspectives, and this may be just what you need to learn Python.
Hi guys, my name is Anil Kulkarni and welcome to this course, Modern Python 101 Thinking in Types. Now, if you wanted to learn Python, if you are a complete beginner or if you have been struggling to learn Python for a time, then this course is for you. Let me share my journey of learning Python. It took me a pretty long time to understand Python, rather many months or rather a couple of years to understand Python. And finally, when I started to learn more about Python, I could understand that I was struggling to learn Python because I was not able to think in types. You know, Python is a dynamically typed language. So sometimes you are at loss to understand what goes where and where we have to use a particular variable or a data type or a data structure. So this course is obviously designed for the people who are totally new to Python, or if you are struggling to learn Python for a while now. Now, throughout this course, I'll be taking you through a small journey. We will start by thinking in types and we will end in thinking in layers. So thinking in layers is like an architectural pattern. I will help you to understand what goes behind creating a production level application. Before we can go ahead and write Python, we need to do a couple of things. The first thing is obviously we need to install Python, and we also need to set up our development environment. But before that, I would like you to meet my friend Louis. Now Louis is going to help us throughout this course for learning Python. Before you can do anything else, I want you to go ahead and download all of the source code for this entire tutorial. What I want you to do is just go to this link, github.com/octalium/modernpython101, and this is where you can find the entire source code for this entire tutorial. You can just click on code and just click on download zip to download all of the files in a zip format. Or if you are using GitHub, you can simply use this link to clone the repo. After you have downloaded all of the files, this is how it's going to look. So let me open up my README and just let me open up in my preview mode. Okay, so this is how all of the files and the folders would look like. Now please keep in mind that on my machine I could have a couple of more additional folders just for the sake of helping me throughout the tutorial. But overall, this is how it's going to look in your machine as well. At any point in the future, if you want to compare your code with mine, you can simply click on these folders. For example, if you just click on this folder type system, you can see there are a couple of files which I have already written. For example, just click on this file variables and you can see all of the code is right over here. If you want to see the sequence in which we are going to learn all of these files, then you can simply click on readme and here you can find the sequence. For example, in this one, the first file would be your variables. The second one would be variable rules, which is right over here, and so on. Well, that's it for this video. In the next video, we are going to download and install Python on your machine. Before installing Python, I thought it would be a very nice idea to give you a small tour of Python. For this, I want you to open up your favorite web browser and I want you to search for Python online compiler, and I want you to click on this link. This is for repelit.com. And as you can see, we have a working Python environment ready for us. So right on this line, I want to print out Modern Python 101. So just replace hello world with Modern Python 101 and just click on the run. So as you can see, we have the output of Modern Python 101. Let's try one more simple example. And this time I want to print out my name, and my name is Octalium. On this line, instead of printing Modern Python, I want to print out my name. That's it. Just hit the run button one more time and you can see we have the output of Octalium. As you can see, writing Python is as simple as writing your plain English. And from the next video, we will see how to install Python and how to set up our development environment. You can just go to the website python.org. From here, let me just zoom in first. Okay. From here, just go to downloads. And as you can see, since I'm using Mac OS, so that's why it's showing as Mac. If you're working on Windows, most probably it will show you on Windows. And at the time of recording, the latest version is 3.10.5. So I just want you to click on this and it will start the download. You just have to install Python just as you would install any other program. Just click on this. It will open up a installer dialog. So just click on continue, continue, okay, agreement, I agree, and install. Now, since I already have Python installed, I won't be installing, but in your case, if you don't have Python installed, just go ahead and click install. After the installation is done, I want you to open up your terminal. If you're working on Windows, just make sure you open up your PowerShell, and let me just try to zoom inside this as well. So once you have your terminal open, I want you to type Python hyphen and a capital V. So as you can see, it's showing the Python installed version. In my case, it is 3.10.5. Just make sure you have a version which is more than 3.10. 3.9 will not work because I will be showing you a couple of new features which have been introduced in the version 3.10. And if you're watching this video in the future, you don't have to worry because all of the functionality that I'm going to show in this tutorial, all of those things are going to work in the future as well. The next thing that I want you to do is install Visual Studio Code. So I want you to go to this website, code.visualstudio.com, and I want you to download Visual Studio Code and install it. So just click on this. Since I'm using a Mac, it's showing Mac. If you are using Windows, make sure you click on the right button. So just click on this. It will again download the installer, and you just have to install Visual Studio Code as you would install any other program. After installing Visual Studio Code, I want you to open it up. So this is my Visual Studio Code. On the left, you can see there is a small bar, and I want you to click on extensions. Let me take it up right over here, and I want you to search for Python. The first thing that pops out right over here, this is the Python extension by Microsoft. I want you to click on install. Now I do have a couple of more extra dependencies. These are optional, but I would highly recommend you to install all of those. So just open up your terminal. If you're working on Windows, open up your PowerShell, and there is a command which is called as pip. Now pip actually ships with Python. I want you to type pip install IPython, MyPy and black, and just hit enter. So these are a couple of extra dependencies that I would like you to install. Now since I have already installed, it's showing me as already satisfied, but in your case it will go ahead and install all of the dependencies, and that's it. Now we can start writing Python code on our machine. If you have some doubts, then you can open up this readme file. So this is the code that we downloaded from GitHub. So inside my folder number 1, introduction, just click on readme, and you can see I have provided the links for everything. There are a couple of more optional dependencies. For example, this one, code runner. This one we would see in some of the future videos, and if you want to have the exact same theme like mine, so you can use this theme. I'm using a theme which is called as pitch black theme. Now if you are working on a Mac and if you have issues while typing this command, so suppose you are typing Python/v, and if you're not getting this output, then just make sure to watch the next video where we would see how to rectify it. Sometimes on a Mac you may not get the desired output. Suppose you are typing Python/v. If you're not getting this output, then maybe you can try typing Python 3 -NV. Now this is because Mac already comes with a pre-installed Python, but most of the times it is not going to be the latest version. You can use this syntax Python 3-v all the time, and if you want to use pip, then also you need to type pip3, and then you can say pip3 I want to install my IPython, MyPy and Black. This is also going to work, but typing Python 3 and pip3 all the while becomes slightly boring. So what I'm going to do is I'm going to set up an alias. For setting up an alias, first thing that I want you to do is I want you to go to your home directory. You can go to your home directory by typing cd, and that's it. Let me clear up my terminal by typing Ctrl and L. Now if you type ls-al, that means I want to list all of my files and folders inside my current directory, and I also want to see some of my hidden files as well. So as you can see, it's a pretty long list, but the file that I am interested is this one. It's called as .zshrc. That's the file where we will set up an alias. I want you to go ahead and open up that file inside your code editor. You can open up the same file inside Visual Studio Code by typing code followed by the name of the file. Don't forget to put the dot before. Now just press enter. If you're not able to open up this file from your terminal, then inside your Visual Studio Code I want you to type Shift, Command and P. That will open up a new window, and I simply want you to type code, and you can see the pop-up shell command, install code command in the path. I want you to click that, and after clicking that you can simply close and open up your terminal once again, and let me just zoom inside, and now you can say I want to open up my .zshrc file inside my code editor. Just hit enter. For now just ignore all of the stuff which I have inside my zshrc. That's because I'm using a lot of fancy setup. The thing that I want you to add inside your zshrc are just these two lines. So what we are doing is we are just setting up an alias. That means whenever we are typing Python inside our terminal, at that time we actually mean to type Python 3. And the same thing goes with pip. Whenever we are typing pip, I want my system to invoke pip3 instead. So this is what our alias is going to do. Just save your zshrc file, again go back to your terminal. I again want you to close and open up your terminal one more time. Again let me zoom inside it, and now this time if you're typing Python -NV, it should give you the right output. Now that we have Python installed on our system, it's time to write our very first Hello World program. But before we can write our Hello World program, I would like you to create our very own directory structure so that we can organize all of the code in a much better way. So for that, I would like you to open up your Finder, or if you're on Windows, just open up any window and navigate to the place where you want to create the folder. So I'm just going inside my home directory, and here I'm going to create a folder by the name of Modern Python 101. You can create this folder wherever you want. After this, I'm just going to open up my Visual Studio Code, and I'm going to drag this folder inside my Visual Studio Code. Okay, so here we are. Here I'm going to create one more folder, and I'm going to name it as 01 introduction. Let me spell it right. And inside this folder, let's create our very first Python program. So let's create a file inside of this, and I want you to name the file as hello world.py. Always make sure that we have the extension as .py. So .py stands for a Python file. And right now what we are going to do is we are simply going to print hello world to our terminal. A couple of lectures ago, we have seen how to do it online by using a Python online compiler. But in this video, let's try to do it on our local machine. Let me just collapse my sidebar. The first thing that I want you to write here is an inbuilt function by the name of print. So basically what we are trying to do is we want to tell Python, hey Python, I want you to print hello world. And that's it. Now I want you to open up your terminal, and inside this terminal let us see how we can execute this file. I'm inside my directory of Modern Python 101. From here I want to go to my newly created folder 01 introduction, and once inside this folder I can simply run my file by typing Python followed by the name of the file and just press enter. And here you can see we have the right output of hello world. If you want to change this from hello world to hello octallium, let's do it. Let us save the file. Again, go back to the terminal. Let me clear up my terminal. Let us try running the file by typing Python followed by the file name one more time. And we have the desired output of hello octallium. Now typing Python and helloworld.py all the time becomes a little boring. In order to automate this task, we are going to install one more extension, and this time the name of the extension is called as Code Runner. So I want you to go to your extensions tab and I want you to search for Code Runner. This is the plugin. Make sure you install this plugin. Once we have this plugin in place, we can simply run the file. I'll just show you how to do it. Let me close my terminal. Let me close all of this. So once we have the plugin installed, you can simply click on this play icon right over here, and that's going to execute your file. So as you can see, the Code Runner extension actually executed my file, and I have the output of hello world on the screen. So this video was just to give you a small feel of writing Python on our local machine. From the next videos, Python is going to get much more interesting, and we will start to learn all of the basic fundamentals of Python. Now let's actually start learning Python. And the first concept that we are going to learn in Python is all about understanding variables. But before we can understand variables, we need to go on a picnic with Lewis. Yes, let's go on a picnic and then let's see what variables is all about. So Lewis is planning for a picnic and he's going to pack a slice of pizza in his Tupperware. You don't want to go hungry on a picnic, do you? Lewis also wants to pack some of his clothes inside a bag and also a bottle of water. Now let's try to visualize this concept a little more technically. So you can imagine your Tupperware, bag and bottles to be your containers. And what these containers are going to hold is this: slice of pizza, clothes and water. So you can imagine all of these things to be values. So the containers are going to hold all of the values. Now let's try to see all of these things in the world of Python. So here we have three containers: Tupperware, bag and bottle. And we have three values: slice of pizza, clothes and water. So essentially what's happening is your containers are just like your variables, because your variables are going to hold some data. You can translate this concept in Python by typing like this. On the left you can see Tupperware is a variable, and the variable of Tupperware is holding a value of slice of pizzas. This equal to is also called as the assignment operator. That means we are assigning the value on the right to the variable on the left. And the same thing goes with bag and bottle as well. Now it's time for us to create some more variables. So I'm inside my folder number 2, type system. So this is the code that we downloaded from GitHub. And this is the folder that we created. Remember, we created a folder called as Modern Python 101. So this is where I am. Here I want to create one more folder, and I'm going to name it as 02 type system. And inside of this, I want you to create one more file by the name of variables.py. And this is where we are going to create some of our variables. Here is the scenario. Louis wants to go for a party and he has 3 items with him. He has balloons, he has some crackers, and he has some hats. But he has only a single box. So let's see what he's going to do. Let's create a variable called as box. Here we are going to create our variable called as box, and let us assign the value of balloons to the variable of box. Please remember to put this inverted commas because this is the value that has been assigned to our variable of box. On the next line, we simply want to print out our variable. So as you already know, we can simply say, hey Python, I want you to print out my variable, and the name of my variable is box. That's it. Just save a file and let's try to run the file. Now there are two ways of running the file. If you have code runner installed, you can simply click on this and this is going to run your file. And here you can see we have the output of balloons, or you can also run the file from a terminal. In order to run the file from the terminal, first we need to go inside the right folder. As you can see right now, I am inside the folder Modern Python 101 and I need to navigate inside my folder, which is 02 type system. Once inside this folder, you can run the file by typing Python followed by the name of the file. In my case, the name of the file is simply variables.py and hit enter. So as you can see, we have the output of balloons. Let me put up a small comment right over here. All of these lines that you can see over here, which starts with a hash sign, this actually means a comment, and these lines are actually going to be ignored by Python while executing your file. Now just suppose Louis wants to take crackers instead of balloons. So let's see how we can reassign the value to our variable. Let me put up a command, and here we can simply reassign by saying that for the variable of box, I want to reassign the value to a new one, and the new value is going to be called as crackers. Let me get the spelling right, and we can again try to print it out. So let's try to print out the box one more time. Let me run the file, and here we have the output. So you can see the first output is balloon, and this output is coming from right over here from line number 7. And on the next line, I have the output of crackers. This output is coming from this line number 11. At line number 11, the variable of box no longer holds the value of balloons because we have reassigned the value on our line number 10. The new value that the variable of box holds right now is just crackers. Now for the last time, if Louis wants to change his mind, and this time he wants to take hats. So let's see how we can reassign the value for the last time. Let me put up some comments before we can do that. So for the last time, we are going to reassign the value of box, and this time the new value is going to be hats. And as usual, we simply want to print out the value inside our variable. So we can say, hey Python, I want you to print my variable of box. That's it. Just save your file and try to run it for the last time. So as you can see, we have the output of hats, and we can see the output of hats. Now this output is coming from our line number 15. The current value that our variable of box is holding is hats. The previous values of crackers and balloons, all of these values are now replaced, and the only existing value inside the box variable is hats. Till now we have seen how to work and create variables. Now let's have a look at what's happening behind the scenes. So these were the variables that we created last time. We created just one variable called as box, but we assign the value of balloons, crackers and hats to the same variable. Now let's see what's happening behind the scene and how Python is treating all of these variables. Just imagine this is the memory of your PC, and let's see now how Python is going to handle your variables. In practical terms, how Python handles the memory would be very different in a practical scenario. But right now, just have a look at this. I have simplified things so that it's much more easy for us to understand. So just imagine all of the green area is the memory of your PC. Now let's see what's happening. Python would read all of your source code, and as soon as it comes across this line box is equal to balloons, what Python is going to do is Python is going to create a variable called as box inside the memory, and Python would look at the right hand side and it's going to find balloons. So it's going to assign the value of balloons to the box, and all of these things are happening inside the memory. So on the next line, when you are trying to print out box, you get the output as balloons. But what happens when Python goes to the next line, that is this one, where you are reassigning the value of box to crackers? At that time, the value of balloons is actually taken out and a new value of crackers is being assigned to the box. So after your line number 6, this is how your box is actually going to look like. So box is going to hold just the value of crackers. That's why on line number 7, when we are trying to print out the value of box, we get the value of crackers. Now the same thing is going to continue on the next line as well. When Python comes across this line, box is equal to hats, it's going to remove the value of crackers inside the memory and it's going to assign a new value of hats, and box would be equal to hats inside the memory, and that's the output that we are getting from line number 10. Till now we have a much better understanding of variables, and this time we are going to see what you don't have to do while creating a variable. You can't just arbitrarily name your variable. There are certain rules for declaring your variables, and that is what I'm going to talk in this video. This is the code from GitHub, and I want you to click on this file, variable rules. I don't want you to waste your time just watching me type, so I'm just going to copy this file from my GitHub folder to my modern Python 101 folder, and let me just paste it right inside my 02 type system. So here is the file, and now let me try to explain what's happening. The first thing that we are going to talk is something about declaration styles. There are different styles in which you can declare a variable. The first style that you can see over here, this is called as camel case. The first alphabet would be in small case and the next words would start with the alphabet. So this is called as camel case. The next is your Pascal case. In Pascal case, as you can see, all of the words, they would start with the capital alphabet. The next one, as you can see right over here, on line number 11, this is called as snake case. On line number 12, this is also a variable, but this is used to declare a constant. I'll be talking about constants in the future. This is also a valid variable, and normally you would use the syntax with an underscore whenever you want to declare a private variable. I'll be explaining what is a private variable as well in the future. This is also a valid variable where you can have a number at the back, and you can mix your numbers with your snake case or your camel case or Pascal case or any other case that you want. So till now what I've done is I have declared a couple of variables, and let's try to print them out and see how they look on our terminal. Let me just run the file, and let me first try and clear my terminal. Now let me go back to the file and let me run it once again. So here we can see we can use different variable styles to get our output. Now let's have a look at the different rules for not declaring a variable. As you can see on line number 29, you cannot declare a variable which starts with the number. If I just uncomment this file, it's going to show me an error. Similarly on line number 30, let me just comment this back. So similarly on 30, if we have a hyphen, it's not going to work. If we have some special characters like a comma, it's not going to work. If you use a $sign at the front, it's also not going to work. And if your variables has a space in between, so that too is not going to work. So whenever you are creating or declaring variables, always keep these things in mind. When it comes to your style, you just have to be consistent in whatever style that you are choosing. As a normal convention, whenever we want to declare any variables or the name of the functions, we would use snake case. But that's just the convention, it's not required. And whenever you want to declare the name of a class, at that time we would be using the Pascal case. And whenever we want to declare a constant, at that time we would use everything in uppercase. Now we have been making very good progress with our variables. We have seen how to assign values to our variables, but we have seen how to assign only a single type of value to our variables. You can see over here balloons, crackers and hats. All of these data types are called as strings. So whenever you are working with your Python programming, you always have to work with some sort of a data, and this data can be classified into different categories. The first category that we are going to see is something called as a primitive data type. So what do I mean by a primitive data type? It simply means that these data types are already present inside Python. The first data type we have already worked with, it's called as a string, and you can see it's always inside a quote. For declaring a string, you can use double quotes or you can use a single quote. Both of them are valid syntax. The next one is called as an integer. So you can see we have whole numbers. So 45 is a kind of integer. The next one would be a float. Whenever you have some decimal places, it's called as a float inside Python. And the last one is called as a boolean. Boolean can have only two types. Either it can be true or it can be a false. Now let's go back to our code editor and create some of these basic primitive data types. So let's create a new file inside my folder 02 type system. I'm going to create a new file and I'm going to name it as primitivedatatypes.py. Let me add some comments as well. Now let's start creating our variables. First, let us create a variable for holding our string, and I'm going to call it as my string. That's it. So my string is my variable and it's going to hold the value of Louis. Let me spell it right. The next variable would be my integer, my int. For short, it's going to be 45. Next one would be my float. It would be 3.14. The next one would be my bool. It stands for my boolean data. And this time I am going to assign it the value of true. Make sure you always use the T with a capital T. And that's it. We have declared our variables and we have assigned the variables with the primitive data types. Now let's try to print one by one. So I want to say, first I want to print my string. Let me just copy and paste it now. The next thing that I want to print would be my integer. Next, let me print out my float. And the last, I want to print out my boolean value. Just save the file and let me run the file inside my terminal. And here we have the output: Louis, 45, 3.14 and true. The last thing that I want to discuss in this video is about your styling. For example, you can see right over here, single quotes is also a valid string, and if you use double quotes, it's also a valid string. So which style should you use? Basically, you can use any style, but you have to make sure that you are consistent throughout your code base. In order to avoid such situations when you're working in a large team, the Python community has come up with some of the style formatters. And one of the style formatter is called as black. So if you remember at the beginning, we have installed a couple of optional dependencies, and one of the dependency was called as black. If you have not installed, then you can simply open up your terminal. Let me clear all of this. And you can install the dependency by simply typing pip install and black. And this will install the optional dependency. Black is a code formatter, and we are going to use black to format our code so that it is consistent throughout. The first thing that I want you to do is I want you to open up the settings for Visual Studio Code. On a Mac, you can do that by typing command and a comma. I think on a Windows, it should be control and a comma. So this is my settings file, and I want you to type save. And the first option that I can see over here is called as format on save. I want you to select this. Now again, go back, search for black. So here you can see the first option, Python formatting black path. Make sure you have black right over here, and that's it. Just close your settings file and let me save this file. It's saying that formatter autopape is not installed. No, I don't want to use that one. I want to use black, so I'm just going to click on this one, use black, and that's it. Now if I come back to this and if I put a single quotes, now just watch what happens when I save my file. It automatically formats from a single quote to a double quote. Black is a really useful utility, and we would be using black so that all of our styling is similar. Since we know a little bit more about strings, let's try and see how we can output the string in our desired format. This is also called as string formatting. Let me create a new file inside my folder, and I'm going to name the file as stringformatting.py. Let me put up a comment at the top. What I want to show in this video is how we can have a desired string output. Don't worry if the concept sounds a little strange, it will get cleared in just a couple of seconds. Suppose I want to print a statement saying that hello and followed by a variable, and that variable can hold a name. For example, you can say hello Louis, or you can say hello Chico, or some other name. So let me first create a variable called as name, and let me assign it a value of Louis. Now let's see how to format this string and get an output as hello Louis. Let me collapse my sidebar, and here I can say print, and I can put my quotes, but before my quotes I need to add one more alphabet called as F. That means I want to have a formatted string, and here I can say hello, and I want to print the name over here. So I'm going to use curly brackets, and inside the curly brackets I can place my variable, so I can say name. Let's save the file and try to run it, and here we have the output as hello Louis. There is one more format of doing this. We can simply say print, and then we can say hello, you can put a comma followed by the variable that you want to print, so I can say name. Just save a file and let me run it one more time. So as you can see, we have the same output, but normally you will see me using a formatted string. So let me just take out the second example. I'm not going to use this kind of syntax. Now let's see how we can output a string saying that Louis is dash and dash years old, and dash has to be filled by a variable. So I can create a variable called as age, and I can say age is 13, and here I want to print Louis is 13 years old. So I can use a print statement. Again, I'm going to use a formatted string, so F and quotes. Then inside my curly brackets, the first variable that I want to print is the name. So name goes over here. So Louis is, then I want to place the age right over here, is 13 years old. That's it. Just save your file and try to run it one more time, and we have the output Louis is 13 years old. Let's do a couple of more practice over here. Suppose Louis has a dog, and then let me spell it right, and the name of the dog is Chico, and this time we want to print out Louis has a dog named Chico. So you can say print, again your formatted string, your curly brackets, your placeholder for your name. So Louis has a dog named, and the dog variable goes right over here, and that's it. Let us try to run the file, and we have the output Louis has a dog named Chico. Let's do it for the last time. Suppose Louis also has a cat, and the name of the cat is Coco. So let me copy and paste this line, and I can say Louis has a cat name, and the variable of cat will go right over here. Let me save the file and let me run it for the last time, And here we have the output, Louis has a cat named Coco. We are making really good progress, but this time I want to make a program that would have a bug inside it. So let me create a file inside my folder, and I'm going to name the file as my first bug.py. Bug actually means that we have some sort of an undesired behavior in our program. So let me put up some comments. Okay, now let's get started with this one. Let's create a variable called as box, and let's assign the value of balloons to it. And let me print out a formatted statement saying that box contains, and the variable of box goes right over here. Let me just run this file, and we have the output that the box contains balloons. Now just watch closely what happens. I can also say box is equal to 10. Now this really doesn't make any sense. Why would I want to store 10 inside balloons? Balloons is a string, 10 is an integer. But if we try to print this, we are going to get an output. Let me copy and paste this line from here, just below this. Let me save it and let me try to run the program. And we have the output, box contains 10. And this is because Python is a dynamically typed language. And this was the point where I really struggled when I was learning Python. But you don't have to worry about this. You can easily solve this problem by thinking in types. In this video, I'm going to introduce to you a concept which is called as type hinting. Let me put up a comment. So what type hinting really means is we always want to associate a type with our variables. And this will really help us to create robust programs and to take care of all of the bugs before we can actually run the program. Now let's start thinking in types. Let's create a variable called as food, and let us assign it a value of milk. Now I want to tell Python that food should always contain the value of a string. It cannot contain any other value. And the way to do it is by using a type hint. You can write a type hint right over here. Let me take it a little up. You can add a type hint right over here. So after the name of the variable, just put a colon. Then we can say this variable has to be of the type of a string, and just you can write str. So str means food variable is of the type of a string, and that's it. And let us print out a statement saying that let us do a formatted string. You can say Louis is going to drink. Inside the curly brackets we can say food, and just save it and run your file. And we have the output, Louis is going to drink milk. We can reassign the variable food from milk to eggs, and then we can say Louis is going to eat. Let me save the file and let me try to run it, and we have the output, Louis is going to eat eggs. Now this time if I say food is equal to false, let me just copy and paste this line. So let me just paste it right over here, save the file, and let me run it for the last time. But what's this? We still have the output. It's saying that Louis is going to eat false. False doesn't make any sense over here. So this is what we call as a bug. This is an undesired behavior. We don't want to assign false to our food. The way to take care of this is by using one more plugin which is called as MyPy. First thing, we need to install MyPy. I hope you installed MyPy in the beginning where I was discussing about the optional dependencies. If not, you can just open up your terminal. Let me clear all of this. And you can install MyPy by saying pip install followed by MyPy, and that's it. After installing MyPy, I want you to open up the settings. Again, you can open up the settings by pressing Command and comma on a Mac. It should be Control and comma on Windows. And here I want you to type MyPy. And I want you to click on this Python linting mypy enabled. Just click on this one and that's it. Now you can see the code editor is highlighting false and it's saying that we have some sort of issue over here. If you just hover over false, it's going to say incompatible types in assignment. Expression has type bool, variable has type string. What it means is variable has the type of str. So if you refer the line number 20, we have assigned the type of string to our variable. That's what this error is trying to tell us. We have declared the variable as string, but in the expression we are trying to assign it a value of boolean. That's why it's not going to work. Or rather, it's going to work because Python isn't dynamically typed language. But at least in your code editor, it's going to show you that something is wrong. So you can see on the top as well, it's showing an error right over here as well. But if you save the file and if you try to run the file one more time, it's going to execute. You can see we are executing our Python program. So this is the thing with Python. Python is a dynamically typed language and it's not going to enforce the data types on the runtime. That is why to prevent such kind of bugs, we are going to use mypy and we are going to use type hinting everywhere. Let's try to do some more practice with our primitive data types. So let's create one more program right over here and let me create a file and the name of the file is just practice.py. Let me put up some comments as usual and let me collapse my sidebar. Now this, as you can see, triple quotes, these are also a valid comment and normally you would use triple quotes whenever you want to write some kind of a documentation inside the string. But the thing about this triple quotes is you can also create strings and you can also do string formatting by using triple quotes. We are going to see an example of this right in this video. Here is the situation. Louis wants to open up a pizza shop and he needs to write a program for accepting orders. Now this is a very important tip. Before you always start coding, first you always need to visualize. Now let's just try to visualize our pizza shop and let us try to think what all variables we would require. The first and the most obvious is we would require a variable for customer. That's the place where we would save the customer data. The second variable could be a pizza base. Maybe you would like to have a thin base or a base filled with cheese or whatever you prefer. The next variable could be for storing the pizza size. Maybe it's like a 12-inch pizza or maybe it's like a 14 or a 16-inch pizza. So we would require a variable for storing the size as well. If it is a pizza, it also needs to have some kind of a topping. So we would need one more variable for topping, one more for cheese and one more for the price. So this is how you would first visualize the entire program, and only after visualizing your program you would start coding. I will come to this concept a little later in detail, but right now let's get going and let's create some of the variables. Let us create the first variable called as customer. The type of the customer is going to be a string, so let us try write str, and the name of the customer would be CC. Let me put C as capital. The next variable would be for my pizza base, so I can say my pizza base. Again, the type is going to be string. This time I want to have a thin base. The next one would be for my pizza size. Now I want my pizza size to be an integer. Suppose I want to eat a 12-inch pizza, so that's what this is going to indicate. The next one would be for my topping. Topping has to be a string and I want to have some toppings of olives. The next one, let us create a boolean saying that extra cheese, and let us create the typing hint. So the extra cheese variable is going to be of the type of bool. So the customer can say yes, they want, false if they don't want. In case they want extra cheese, then we can say true, otherwise it's going to be false. The last one is going to be price. Now since price is going to contain decimal values. So we can say price is going to be a float, and we can say this is for $8.99. Just save it. And now let's try to print all of these values in our terminal. Let me put up one more comment over here. Now, since this program is for accepting pizza orders, let's try to write print statements that would make some sense. So the first one I can say received order from, followed by the name of the customer. Let me save it. The next line we can print some of the pizza details. So we can say print again the formatted string, and then we can say the pizza base would be the pizza base. Then we can say size is going to be pizza size in inches, followed by toppings, and I can write toppings over here. Save this. Now let us try to print if the customer wants extra cheese or not. So we can again say is extra cheese required, and let us put the value right over here, extra cheese. And the last thing we want to print is going to be the price. So we can say bill amount is going to be the price. So I can put the price right over here. Let me run the program, and here we have the output, received order from CC. Let me take this a little down, and now we can start comparing. So you can see we have declared the name of the customer as CC. That's what we have right over here. The base of the pizza is thin, so thin is what we want. The size is 12 and the topping is olives. Do we require extra cheese? Yes, we require. And the total amount is $8.99. Let us have a look at one more alternative syntax of using formatted string. Let me put up a comment right over here. Now this time I am going to construct an entire string which will hold all of these values. In order to save all of this data, let me create a new variable by the name of order details. Is going to be of the type of string. And now this is the interesting part. We can create a formatted string outside the print statement as well. So I can say F and I can put my comma right over here. But I'm going to use triple quotes because I want to create my string which is going to be in multiple lines. So if you just compare your output, you can see we have multiple lines. On the first line we have the statement for received order, the next line has the pizza details and so on. So I want my string to be multi-line. That's the reason why I'm using triple quotes right over here. Now between these triple quotes, let's start adding our values. Now this is pretty simple. I just have to copy from above. Let me just paste this inside. The same thing for this as well. Please note that I am not copying the inverted commas because I already have them outside. Let me put this line, this one as well, and this as well. So what we have essentially done from line number 34 to line number 39 is we have created an entire string and we have saved that string to a variable, and the name of the variable is called as order details. On the next line we can simply print out the order details. So we can say simply print my order details, and that's it. Let's try to run this file, and we have the output. Let me just comment all of this for a moment so that the output is much more clear. Let me clear my terminal, again go back, and let me try to run the file. So now you can see our formatted string is also working. Let us have a look at one more very simple alternative. We just saw that we can create a multi-line string by using triple quotes and assign that string to a variable. But let us ask the question, do we really require a variable? Maybe not. We can simply print out the entire statement. So what I'm going to do is I'm just copying all of this formatted string. Let me copy all of this. Let me go down. Let me write print. And inside my print function, I'm just going to paste everything as it is. That's it. Let me just save the file and let me run it. And as you can see, we have the desired output. You can use any of the string formatting style. There is no right and wrong method in this one. Welcome to a new section. This section is all about decisions, and more decisions. And we are going to learn how to take decisions by the use of flow control mechanisms. That means there are multiple flow control statements such as if and else, while and do, and some other statements. So we will have a look at all of these control flow statements. First thing that I want you to do is go back to your code editor and let's create a new folder right over here. Let me name it as 03 flow control. And the first file that I'm going to create over here is called as drivinglicense.py. Let me put up a comment as usual. Now let's see what's happening. Louis wants to drive a car and he wants to know if he can apply for a driving license or not. So first let me declare a variable called as age is going to be of the type of integer, and let me assign a value of 13 to it. The first flow control statement that I am going to introduce in this video is the if and else statement. Suppose the legal driving age in your country is 16. So right now we can create a very simple if and else blocks. We can say if the age is less than 16, in that scenario I want to print out you are not eligible for a license. But what happens if you are more than 16? In that case, you are eligible for a license. So on the next line, we can simply say else. So that means you are actually more than 16 years old. And let me copy and paste it right over here. Here I can say you are eligible for a license. Let's have a look at what's exactly happening. Python is going to read your file from top to the bottom. On line number 6, it is going to create a new variable called as age and it is going to assign the value of 13 to it. When Python comes to line number 12, it's going to try to evaluate this statement right over here. Let's see what's happening in this statement. My age is 13. 13 is less than 16. So this condition on line number 12 is true. And since this condition is true, Python is going to print whatever which is inside the if block. You can see the line number 13 is indented towards the right. So this is a tab space. So that means this line belongs to the if block. So Python is simply going to print out you are not eligible for a license. And after printing this block, Python is actually going to skip the else part because it's not the case with us. And Python will go to line number 16 where it will exit from the program. Let me just save the file and let me try to run it. So as you can see, we have the output, you are not eligible for a license. Now let's try to imagine what happens after a couple of years. So after a couple of years, the age would be 19. Now let me copy and paste the exact same flow control statement and let me put it right over here. Let me save it and let me try to run the file. So the second time we get the output, you are eligible for a license. And this is the case because on line number 21, you can see now Louis is 19 years old. Let's go back to our code. one thing that I want you to understand is it's not necessary to have an else block. We can simply write an if block. So let me put our comment and let me just copy and paste this block right over here. Let me comment this. Let me comment all of this. So the only thing we have in our file right now is this variable age, which we declared as 13 on line number 6, and we reassign the value on line number 21, and we have this if and else block. Now I'm going to take out the else block and I'm going to left indent this line. So that means we don't have an else block in this condition. This is just the if block, and this is the next line. Let's see what's happening. Let me save the file and try to run the file one more time. So in this case, I'm getting the output, you are eligible for a license. Now let's see what's exactly happening. When Python comes to this line number 32, it's again going to evaluate this statement. In our case, the age is 19, so 19 is not less than 16. And since this condition will evaluate to false, Python is going to skip the if block. And since we are going to skip the if block, Python is not going to print this line. It will simply move to the next line. On the next line, that is on line number 35, we are simply going to print out you are eligible for a license, and that's what we get on our terminal. You can check the terminal one more time. Let me clear up all of these things. Let me run the file one more time. And that's it. You have the output of you are eligible for a license. You can also chain multiple if and else blocks. Let me show you an example for that. Now suppose after too many years, Louis is 100 years old. Let me just go and copy the code from above. So let me just copy this one and put it right over here, and let me uncomment all of this. Here we can start chaining our if and else blocks. So on the next line I can say else and if. In Python we write it as ELIF, that means else and if. So the next condition that I want to check is my age greater than 100. In that case I want to print out you are too old to get a license. Let me comment this one. Now let me try to run the file. Oh, but what is this? We are getting an output saying that you are eligible for a license, but that's not what we want. We want to print out you are too old to get a license. And we have a small bug, and that bug is exactly on line number 45. We are saying that if the age is greater than 100, but right now our age is 100. So in order to make this statement true, we have to say if the age is more than or equal to 100. Now let's save it and let us try to run the file one more time. And this time we have a proper output saying that you are too old to get a license. Till now we have seen very simple if and else blocks. Let's try to expand our knowledge. And this time let me create a new file by the name of alienlicense.py. Here is the situation. Louis desperately wants to drive a car, and he hears that in a planet called as Zortan, there is no age limit for getting a license. So let's see how we can address this situation. Let us create a couple of variables. The first one would be for age of the type of integer, age is 13. The next one for a planet. Planet, the type would be string, and let me assign it to Earth initially. Let me introduce to you a little more complex statements by using and or statements. So let's start writing our compound if and else blocks along with and or. The first case would be if the age is less than 16 and the planet is Earth, in that case I simply want to print out that you are not eligible for a license on Earth. Here you can see I have double equal to. That simply means that this is a comparison operator. We are just trying to compare if the value inside the variable planet is equal to Earth or not. Now let's move on to the next block for the else statement. Here we can say else if the age is greater than 16 and if the planet is again Earth. In that case I want to print out that you are eligible for a license on Earth. But what happens if both of these values are false? What happens if the planet is Zortan, or what happens if the age is less than 16 but you are trying to apply for a license on Zortan? Let's try to create one more condition over here. Let us write an if and else block right over here. So we can say else if the age is less than 16 and if the planet is Zortan. In that case I want to print out you can apply for a Zortanian license because it's valid in the planet Zortan. Let me save the file and let me try running it and let us see what output we are getting. So I'm getting the output that you are not eligible for a license on Earth. So let's get back to the code and let us evaluate what's exactly happening. Let us begin with evaluating all of the if and else block. Let's start with this one on line number 13. Let me put up a comment over here. So this is how the evaluation is taking place. Python is going to compare, is the age less than 16? Yes, my age is 13. 13 is less than 16. So the first statement is going to evaluate to true. So that comes right over here. The next operator that we have is AND. So AND comes right over here. Now Python will go to the last statement. It's going to compare, is planet equal to Earth? So as you can see on line number 7, we have assigned the value of Earth to planet. Hence, this statement also evaluates to true. Earth is equal to Earth. So that's why we have a true over here. And since we have two trues, this entire statement on line number 13 evaluates to true. So we can print out you are not eligible for a license on Earth. And right after this, let me put up one more comment just to explain what's happening. And since this if statement on line number 13 evaluates to true, the execution is going to stop right at this point. Python is not going to go to the next else and if block. Python will directly jump to line number 22 and it will exit from our program. So that's what is exactly happening. So let me put up some more comments right over here. Execution does not reach over here. The same thing for this one as well. Let's do a small exercise. On line number 14, we have tried to evaluate the statement. Let us try to evaluate the statements on line number 18 and line number 21 as well. Let me put up a comment right over here. Now let's try to evaluate this statement. My current age is 13. As you can see on line number 6, we have assigned the age as 13. So the first statement, age is 13, 13 is greater than 16. No, it's not. So we have false right over here. The next operator is AND. So AND comes right over here. The next statement is planet equal to Earth. Yes, my planet is equal to Earth. So we have a true. But in this case, we have one false and one true. So this statement is going to evaluate to false. Let's see what's happening on line number 22. Let me put up a comment right over here as well. So as you can see, the age is 13. 13 is less than 16. So we have a true condition over here. Now the planet. The planet currently is Earth and Earth is not equal to Zortan. So we have false over here. One true and one false is always going to give you a false statement. We can actually try to improve our logic at this time by introducing an OR statement. Remember, in Zortan, even if you are less than 16, you are still eligible for a license. So we don't have to check this condition at all. We can simply say if your age is 16 or if the planet is Zortan, in that case you can apply for a Zortanian license. In this case, the evaluation would be different. My age is less than 16, it's true, and right here instead of AND we have an OR condition. The next is planet is equal to Zortan, so that's again going to be false, true or false. Now this time, whenever we have an OR condition and we have one true and one false, it's always going to evaluate to true. Since we have an OR statement, the true wins over the false. But since the first block is executing, we are not going to execute this block. And just for your reference, let me put all of the AND and OR tables right over here. So these are all of the AND and OR scenarios, but you can do much better. If you are in confusion, just open up your terminal, and I want you to open up the IPython shell. Remember, we have installed IPython at the beginning of the series. If you have not installed, you can simply install by typing pip install IPython. What happens is Python actually comes with a shell. You can simply type Python. This takes you inside a Python shell, and here you can start writing Python commands. For example, I can say 1 plus 2 and I get the output of 3. You can exit this shell by typing Ctrl and D. Now IPython is a slightly better version of this, and it's slightly more interactive, so I prefer to use IPython shell. Just type IPython and go inside the shell. Let me clear up the terminal. And whenever you are confused what statement evaluates to what, you can simply type right over here. Here you can type what happens if I have one condition which is true and the next condition which is also a true. We get a true. But what happens if I have one true and one false condition? We have a false. What happens if I have one true or false? Then also we get a true. What happens if I have a false and also a false? We get a false. Let us try to evaluate one last condition. What happens if I have a false and false? In that case, it also evaluates to false. So you can always come back to this IPython shell and see how the statements are being evaluated. Now suppose Louis migrates to Zortan. Then let's see what's happening. Let me put up a command. Now Louis is no longer staying on Earth. He's staying in Zortan. Let me copy and paste all of this and put it right over here. I'm not going to change any of the logic. Let me just run the file as usual and let us see what output we are getting. Oh, first I need to exit this. You can exit this by pressing Ctrl and D. Yes, I want to exit. Let me clear up my terminal, go back to the file. Let me save it one more time and let me try running it. It looks like we have a small bug and I exactly know what we did wrong. At this point, we did not reassign the value of planet to Zortan. That's what we need to do. So we can say my planet now is Zortan. That's it. Just save your file and let us try to run the file one more time. Now we have the desired output. You can apply for a Zortanian license. Now let's try to see how the statements are being evaluated. So let's see what's happening. On line number 48, this statement planet equal to Earth, this time it's going to evaluate as false. True and false is going to evaluate to a false, and so we are not going to execute this block. Let's go to the new block. Age is greater than 16. no, it's false. Planet equal to Earth, no, it's false because we are staying in Zortan. False and false, we have a false. So Python will go to the last condition. Age is less than 16, true. Planet equal to Zortan, yeah, it's also true. True or a true equals to true. And that's the reason why we have this output as you can apply for a Zortanian license. Let's try to see the next concept in the flow control mechanism. And this time I'm going to introduce you a new concept which is called as looping. We can iterate over things, that is called as looping, and we can iterate by using a for loop. Let me create a new file as usual and let me show what I'm talking about. Here I'm going to create a new file and I'm going to name it as printmyname.py, and let me put up a comment. So this is the situation this time. Now since Louis is staying in Zortan, he has to do things in a Zortanian way. In Zortan, they don't print your name on a single line. They want to print each and every character of your name on a different line. So let's see how we can do that. First, let me create a variable for name and let me assign the type as string. The name is Louis. And this time, let me introduce you one more concept which is called as the for loop. And we are going to use the for loop to iterate over all of the characters in Louis. Iterate simply means that we want to go from one alphabet to another throughout this string. Creating a for loop is very simple. We can simply say for character inside my name. I simply want to print out the character. Let me put up a comment right over here. So on each iteration, we are just going to print a character. Let me save the file and let me try running it. Here we have the output. We have each and every character on a new line, and we are doing this by using a very simple for loop. Now let's see what's happening inside each of the iteration. Here we are saying for character in name. First time the character is L. You can see right over here. We get the output of L right over here as well. The next character is O, U, I, and S. So on each iteration, we are printing a single character on a new line. Let's try to move on and learn one more concept for flow control mechanisms. This time I'm going to show you the while loop. For this, as usual, let me create a new file and let me name it as guessplanet.py. And this time, this is the situation. Now since Louis has migrated to Zortan, his friends from Earth, they are a little curious to know where he is. So Louis decides to write a program that will make his friends guess the name of the planet. For this simple program, I'm going to create 3 variables. First variable would be as a boolean, so I can say correct guess. This would be an boolean. Initially, let me assign it the value of false. The next boolean for guess. So this is the place where we would be storing all of the guesses that his friends are going to make. Initially, it's simply going to be a blank string, and that's it. The next one for the planet. So I can say planet of the type of string. This is going to be Zortan. Let us have a look at the first alternative. The first thing that we want to do right over here is we want to create a loop, and we want his friends to keep on guessing till the time they get the planet right. First, let us see how we can get the input from his friends. The way to get an input is by using another inbuilt function by the name of input. So we can say input, and I can write a prompt over here. Louis says that can you guess my planet, and I want to save the input inside my variable of guess. So I'm just going to the left. The input has to be saved inside my variable of guess, so my guess comes towards the left. Let me save this and let us try to run this and see what's happening. Let me also print out the guess on the next line. Now let's try to run this file and see what's happening. So as you can see, I'm getting the prompt. Lewis says, can you guess my planet? Let me write as Mars, and we have the output. Now this output of Mars is coming from this line, from line number 15. If you are having some issues while running this file from the code runner, then what you can do is, I want you to open up your settings. Let me collapse my terminal. Here I want you to write code runner, and let us scroll a little down. I want you to go a little more down, and I want you to check this option, run in terminal. So make sure that this option is checked. Or what you can do is, you can simply use the Python command. Let's try to navigate inside the folder. Now this time the folder was 03. So you can go inside this folder and you can say, hey Python, I want you to run my program which is called as guess planet. And we have the prompt, and this time it can be Pluto, and we have the output of Pluto. Let's get back to our program. Here we can create our if and else blocks. So we can say if the guess is equal to my current planet, then I want to print out right guess Lewis is at Zortan. Else we can say that I want to print out Lewis says it's a wrong choice, I want you to try again. Let me save this and let us try to run this one more time. Suppose my planet is Mercury and we get the output. Lewis says wrong choice, try again. Let me clear up my terminal and let me try this program one more time. This time I am going to write as Zortan. What's this? We still have the output saying that it's a wrong choice, but that's not the case. We have written Zortan. The issue is this, that we have written Zortan with a Z which is in the small case, but we have saved planet with a Z which is in the uppercase. The point that I want to convey is all of the strings are going to be case sensitive inside Python. Your uppercase Z is not equal to your lowercase z. Let us see how we can handle this situation. We can go back to our if block right here, and we can actually convert from capital Z to a lower z. In fact, we are going to convert the entire string to a lowercase string, and you can do that by using an inbuilt function. Now this function works only with strings, and since we have two strings, guess and planet, we can use that function right over here. So we can simply say guess, I simply want to lower it, and after this I want you to put brackets. So this means I want to invoke the function of lower. I will come to functions a little future in the series, but right now just go with the flow. So what this statement is doing is, it's going to take the guess and it is going to convert it from whatever case it may be to a lower case. We want to do the same thing for planet as well. So here we can say lower along with the brackets. Just save it. And now let's try running this file. Let me write Zortan with a smaller case z. And this time we have the output, right guess, Lewis is at Zortan. Now let's try to improve the logic even more. We don't want to exit this program. We want to ask his friends to keep on guessing till the time they get the guess right. And we can do this by wrapping all of our logic inside a while block. So let's see how to do that. On line number 16, let me make some space, and here I can say while my correct guess is not true. So that means till the time we don't get a correct guess, I simply want to keep on looping. So let me put a colon over here, and after this I want to indent all of this if and else blocks one tab space inside. So now if and else blocks belong to the while loop. Let me save it, and let me try to run the file. But we have a small bug. Let me run the file first and then you will understand what's wrong with it. So here it goes. It's asking me for the name of the planet. I'm writing Mars. So what's this? It's keep on looping. Something's wrong with our program. Let me stop it by pressing Ctrl and C. The issue is we are just keeping on looping. The first thing, Python will go on line number 18. It's going to see, is my Mars equal to my Zortan? It's not. So it will go to the next line. It says that Lewis says wrong choice, try again. So this is what we're getting. And since our while condition is not true, as you can see on line number 6, do we have a correct guess? False. And that's the reason why Python will again go back to line number 18. It's going to see Mars is equal to Zortan. No. So it's again going to go on the line number 21 and print out Lewis says wrong choice, try again. The way to come out of this while loop is we need to have a circuit breaking mechanism. That's why I have created this variable called as correct guess. So right over here after line number 19, since we have a correct guess this time, let us reassign the value of correct guess to true. Now let's try running this file. Let me clear up my terminal. Now let's try the file one more time. So it's saying that, can you guess my planet? Let me say as Mars. Oh no, we again have an issue. Let's see what's wrong this time. Now the issue is we are not asking for a new input after we get a wrong guess. That's why we never have a correct guess. In order to correct this, let me take this line, let me cut it out, and I want to paste it right over here. Let me indent so we have a proper variable. We don't require this print statement now. Let me take it out. And let us see if we can have a running program. Let me put the input as Pluto. It's saying wrong choice. Now this time it is again asking me for an input and is actually waiting for my input. Let me write Mars. No, it's not going to work. Earth. No, it's not going to work. Let me write Zortan. And that's it. We have the right guess. Let me add some comments so that it's much more easy for us to understand what's happening. The first comment goes right over here. So on line number 16, we are just asking the users for their input. The next thing that we are doing, which is right over here, we are just lowercasing all of the strings so that we have a much more correct comparison. Then as a circuit breaking mechanism, we are setting the correct guess variable to true. So this is what is happening right over here. Inside the else block, if the condition is false, then we are going to print this statement. And just to give it a small cosmetic touch, I'm going to put a line just below this. Just save your file and let me try running this file for one more time. So my first planet would be Mercury. We have a very nice output saying that wrong choice, and then we have a line below it. Now this time it's going to be Zortan with a lowercase z, and we have the right output. There is one more alternative way. We don't need to declare this variable all the time. We can simply work directly with the while loop. Let me put up a comment and then let me show how it works. Let me copy and paste everything from above. So let me just copy this. Let me go right over here. Let me paste it. I also want to comment all of this. Once inside the while loop, we have one more alternative which can act like our circuit breaker. Here on line number 33, I can simply say while true. This means that I always want you to start the while loop because true is always true. And on line number 40, instead of saying correct guess is equal to true, I can say break. So that means as soon as we have a condition which is right, I simply want to break out of the while loop. Let me save it and let me run it and see if it is working or not. Okay, so my first planet would be Earth. Wrong choice. The next planet is Zortan, and that's the right choice. Let's try to learn the next flow control statement, and this time we are going to learn the match statement. So let me open up my sidebar and let me create a new file by the name of matchcolor.py, and let me put up a comment. So this is what we want to do. While traveling to Zortan, Lewis, he has packed a lot of stuff, and we want to check if he has anything that matches our favorite color, and we are going to do this by using a match operator. Now please keep in mind that match is a brand new operator which was introduced in the version 3.10. So in case if we have any version below 3.10, it's not going to work. So please make sure you have any version 3.10 or higher. Here what we can do is we can create a variable called as my favorite color, and we can ask the user for an input. So we can say input, and here we can say enter your favorite color. What's wrong with this spelling? Okay, so enter your favorite color. Now let's try to print the favorite color. Let's try to run this file and let's see if it's working or not. So it's asking me for my favorite color. I say it's black and I have the right output. Now let's see how the match operator is going to work. We can write that I want to match on my favorite color, and the first case would be in case if I get the input as black. In that case, I want to print out a statement saying something like Lewis has a black t-shirt. Now suppose the user input is the red, then maybe in that case I want to print something like Lewis has a red car. Suppose my favorite color is yellow. The colons has to be outside the quotes, and I want to print out Lewis has yellow shoes. Now in case the favorite color is green, in that case I want to print out Lewis has a green hat. But what happens if we don't get a match? So in that case we can write like this, case followed by an underscore. So that means the default case would be this one. In case we don't get the favorite color right over here, we can simply print out that Lewis has nothing in, and let me put my color right over here followed by the word of color. Just save it. Let me save the file and let me try to run it one more time. Let me give the input of green. It's working. Let me try to run the program one more time. This time again green. But you can see we are getting the output as Lewis has nothing in the green color. Now this is again because I have entered green where G is capital. While inside the match operator, you can see I am using a lowercase g, and you already know that strings are case sensitive inside Python. Let us tackle this issue, and it's going to be a very simple thing. We can either write over here, I want to match my favorite color and I want to lowercase it first and then I want to match, or we can say on this line I want to say that my favorite color should be equal to my favorite color but in the lowercase. Or even better, what we can do is we can write it write over here dot lower, and let me take out this line, and that's it. If you're wondering why I don't have a type annotation right over here, and the reason is just hover over input, and if you read the documentation, it's saying that the output is of the type of a string. We will look at the syntax when we learn a little bit more about functions. Your MyPy plugin is smart enough to infer that the variable favorite color is of the type of a string, and since your favorite color is a string, we can apply the lower method on our string. You can always write the type over here and it's not going to hurt. So this is also a valid syntax. Let me run the file for the last time and let us check what's happening. Now this time I'm going to say red with a capital R. Now it's a match. Lewis has the red car. Till now we have learned a lot, and I think it's time for us to start writing our game. So what I've done in the background, I've created a file by the name of game save Zortan _1. You can see on the tab right over here as well, and I've added a couple of comments. Let us see now what we are supposed to do inside this game. Now as we remember, Lewis is staying at Zortan, but this time Zortan is under attack. Thanos has arrived and he is going to attack Zortan. Now fortunately Lewis can call his Avenger friends from Earth. So he has made a call, Avengers has received his call, and they are going to send 4 of the Avengers to save Zortan. The 4 Avengers who are going to save Zortan are Iron Man, Black Widow, Spider-Man and Hulk. Each of the Avengers have their own attacking power and they have to fight with Thanos in order to save Zortan. But we have a couple of conditions. Avengers can only attack in pairs. So that means at each given point of time, a single Avenger cannot attack Thanos because Thanos is much more powerful. So Avengers have to team up in pairs of 2 and they have to attack Thanos. And while doing all of this, Avengers only have 3 chances to kill Thanos. Otherwise, Thanos will kill the Avengers and we will lose the game. Sounds interesting, isn't it? But the first thing that I want you to do is not write the code. Yes, you heard me right. I don't want you to write the code first. First, I want you to understand what we have to do and then you can start writing code. In order to understand better, I want to introduce to you a very simple concept which is called as VOC-DTP. It's a very simple concept that I've come up with, and the entire concept is divided into 2 parts. So as you can see, the first part is VOC, the second part is DTP. So the first part simply means to visualize, outline and code. The next part would be debug, test and polish. For now, we would be concentrating on the first part, visualize, outline and code. So as a programmer, always remember, first you always need to visualize before you can code. You don't have to write code immediately. So let's try to visualize what's going to happen inside our game. Since it's a game, we already have some characters. So let's try to visualize the different characters that we have. We have 2 main categories. One category is for the superheroes and the next category is for the supervillains. We have a specific list for the superheroes and those are Iron Man, Black Widow, Spider-Man and Hulk. And for the supervillains, right now we have only a single supervillain and his name is Thanos. So this is where we just simply try to visualize how the game would look like. And now we know the characters. In the next step, let's try to outline how these characters would look like and how they would work. So coming to the next point of outline, since we have characters, all of the characters should have some properties. They should also have some constraints and we should also have some sort of a logic. I have already specified that our Avengers have a fire or an attack power. But if we have an attack power, then we would also require life. And having a property of life would make our job much more simple and we can implement a very simple logic for the game. Now this game also comes with a couple of constraints that we can't forget. The constraints are, the first one that we saw, Avengers can only attack in pairs. So at a given time, only 2 Avengers can attack, a single Avenger cannot attack, and more than 2 Avengers also cannot attack. And Avengers only have 3 chances of defeating Thanos. So this is where we are just trying to outline how our characters are going to look like. The last and the most important part is, can we come up with some kind of logic where we can simulate the attack? Now let's go back to our code editor and let us see how we can translate all of these things in our step number 3. So as you can see, the step number 3 is to actually code. In step number 3, what we are going to do is, we are just going to translate all of these things to a logic, and that logic would be coded with Python. Now let's start with declaring our variables. If you refer our outline, we have a property, and the properties are for your fire or attack power and one for the life. So let's go right over here and let us start creating some of our variables. So we can say the attack power of Iron Man. So I can say Iron Man attack power, and just suppose it to be 250. Now let's start thinking in types. Now since it's a power, I have to do some sort of calculations, so it must be either in integer or in float. For the sake of simplicity, I'm keeping it as integer. The next thing that I want you to remember is, since this is an attack power, we are not going to change the attack power in the future. So no matter even if we are losing or we are winning the game, the attack power of Iron Man is always going to be 250. So just as a stylistic preference, I want to name my variable everything in uppercase. So this would denote that I want to have a constant instead of a variable. Now what do I mean by constant? A constant simply means there is some value which we don't want to change, and that is what we are indicating by writing everything in the uppercase. Now if you just hover over our variable, you can see on the left we have constant. So that means our code editor knows that this is a constant, but we can go further and we can improve our typing. For this, I'm going to import and use something from an additional package. Now what is a package? Package is basically some code that the developers of Python have written, and they have put all of this code inside a library which is called as the standard library. So what I'm going to do is, I want to go to my typing package. So this package lives inside the Python standard library. Please remember that standard library is already built into Python. So from the package of typing, I want to import final, and we can wrap this integer inside final. Now it's very clear that Iron Man attack power, it's not just a variable, it's a constant, and we don't want to change the value of the constant throughout our program. Let us repeat the same thing for Black Widow, Spider-Man and Hulk as well. The next superhero would be our Black Widow, and she has a power of 180. The next one would be Spider-Man. Spider-Man has an attack power of 190. The last superhero would be Hulk, and Hulk, since he is the biggest guy, he has an attack power of 300. Let me put up some comments right over here. So this is where we are declaring our constants, and on the top let me put up one more comment. So this is the stuff that we are importing. Now let's go back to our outline just to figure it out what we are supposed to do next. We have defined the attack power. Now we also need the life. So let me go to the next line, and here I am going to define the life of Thanos, and the life of Thanos is 1500. As you can see, I don't want the life of Thanos to be a constant, I want it to be a variable. That's why I'm declaring everything in small case, and my MyPy is smart enough to infer that Thanos is of the type of integer. or if you want to be explicit, you can always type int right over here. The reason why I don't want it to be constant would get much more clear when we implement the logic for the game. Now let's go back to our outline, and here you can see we have a couple of constraints. The first constraint is Avengers can only attack in pairs. So let us go back to our game, and I want the game users the ability to choose our pairs. In order to give this ability, I am going to create one more variable called as choices, and let me assign it the value of 0. Again, I don't need to annotate as integer because MyPy would be smart enough to infer that my choices variable would always be an integer. After this, let us create a couple of if and else blocks, and let us start creating our pairs for our Avengers. For the sake of simplicity, I'm just going to create pairs in line. So what I mean, the first pair would be Iron Man and Black Widow. The second pair would be Black Widow and Spider-Man. The third pair would be Spider-Man and Hulk. And the fourth pair would be Iron Man and Hulk. But you're free to make the pairs in whatever choice you want. So here we can say if my choice is 1, in that case I simply want to print out that Iron Man and Black Widow are attacking Thanos. The next choice would be choice number 2, and this time I want to print out Black Widow and Spider-Man are attacking Thanos. Next choice would be 3, and this time Spider-Man and Hulk are attacking Thanos. And the last one, if the choice is number 4, then Hulk and Iron Man are attacking Thanos. While doing all of this, let us not forget that we want to ask the user for the choice of the Avengers. So let us implement that logic, and I want to implement that logic before our if and else blocks. So here I can, since we want to ask the user for the input, we need an input block. And let us display a prompt message saying that enter your pair number. We want to assign the input back to our variable of choice. So choice goes on the left, and let me save my program. But as you can see, we have a small bug. So if we just try to hover, you can see that we have an error saying that incompatible types in assignment, expression has type of string, variable has type of integer. So this was what I was telling you about. Variable has the type of integer. Our variable of choice, as you can see on line number 29, we have declared a variable called as choice, and the type of this variable is an integer. But if you hover on input and if you read the documentation, it is actually giving us a string. So this is where when you start thinking in types, it's going to help you to avoid a lot of bugs. To address this bug, it's a very simple solution. We simply want to convert the string to an integer, and the way to do that is by using a cast. Let me just show you how it is done. So I'm going to wrap all of this inside my brackets, and I want to cast all of this into an integer. So what this means is my input is going to give me a string, and I want to convert that string into an integer right over here. Now our types are going to match. On the left it's also an integer, and on the right it's also an integer. Let me save my program and let me try to run it. Suppose I want my pair number 2. You can see Black Widow and Spider-Man are attacking Thanos. Let me try to run the file one more time. Let me go by pair number 4. Hulk and Iron Man are attacking Thanos. So we have some basic logic in place. This time let us display a nice message to the user informing them of all of the pairs which are there inside the game. So before I ask the input, I want to display a nice message. For this I am going to create a new variable called as message, and I am going to assign some string value to it. So let me create a variable called as message, and I'm going to assign some value to it, and this is the value. So please note that I'm creating a multi-line string by using triple quotes, and just before we can show the choices, I want to print out the message. Let us do that right over here. So we can say print and my message. Let me save the file and let's try to run it. And this time we have a very nice message and we can see all of the pairs who can attack Thanos. This time let us go with the pair number 3 and we get the output that Spider-Man and Hulk are attacking Thanos. Let me clear up my terminal and let us go back to our code. Now since this message is never going to change, I can actually make it as a constant. So let me change from the lowercase to the uppercase and here as well. So we have a message in a form of a constant. Let me put up a comment right over here saying that this is going to be one of my helper message and I can utilize this message multiple times whenever I want throughout my program. Now the next part would be, since we have multiple chances of attacking Thanos, we need some kind of a loop. And inside the loop, we can keep on attacking Thanos for at least 3 times. In order to simulate this loop situation, I'm going to use a while loop. So I can just come down over here and just before my print message, I can say while true and let me indent. Sorry, it has to be while, not white, and let me indent all of this thing one tab space inside. So all of this belongs to the while loop now. Now let's see, since we have a while loop, we also need some kind of a circuit breaking mechanism in order to exit. Now let's go back to our outline and see how we can do that. One of the constraints is that we only have 3 chances of attacking Thanos. Another constraint is if we have already lost or we have already won, then we can simply break out and we don't have to play again. So we are going to combine this logic together and come up with a very simple circuit breaking mechanism. So let me go back to my code. Now inside my while loop, we need to have some sort of circuit breaking mechanism. So let me put up a comment. Either we can break out whenever we win or we can break out whenever we lose. So let's write our logic right over here. But before writing the logic, we need to create one more variable and that variable is going to hold our number of attacks. As you can see the constants, we have 3 chances for an attack. So let's save that data inside one variable. Let me go to the top and declare a variable right over here. So this is called as attack numbers and I'm going to assign it a value of 0 initially. Let us go back to the while loop and let us write our winning or our losing conditions. First, let us see the winning condition. So we can say if the life of Thanos is less than or equal to 0, that means we have won. But we need to add one more condition right over here, the second constraint, and that constraint would be if my number of attacks is also less than or equal to 3. Only in this case I'm going to win, otherwise I'm going to lose. And I'm going to print some kind of a message over here. So right now let me just put up a comment that this is for the win. For the else block, that means if we have lost, so we can say if my attack numbers are greater than or equal to 3. Oh, this has to be else and if. Now in case my attack numbers are more than or equal to 3, in that case I'm actually going to lose. Now before I forget, we need to add the break statements to actually break out of the while loop. So let me add them right away. The next thing that we need to do is we want to display a nice winning or a nice losing message. So what I have done is I have already written a nice message which I'm going to paste it right over here just above the message. So the first one would be my winning message and it's going to be you successfully saved Zortan along with a couple of emojis. And since this is a constant, all of this is capital and this is final str. If you want, you can write this. If you don't want, you can take it out, and MyPy is smart enough to infer that it's a constant of the type of string. The next message would be our losing message. So I'm just saying that Thanos killed Avengers and captured Zortan. The reason why I have all of this separately in a constant or in a variable is because in future, if you don't like these emojis, you can simply take them out and you don't have to change all of the logic that you write below. You have to just change one constant or one variable and it's going to reflect throughout your code. It makes our code much more manageable. Let me put back my emojis. I just love them. And go back to our if and else block. Let me remove this and I can say here I want to print my win message and here I want to print my lose message. Sorry, it's going to be lost message. Let me save my file. Now let us go back to our outline and let us see what we need to do next. Now we have to do the most important part, that is how to actually simulate the attack. And fortunately for us, this is the most simplest part. Let's see how we can do that. Suppose you are using the first pair right over here. In this case, what's happening is Iron Man and Black Widow, they are going to attack Thanos. And if we just scroll up, Iron Man has a power of 250, Black Widow has a power of 180, and Thanos has a life of 1500. So when Iron Man and Black Widow are attacking Thanos, we simply want to minus the attack power from the life of Thanos. And since we have two Avengers who are attacking Thanos, we have to reduce the value by 250 and 180 from 1500, and that is how we simulate an attack. So let's go down over here and let us implement that logic. So we can say that my new Thanos life would be my current Thanos life minus my Iron Man attack power and also minus the Black Widow attack power, and that's it. And after doing this, we also want to increment the number of attacks since we already have done one attack. So we can say my current attack number would be my attack number plus 1. So initially, if you see, the attack number is 0, and whenever we have an actual attack, we are going to increment it by 1. And remember, we have a constraint right on line number 49 that we cannot have more than 3 attacks. If we have more than 3 attacks, then we are going to lose the game. Let us do the same thing for our choice number 2, 3 and 4 as well. Let me just copy this. Let me paste over here, and before the attack I have to say that my Thanos life would be my Thanos life minus Black Widow attack power minus the Spider-Man attack power. Let me go to the new line right over here. Again the same thing, let me copy here as well, and then here my Thanos life would be my Thanos life minus Spider-Man attack power minus Hulk attack power. Let us go to the last choice, and here we can say again the same thing. Thanos life would be Thanos life minus Hulk attack power minus Iron Man attack power. Here is my Iron Man. Save it, and that's it. I think we are good to go and we can try out our game. So let's give it a try. Let me take this up a little bit. So the first thing is we have a nice message saying that we have the following pairs. For the first pair, I want to go with the first one, Iron Man and Black Widow. So I just press 1 and enter. So I get the message that Iron Man and Black Widow are attacking Thanos. Now it's asking me for the second pair. Now I can say I want to go with Black Widow and Spider-Man. So I enter my choice number 2. Again we get a message saying that Black Widow and Spider-Man are attacking Thanos, and it is asking me for my third pair. Let me go with Hulk and Iron Man, so I can type 4, and that's it. And unfortunately we have lost the game. Thanos has killed Avengers and he has captured Zortan. Let us play the game one more time. This time I'm going to choose my pair number 4, Hulk and Iron Man, and my pair number 1 and again my pair number 4. And that's amazing. Finally, we have been able to save Zortan. You can see the message right over here. And this brings us to the end of section number 3. Just take a break, have some nice snacks or coffee, and I will see you in the next section. Welcome to a brand new section. This section is all about data structures. Data structures is just a common name for how we can group our data together. And the first data structure that we are going to see is called as a list. Now, since Lewis has migrated to Zortan, he has been making a lot of progress. And in Zortan, people greet each other by saying Zola. So Lewis wants to write a simple program where he can greet all of his friends by saying Zola followed by the name of the friend. You can do this by using multiple print statements, but that is not a very effective approach. What if you have hundreds or thousands of friends? Then you can imagine that using a print statement for each and every friend would get too tedious. Instead, Python offers a much better solution, and that is called as a list. So what we are going to do is we are going to create a list, and after that we are simply going to loop through the list and print a greeting message to each one of his friends. Let's see how to do this. Behind the scenes, I have created a new folder called as 04 data structures, and I'm working in this file called as friends.py. So let's get started with this one. Let us create a variable called as friends. Oh, let me get the spelling right. Now this friends is going to be a list. For creating a list, you have to use open and closing square brackets, and inside this you have to insert all of your elements. Suppose the first friend is CC, and then we have a bunch of other friends Rocco, Chico and Nico. So this is what a list in Python looks like. Now let's see how we can add the type hints to this one. Now obviously this is a list, so what we can do is here we can simply say that friends is a list, and after that let us try and specify what kind of data that our list would be holding. And if you see, all of our data types are strings. So what we can do is we can simply tell that this list is going to be a list of strings. The next point that I want to tell you is all the lists in Python, they always start with the index number of 0. So let me put a comment and then let me try to explain what's happening. So this is how your list will look inside the memory. On index number 0, it will have CC. On index number 1, it will have Rocco. On index number 2, Chico, and so on. Always remember that list will always start with an index number of 0. And this is common across all of the programming languages, not only in Python. The next point that I want to share is, if you see the length, our length is 4. That means we have 4 elements inside the list. So this is the first element, second, third and fourth. So the length of our list would be 4, but the index number would be up till 3. Let's print out the friends and see how they look like. So let me print the friends right over here. And let me run this file. So these are the friends. We have friends right over here. Now let's create a very simple for loop and greet all of his friends. So let me start by putting some comments. Let me take this a little up, and we can use a very simple for loop. So we can say for friend in my list of friends. For every friend, I simply want to print out a greeting message saying that Zola followed by the name of my friend. Let us run this file. So here we have the output Zola CC, Zola Rocco, and so on. Let's see what Lewis wants to do next. So Lewis simply wants to count his number of friends. So remember, I just told you that the length of this list would be 4. And we can find that out by using an inbuilt function which is also called as length. Let me show you right over here. Let's print out friends length, and inside the curly brackets I can find the length by using the inbuilt function called as length, len, and let us pass our list to it. Just save and run your file, and here we have friends length is 4. And that is what we were expecting. Let's see what Lewis is doing next. Oh, He had a fight with Nico and he wants to unfriend him. Now let's see how we can take Nico out of our list. So we can see Nico is the last element inside our list, and we can remove him by using an inbuilt function which is called as pop. Let me show you how it is to be done. So I can say I want to unfriend, and I can say from my list of friends I simply want to pop the last value. Now since Nico is the last element, we can use this method to remove an element from the list. Let us print out the friend that we have just unfriended. So we can just say unfriend, and let me put my curlies, and let me put unfriend over here. Let me also copy and paste our friends, and let's see how our list is looking right now. So let me just paste it right over here. Just save it and try to run your file, and here we have it. We have unfriended Nico, and this is how our current list of friends looks like. Let us go back and let us see what Louis is up to this time. So Louis has made a new friend by the name of Zico. So let us see how we can add Zico to our list. We can add Zico by using another inbuilt function by the name of append. Let's see how to do that. So here I can say in my list of friends I want to append one more element, and that element is called as Zico. Let us copy this line and paste the new list. Let me save it. Let me try to run my file, and here you can see we have Zico at the back. One more thing you must have noticed that I am not assigning a variable for this operation. So for example, I am not doing something like this. The reason is if you just hover over append, you can read the documentation. This function returns none. That's why I'm not assigning it back to my list of friends. But at the same time, if you hover over pop, now this method of pop is actually returning back a string. That's why I'm using a new variable on the left to collect that data. But for this, we can't do the same. Now let's see what Louis is up to. So let me go down right over here and let me paste a new comment. This time Louis wants to know who is his third friend inside the list. Let us check it out. Let me open up my terminal. So this is how our latest list looks like. So CC is the first friend, Rocco is the second one, and Chico is a third friend. So let's see how we can get this value from our list, and we can do that by using our indexes. So just remember, let me scroll a little up. Our list, it has a set of indexes, and always remember that the index is going to start from 0. Now let's see how we can get the third value from our list. So here I can simply print out from my list of friends, I simply want the friend who is on the index number 2. Now remember, we are using 2 because our index starts at 0. Let me put a comment. So let me save this file and let us try to run this file. And here we have the output. Chico is the third friend inside the list. Let us go back. This time Louis again had a fight, but this time he had a fight with Rocco, and we need to remove Rocco from our list as well. Let me scroll to our list. If you see, Rocco is inside our list at index number 1. So let me show you how we can do this. So let us go down. Here I can say from my list of friends, I simply want to remove Rocco. That's it. Let me copy this line and paste it over here, and let us try running this file. So this is our new list. We have CC, Chico and Zico. We have successfully removed Rocco from our list. Let's see what Louis is up to next. And it seems like Louis and Rocco have become friends again. So let's see how we can add Rocco back to our list. Remember that Rocco was at index number 1. So we want to insert Rocco back to its original index. So let me show you how it is to be done. So here I can say in my list of friends, I want to insert at index number 1 the element of Rocco, and let me try to print out the list one more time. That's it. Just run your file, and this is the new list. We have Rocco back at index number 1 inside the friends list. Let's go back and let's see what Louis wants to do next. So this time Louis wants to confirm if Rocco is in the friends list or not, and we can do this by using our if and in syntax. So what we can say right over here is, if Rocco in my list of friends, then I simply want to print out, yay, Rocco is in the friend list, or else I can print out some other message. So let me save the file and let us try to run this one. Now since Rocco is inside the list, we get the output that, yay, Rocco is in the friends list. Let us go back. Let's see what's happening next. So this time Louis patches up with Nico as well, and this time Nico has become his number 1 friend. So we want to add Nico back to our list of friends. But since Nico is his number 1 friend right now, we want to add Nico at the beginning of the list. So we can do this by using the same syntax right over here. We can use the same syntax, and let's see how to do this. So we can say, in my list of friends, I want to insert at index number 0 the element of Nico, and let us print our list of friends as well. So let me go down, let me paste, and let us run this file. And here you can see we have Nico as the first element inside our list. Let us go back. So this time Louis wants to sort his friends in alphabetical order, and luckily it's very simple. We simply have to say friends, I simply want to sort it. Let me copy and paste the list of friends, and let us run this file. And here we have the output. You can see all of the names are sorted alphabetically. So CC Chico comes first, Nico, Rocco, and finally we have Zico. Let us go back. So this time Louis doesn't really like this ordering, and he wants to reverse the order. Luckily this too is very simple. Let me just copy this and let me paste it right over here. And instead of sort, I simply have to say I want to not remove, I want to reverse. That's it. And let us run this file. And this time we have the new list, and you can see the first element is Zico and the last element is CC. Let's see what's happening next. And this time Louis again had a fight with Nico, and we again need to remove Nico from our list. But before removing Nico, let us have a look at our list. So this is how our list is currently looking like, and Nico is the third element, or you can say the index number of Nico is 2. So keeping this in mind, let us go back and see how we can remove Nico from the list. Earlier I have shown you 2 different methods of removing elements. One was this one of remove, and the first one was with the pop method. Let me show you one more method again by using pop. Let me copy all of this and let us go down. Now since Nico is at index number 2, what I can do is I can tell Python that I want to pop an element from an index number 2. Let us save and let us run this file for the last time. And here we have it. We have unfriended Nico, and this is our updated list. The next data structure that we are going to learn is called as a tuple. Behind the scenes I have created a new file which is called as subjects.py, and let's see what's going to happen. Let me collapse my sidebar. Now it's time for Louis to go to school, and he has to choose his subjects. But his school wants to make sure that once a student chooses their subjects, they won't be able to change it. So let's see how we can do this. And the way to do this is by using a tuple. So you can imagine tuple to be like a stricter brother of list. Once you create a tuple, you can't change or modify it. So let's see how to create a tuple. So let's say that we want to create a tuple by the name of subjects, and the way to create a tuple is by using the round brackets. And inside of this round brackets, we have to add our elements. Suppose the first subject would be maths, the next could be science, then we can say history. Now remember that similar to our list, our tuples will also start with index number 0. That means the index number for maths is 0, for science it would be 1, and for history it would be 2. Let us see how to add typing for this one. So here I can say that subjects is obviously a tuple, and the way to define its type is we have to put our square brackets, and since tuples are strict, we have to define the data type for each and every element. So for example, in this tuple we have 3 elements and the types are string and string. So here we can say that the first element is a string, the second is a string as well, and the third is a string as well. Suppose we had one more element. So if I say that we have one more element as 13, now the data type of 13 is an integer. So what we would have to do is, after this, we would have to say that my fourth element is of the type of integer. So make sure whenever you are creating a tuple, you write the data type of all the elements inside the tuple. Let me take it out. This is not required for our example right now. Let me also put up a comment, so saying that the index number for maths is 0, for science is 1, and history is 2. Let's see what we can do next. So let me take it a little up. So this time Lewis wants to count his number of subjects, and you can do that by using the inbuilt function called as length. So we can use a simple print statement, and we can say that number of subjects, then inside our curly brackets we can use the inbuilt function called as length, and let us just pass our tuple inside. So we can say subjects. Let us run and see the output, and here we can see that the number of subjects is 3. Let us go back. The next thing that Lewis has to do is Lewis has to sign up for all of the subjects. So let us create a very simple loop, and by using the loop we can sign up for all of the different subjects. You can use your regular for loops to iterate over the tuple. So here it goes. We can say for my subject in my tuple of subjects, for each iteration I can simply print out a statement saying that Lewis is signing up for, let me get my spelling right, this to be signing up for, and inside the curly brackets we simply have to say for my subject. Let us run and let us see the output. So here it is. Lewis is signing up for maths, and then for science, and the last one is history. Let us go back. So this time Lewis wants to see which is his second subject, and we can do that by using our index. So as I just mentioned, tuples also have indexes. So the second subject would have an index of 1. So let us try and print it out. Here I can simply say that I want to print out from my tuple of subjects the subject at my index number 1. Also let me put up a comment saying that since the tuple starts from index 0, we are using 1. Let us see the output. So you can see the second subject is science. Let us go back, and this time let us see what's happening. So this time the school wants Lewis to take another 3 subjects to get his full credits. Now what happens is, once you create a tuple, you can't add different elements to a tuple. For example, when we saw list, we could append elements to the list, but you can't do for the tuple. Then what can you do? Well, you can add 2 different tuples and create a new tuple. Let me show you how it is to be done. So suppose the additional subjects which he has to take would be a new tuple, and we can say that the new subjects are English, Python and physics. On the next line we can create a new tuple called as my total subjects, and we can simply add our tuple of subjects plus our additional subjects. So now we have a new tuple which has all of the subjects together. We can also try and print it out. So here let me just say that my all subjects would be my tuple of total subjects. Let us run it, and here we have the output. You can see we have English, Python and physics at the back, and also we have maths, science and history. So this is our newly created tuple. Let us go back and let's see what's happening this time. Now it's obvious that out of all of the subjects, Louis loves Python and he wants to make sure that Python is inside his list of subjects. So we can check for an element inside a tuple by using our if and else blocks. So let us see how to do that. So here we can simply say that if Python is in my tuple of total subjects, if this is true, then I simply want to print out, yay, Louis is going to learn Python. If not, so we can say else, we can print out, oh no, no Python for Louis. So let us save this file and let us try to run this file for the last time. And here we have the output. Now since Python is inside our tuple, we get the output of, yay, Louis is going to learn Python. Now let's try to learn about dictionaries. Dictionaries are of mapping type. That means the dictionary are going to map a key to a value. So let us see what's going to happen right now. Behind the scenes, I've created a file called as marks.py and I'm working in this one. So let me collapse my sidebar and let us see what's happening. Now this time Louis has given his exam and he has received his marks. So let us see how it looks like. So we can create a dictionary and call it as marks. The way to declare a dictionary is by using your curly brackets. And inside of this curly brackets, let us give the key and the value pairs. Suppose the first subject is maths. So we can say maths and he scored maybe 80 marks in his maths. So this is how your key and value pairs look like. On the left of the colon, we have a key and on the right we have a value. Let us give a couple of more key and value pairs. Suppose the next subject was science and suppose he fared 82 marks in science, and let me add a couple of more subjects as well. So this is his score, and on the next line let us print out all of these subjects. So we can say with my formatted string, my marks, and let us say marks. Let me save the file and let us try running this one. And here is the output. So this is the dictionary that we just created. Now let us go back and see what's happening next. Let me put some comments right over here. So this time Louis wants to check all of the subjects. Now remember, inside our dictionary, the keys are our subjects. So let us see how we can just get the keys out of our dictionary. The way to do that is very simple. Let's also use a for loop to print out the keys. So we can say for my subject in my dictionary of marks, I want to get all of the keys, and for each iteration we simply want to print out the subject. Let us run this file and see the output. So here is our output. We have all of the keys inside our dictionary. Now let us go back and let's see what's going to happen next. So this time Louis wants to check all of his marks. Now again remember that the marks are the values. So anything on the right is the value, and this time we want to get only the marks out of our dictionary. So let us do that. And the way to do that is similar to something like this. So let me show you how it is to be done. So we can say for my score in my dictionary of marks, I want to get only the values, and for each iteration I just want to print out my score. Let me save the file and let me try to run this file, and here we have the output. Here you can see we have all of our score. Let us go back. Let us see what Louis wants to do next. So let me take a little up. This time Louis wants to check out all of the subjects and marks together. That means we simply have to print out our key and value pairs. So let us see how we can do that. Again, let us use our for loop to print out the key and values. So we can say for. Now since the keys is for the subjects, let us call subject, and on the right we have score, so we can say score. In my dictionary of marks, I want to get all of the items. Now this method is going to return our key and values which we are capturing right over here, and for each iteration let us print out our key and value pairs. So here I can say that my subject, and here we can say the score, and we can say the score is out of 100. Just let me save it and let us try running this file. And here we have the output. Maths, Lewis scored 80 out of 100, science was 82, history was 78, and so on. Now let us go back and see what we have to do next. And this time Lewis wants to check if he has passed in all of the subjects or not, and the passing marks are 50. So let us see how we can do this. We can do this by using our for loop and our if and else blocks. So let me show you how it is to be done. So here we can say for my subject and my score in my marks dot items. For each iteration I want to check if my score is greater than or equal to 50. Only in that case I can print out that subject and I can say pass. Else if the score is less than 50, that means he has failed, and so we can print out the name of the subject. So we can say the subject and we can say failed. Let me save it and let me try to run this file. So let's see how he has done in his exam. Maths is a pass, science is a pass. Oh, but what's this? English is a fail. So let's see what's going to happen next. Let us go back to our file. So let me take it a little up and let me put some comments. So Lewis thinks that there was some kind of a totaling mistake for his English paper, and he's asking for an revaluation. And after the revaluation, the new marks are 70. So let us see how we can update the values in our dictionary. So this time what we want to do is, let me show the dictionary. So this time we want to update the marks of English from 35 to 70. So let us see how we can do that. So let me go down, and here I can say that from my dictionary of marks I want to go to my key of English and I want to assign the new value of 70. So this is how you can update the values inside your dictionary. On the next line we can print out the value. We can say something like this: Lewis scored, inside the curly brackets we can say the marks of English in English. So let me just save this and let me try to run this file. So here we have the output saying that Lewis scored 70 in English. Now here what we are doing is this syntax. We are just retrieving the value from our dictionary. So this syntax means that from my dictionary of marks I want to get the value for the key of English. Let us see what is happening next. Now this time Lewis also took an exam for geography and he scored 78 marks. So this time what we have to do is we have to create a new key and a new value this time. Remember, we don't have geography inside our dictionary of marks and we have to create one right now. So what we can say is, for my dictionary of marks I want to create a new key for my geography and I want to assign the value of 78 to it. And Lewis also wants to check if he has passed in all of his subjects or not. So let me go up and I just have to copy all of this and let me paste it right over here. So here is the output and it looks like Lewis has passed in all of his subjects, and you can also see we have the output for geography as well. Now let us go back. So let's see what's happening this time. So this time his friends on Zortan, they want to know how much Lewis scored in Python. So let us see how we can retrieve the values from our dictionary. So let me show you the first alternative. Let us create a new variable called as our Python score, and we can retrieve a value by using the syntax. So we want to say that go to my dictionary of marks, and I want you to get the value for the key of Python, and that's how you retrieve the value. But this syntax has a couple of limitations which I'll explain it shortly. But first let us print out these values. Let us print out the marks in Python. So we can say Lewis scored the Python score in Python. Let us run this file, and here we have the output saying that Lewis scored 98 in Python. Now let me show you one more alternative method. Let us go down and let me put one more comment, and here again we can say that the Python score, and this time we can use one more alternate syntax. So what we can say that from my dictionary of marks, I want to get the values for my key of Python. And on the next line, let us print out the same statement. So let me copy from here and let me paste it right over here, and let us run our file. So this time you can see we again have the output. Now let us go back and let's see what's happening next. So let us see what's happening this time. And this time his friends from Earth, they want to know how much Lewis scored in Java. So what we can do, we can create a variable called as Java score, and we can say from my dictionary of marks, I want to get the value for my key of Java. And on the next line, let me try and print it out. So what I can say that I want to print out Lewis scored Java score in Java. Let me save and let me run this file, and this time you can see that we have an error, and the error is called as key error. Now this is because our dictionary does not have a key called as Java. So this is one of the limitations of using this syntax right over here. Let me put up a comment saying that this syntax will throw an error. Now let's see a better way of getting the values from our dictionary, and that is by using the get method that we just saw. On the next line, let me paste some comments, and I want to comment this out because this is always going to fail. So let us go down right over here. Let me take everything up. So here let me create one more variable called as our Java score, and let us use the get syntax. So what we can say is from my dictionary of marks, I want you to get the value for the key called as Java. Let me save this, and this time let us try to print out this same sentence. So I can just copy and let me paste it right over here. Let us run this file and see the output. So this time we get the output of Lewis scored none in Java. So let us go back and let us see what's happening. Now this method of get returns a none if it can't find the value, and that's what is happening right over here. One thing that I forgot to show is how to use the typing for this one. So let us go up and let me show you how to write the type hints for our dictionary. So this variable of marks, this is a dictionary, so we can say this is our dictionary, and inside the brackets we also have to mention the types for our keys and values. So here we can say that since all of the keys are string, so the key is going to be of the type of string, and the values are integers, so we can just say int, and that's it. Now let us go down and let us see what's happening. So here on the line 108, this get method is going to return none, or if it finds a value, it is going to return our score, which is of the type of integer. Now let us use our if and else blocks to print something meaningful. So here we can say that if my Java score is none, that means if we can't find the value, then we can simply print out saying that Lewis did not study Java, and else we want to print out this statement. So let me take it inside my else block, and let us try to run this file, and here it is. We have the output of Lewis did not study Java. Now let us go back. The last thing that I wanted to show you is how to delete some elements or how to delete the key and value pairs from our dictionary. Now suppose we want to delete the key and value pair for English, then we can say that I want to delete from my dictionary of marks English. So this is how the syntax goes. Let me remove the extra quotes. Now let us print our marks one more time. So I can say marks and let us print out the marks right over here. Let me run this file. So this is how our dictionary is looking, and you can see we have deleted English from our dictionary as well. The last thing that I wanted to mention for this one is the lookups in dictionary are extremely fast. What do I mean by lookup? So on line number 108, we are getting the value from our dictionary. So this is a lookup. When we were working with our list or tuples, we were using indexing. But for a dictionary, we always use the key to get the data. And this is the reason why lookups in dictionary are extremely fast. And we would be using dictionaries and lists in our final project as well. So make sure you go through them a couple of times and understand what's exactly happening. There is one last thing that I wanted to show you. So if you open up the code from the GitHub, so this is the code from GitHub. Inside my folder 04 data structures, this is the file which I'm referring to. It is called as dictionary. Now let me collapse my sidebar. So here I have one more sample dictionary called as pizza, and you can see the structure is very interesting. The first key value pairs we have integer as the key and string as the value. For the next one we have a float as our key. The next one is even more interesting. We have a tuple as the key, and the last one we have a boolean value as a key. Now the interesting part is this is a valid syntax. So let me copy all of this and let me paste all of these things inside my IPython shell. So here it is. Let me paste it right over here and let us try to print out our pizza. So you can see we have a valid output. So what happens is you can use any data type for a key as long as it is immutable. So our strings are immutable, integers are immutable, floats, booleans are also immutable, and we also saw that our tuples are immutable as well. So you can use all of these data types as your keys. The way to retrieve the data is similar. So let me give you some small examples. So here we can say from my dictionary of pizza, I want to get the value for the key of 10. And here we have the output. The same thing can go for our float as well. So we can say 8.99, and here we have the value. You can do the same thing for our tuple as well. Let me copy this tuple, and here I can say from my dictionary of pizza, I want to get the value from the key, and this time the key is a tuple. So let me paste it right over here, and you can see we have the right output. But before you make such a dictionary, I want you to wait and think. Do you think that this is going to be a developer friendly dictionary? I would rather think not. I just wanted to show you that you can create such dictionaries, and all of this is valid syntax. Now let us have a look at the next data structure, and this data structure is all about being unique. The name of this data structure is called as a set. For this video, I have created a new file called as teach.py, and let's get working with this one. So let's see what's happening this time. Lewis wants to show some of his English magic to Zortans, but Zortans, they can't understand what's happening, and they want to see each alphabet separately. That means they want to understand each unique alphabets. So let's see what's going to happen next. So suppose we have a magic word called as abracadabra. Now let's see how we can get the unique alphabets from our string. So on the next line, let us create one more variable called as unique alphabets. And in order to get unique alphabets from this string, we have to create a set. And the way to create a set is by using the cast which is called as set, and let us pass our variable magic words to this one. Now if you hover over the variable unique alphabets, you can see the type is set and the set is of the type of a string. So let's write that over here. So this is a set and the data type is for the string. Let us print out our unique alphabets. So here we can say I simply want to print out my unique alphabets. Let me save it and let us try to run this file. And here we have all of the unique alphabets. So let me take this a little up. So inside our word of abracadabra, the alphabets of C, D, A, B and R, all of these alphabets are unique. Let us go back. Let's try one more time, and this time let us use a sentence. So we can create a sentence like this: the big blue sky and the big blue ocean. And let us see the unique alphabets. So I can reuse my variable of unique alphabets, and this time let us create a set from our sentence. And let me copy and paste this line right over here. Let us run the file, and this time we have an output. So all of these alphabets are unique inside our sentence. But what happens if we want to check the unique words instead of the characters? Let us see how to do that. The first thing that we would need to do is we would want to convert our sentence into a list of words. So let us see how to do that first. Let me create a variable called as my word list, and we can simply split our sentence by using an inbuilt function by the name of split. So we can say that I want to split my sentence. Now if you see, the type of sentence is a string, right? So on a string you have a method called as split. So this is going to return a list of all of the words inside the sentence. Let us try to print it out on the next line. So let me say my word list is my variable of word list. Let us try to run this file. So here you can see we have the list of all of the words inside the sentence. So the next step is to actually create a set out of our words list. And once we create a set, then we can know all of the unique words inside our sentence. So let's do that. Let me put up a comment saying that we need to extract the unique words. Let us create a variable called as unique words, and we simply need to create a set out of our word list. Let us try to print it out. So here I can say my unique words and the variable of unique words. Let us try to run this file. So here you can see the unique words are big, ocean, blue, sky, the and. Also one more thing that I want you to note, that at the beginning and at the end we have the curly brackets. So you can see right over here, for the beginning we have a curly bracket and at the last we have a curly bracket. So this symbolizes a set. In the dictionary we had key and value pairs inside curly brackets, but for a set we only have values. So let us go back. So this time Zortans, they are really impressed and they want to see if we can add a couple of more words to our set. So let's see how we can try and update our set. So what we can do is, let us take the existing set for our unique words and we can say that we want to update with the new values, and here we need to pass an iterable. That means you can pass a list or a tuple or any other data structure which is iterable. So let me paste some values right over here. So let us see if we can update with the new values of big, blue and sky. Let me copy this line and let me paste it right over here, and let me try to run this file. Now if you see, nothing is happening. This line and the line before that, they are exactly the same. Now what's happening? Now since set is all about being unique, we can't add the existing values to the set. If we go back to our code, big, blue and sky, these words are already existing inside our set. So nothing is happening. Let me put up a comment. If you try to update your set with existing values, nothing is going to happen. Now let us try to update with some other words which are not there inside the set. So I can say my unique words. I want to update with the new values, and this time I want to pass the value of green and grass. Let me copy this, paste it right over here. Now let us try to run our file, and this time you can see we have the words of green and grass inside our set. Let us go back and let us see what's happening next. Let me put some comment right over here saying that something does happen. Now what happens is Zortans, they don't like the word of grass. Now let's see how we can remove the word of grass from our set. So we can simply say that from my list of unique words, I want to remove, and I want to remove the element of grass. And again, let me copy and paste all of this, and let us save and let us run our file. And you can see that this time we have removed the word of grass from our set. Let us go back. Now I just wanted to let you know that you can do a lot of other operations on sets, such as your union and intersections and so on, but I would not be covering all of those inside these tutorials. Now let us see how we can use data structures for our game. So behind the scenes, I've created a new file called as game save Zortan 2, and this is the file, and I've also pasted a couple of comments right over here. So this time what is happening is the war is just getting more intensified. This time the army of Thanos is also arriving, and since it's going to be a very intense fight, our program will automatically choose superhero and the supervillain, and our Avengers have exactly 3 chances to defeat Thanos. Now this time, since we have already seen data structures, we are going to create a nice data structure for our characters. But first, let me go to my old file inside my folder number 03, and let us copy a couple of things from here. So let me copy from here till my last message. Let me go back, let me collapse my sidebar, and let me paste it right over here. So this is our current file. Now let's get started. This time we are going to define a nice structure for our characters. You have seen that our character has an attack power and Thanos had life. But this time our supervillains are also going to attack our superheroes. So all of the characters will have a property of life as well. So let us see how we can do all of these things. Let me create a constant and let me call it as Iron Man. And the most ideal data structure would be a dictionary. Now since with dictionary we can have the key and value pairs, it makes much more sense to use a dictionary right over here. The first key would be for the name of the character. So in this case the name is Iron Man. The next key would be for the attack power. So I can say my attack power. The value is of the type of an integer, and the attack power of Iron Man is 250. The last key and value pair would be for the life. So you can say I want to have a key for my life. Let's give him a life of say 1000. Now let us see how we can define the types for this one. Now obviously Iron Man is a dictionary. Now if you see the structure of our dictionary, all of the keys are strings, but for the values sometimes we have a string and sometimes we have an integer. So let us see how we can define the types over here. Since all of the types, the keys are going to be string, so we can say the key is of the type of a string, and the value we can say it's either going to be a string or it is going to be an integer. So this is how you define the types for our Iron Man. Now since this is going to be a constant, we can wrap all of these things inside final. So let me do that. Let me put my brackets and let me say final. But what happens is typing all of these things again and again becomes so boring. So what we can do is we can use a small trick, and that trick is called as in typing alias. So what I can do is, let me just cut out all of these things, and here let me create a new variable called as character, and I can define the type right over here. So what I'm doing on line number 20 is I'm defining a new variable called as character, and I'm assigning the type to it. So what I can do on line number 22 is I can simply say that Ironman is a constant of the type of character. So this is going to save us a lot of typing. Let me put up some comments over here. Now let us go down and let's create some more superheroes. So let me just paste it right over here. So what I have done is I have created 3 more superheroes. One is Black Widow, Spider-Man and Hulk, and I have also assigned values to each of our superhero. Let me put a comment right over here. So this is for our superheroes. Similarly, let us also do for our supervillains. So let me put a comment right over here. So I can say that let us define a supervillain called as Thanos. The type would be final, and we can say character right over here. And let's create our dictionary. So we can say the name is Thanos, the attack power is 1500, and life is 1500. Similarly, let me create some other supervillains as well. So I've created a couple of more supervillains. One is Red Skull and the last one is Proxima. Now since we have a structure for our character, we don't need all of these things. So let me take it out. The next thing is, let us create a list of all of our superheroes and all of our supervillains. So let me put up a comment and let us create a list for our superheroes, and we can say this is going to be a list. So I can put my square brackets. The first is our Iron Man, next is Black Widow, next is Spider-Man, and last is the Hulk. Now let us see how we can define the typing for this one. So superheroes is a list and the type is of the character. Let us go down and let us create one more for our supervillains as well. So I can say that my villains is again going to be a list of my character, and let us create a list right over here. The first is our Thanos, then is for the Red Skull, and last is for Proxima. Let us go down and let me put up a comment right over here that choices and attack numbers, all of this are our helper variables. Let me take this out and let me take this out as well. That's not required. Now let us go down and let us see how we can implement the actual attack. The last time we had used a while loop. This time I want to show you a for loop, and I also wanted to show you a new keyword. That keyword is called as range. So first let me type and then I will try and explain what's happening. So I can create a for loop saying that for attack in my range of 3. Now let me try to explain what's happening. If you remember, we have a constraint that Avengers can attack only 3 times, and that's what I'm doing right over here. Let me open up my IPython shell and let me try to explain over there. So range is an inbuilt keyword inside Python. So we are typing as for my number in my range of 3, I simply want to print out my number. Let's see what kind of output we are getting. So we get the output of 0, 1 and 2, and after we get 2, our for loop is going to stop. So that means our loop ran for 3 times. This was the first, this was the second, and this was the third time. So this is where I'm trying to implement our constraint of maximum 3 attacks. So here our for loop will run for exactly 3 times and then it will exit. Let's see what we can do next. Now since this is a very intense fight, our program has to choose a superhero and a supervillain randomly. So let's see how we can do that. First let me put up a comment, and here again I want to show you one more function which is built into Python, and that is called as random integers. So what's going to happen is for each iteration of our for loop, we want to choose a superhero and a supervillain. And remember, our superheroes and supervillains are lists, and lists have indexes, right? So for Iron Man, the index number would be 0. For Black Widow, the index number would be 1. Spider-Man would be index number 2, and Hulk would be index number 3. So what we are going to do is we are just going to generate a random index number, and we are going to take that superhero out of our list of superheroes, and similarly for our villains as well. But before we can generate a random integer, first we need to import that functionality. So here I can say from my package of random, I want to import something which is called as random int. Let us go down and let us see how to use this. Let me go to my IPython shell and let me give you a small demo right over here. Here I can say from random, I want to import my random integer, and let us try and see the output of random int, and let us pass the values of 0 to 10. So this time we get an 8. Let us try running it one more time. This time we have a 3. This time we have a 7. So you see that we can randomly generate different numbers. So let's see how to use this inside our program. So here I can say that for each iteration of the for loop, I want to generate a random integer, and my starting index would be 3 and my last index would be 3. Now let's see why I'm writing 3 over here. The first time we want to generate a random integer for our hero. So let me create a variable called as hero index and assign the value right over here. Now let's see what's happening. If you see our list of superheroes, we have 4 elements. That means the length is 4, but the index number is 3. That is why I'm writing 3 right over here. Let us generate a random integer for our villain as well. So let me create a variable called as villain index, and I can use the same function random integer. I want to start at 0 and at the max I want to have 2. That's because the length of villains is 3. Now let's see what we can do next. So what we are doing on line number 54 and 55 is we are just generating a random integer number. The next thing is we can use that integer number to get a superhero from our list. So let's see how to do that. So let me put up a comment saying that we have a couple of more helper variables, and I can say that I want to get my current superhero from my list of superheroes, and the index number is the randomly generated number which we have stored in the variable of hero index. So that means on line number 54 we are just generating an index number, and on line number 57 we are using that index number to get a superhero from our list of superheroes. Let us do the same thing for our villain as well. So here I can say that my current villain would be from my list of villains from the index of my villain index. Let us try to print out the values and see what's happening. So here I can say I want to print out my current superhero, and I want to print out my current supervillain. Let us run this file. So here is the output. For the first iteration we have Iron Man and Proxima. For the second iteration we have Black Widow and Red Skull. For the third iteration we have Iron Man and Thanos. So you see, for each time we have a different pair who is going to attack each other, and that's what we want. So let us go back to our program. Let us display a nice message right over here. So let us say I want to print using my formatted string. The first thing I want to display is my attack numbers. I can say my attack, and let us also display the names of our superhero and our supervillain who are going to fight. So I can say inside my curly brackets that my superhero, and let us also get the name. Now remember that current superhero is a dictionary, and we can get the values by using our key and value syntax. So I can say that I want to get the value of my key of name, and then we can say that is going to fight with. Here we can display the name of our supervillain. So I can say my current villain, and I want to retrieve the value from my key of name. Let me save it. Let us take out this line, it's not required now, and let me try and run this file. So this time we have an output. For the first attack we have Black Widow who is going to fight with Red Skull. The next time we have Black Widow again and she is going to fight with Thanos. The last time Spider-Man is going to fight with Thanos. What we can do right over here is, instead of displaying 0, we can start from 1. So let me go back, and here I can say attack plus of 1. Let me save it and let me try to run the file. So this time we have a much better output. Let us go back. So here, before we can attack, we also need to calculate the total life. So what's happening is, for each iteration of our for loop, we have a superhero and we also have a villain. So we need to calculate the life of our superheroes as well as our supervillains. For that we would need 2 more variables. So let me go right over here and create 2 new variables right over here. So the first one would be for our hero life and initially give it a value of 0. The next one is for our villain life. Again, let us set it to a value of 0. Now we don't require this variables because remember we are using the function of range, so we can simply take them out. It's not required. Let me take it up. Let me save my file and let us go down right over here. Let me put up a comment saying that first we need to add the life for each iteration. So I can say for my life, and for each iteration what I want to do is, this is my life of hero and I want to add the life of my current hero to my hero life for each iteration. So I can say my hero life plus my current hero, and from my current hero I want to get the value of his life. Let us do the same thing for the life of villains as well. So I can say my villain life is equal to my villain life plus my current villain, and I want to get the value for life. Now what we can do is, we can also use our shorthand syntax. That means we can take this out and here we can say plus equal to. So this means the exact same thing. Let me do it for the villain life as well. So let me take it out, plus equal to. Now you see that we have an error right over here, but for now just ignore this error. All of these errors will go away when we implement these characters by using classes. Now let's see how to implement the actual attack. So let me put up a comment. Now what is going to happen is, our villain is going to attack the hero. So what we need to do is, we need to minus the attacking power of the villain from the life of the hero. So let us do that right over here. So I can say that my hero life would be my hero life, and minus I want to have the attacking power of my villain. So I can say my current villain, I want to get the attack power. We can use our shorthand syntax right over here as well. So here I can take this out and I can say minus equal to. Let us do the same thing for the villain life as well. So here I can say my villain life minus equal to the current superhero, and I want to get the attacking power of my superhero. Now let's see what to do next. So this attack is going to happen for 3 times, and after the attack is done, we need to see if we are winning or we are losing. So once we are out of the for loop, let us print a nice separating line. So let me put up a comment and let us print a nice separating line. So I can say equal to multiplied by 70. So what this is going to do is, it is simply going to repeat the string of equal to 70 times. Next, let me take it a little up and let me put up a comment. So this time we want to check if we are winning or if we are losing, and the logic for this is very simple. If the life of the heroes is greater than or equal to the life of the villains, that means the Avengers have won. So let us do that right over here. So we can say if the hero life is greater than or equal to the villain life, then we simply want to print our win message. Else that means we have lost. So let us print out the lost message. That's it. Let me save my file and let me try running this. Amazing, we have a nice output. So here you can see that we attacked 3 times. The first time Spider-Man attacked Proxima, the second time again Spider-Man attacked Red Skull, and the third time Black Widow attacked Red Skull. But unfortunately Thanos killed Avengers and he has captured Zortan. Let us try playing one more time. So let me play one more time. Okay, so this time we have saved. It's so amazing. Welcome to the last video in this section. Now this is an extra video and I want you to come back to this video after you learn about classes. I am putting this video right over here just for the sake of completeness. In this video we are going to learn about enums. So behind the scenes I have created a file called as choices, and let us see what's going to happen. Now enums are the perfect data structures whenever you want to create multiple choices or varieties. So let's see how to do that. The first thing is we need to import enum. So we can say from my package of enum I want to import enum, and let us import auto also. So I'll explain what is it all about. Suppose you wanted to create choices for different pizza sizes. So let us see how to do that. So I can say my class of my pizza size. Now this inherits from my class of enum. Let me put up some documentation, and here we can say that my first choice would be for a small size, and we can assign it a value of 8. The next choice could be medium. It could be at 10 inches. Then we have one more for large. It could be 12. So what this simply means is we have created an enum of pizza size and we have 3 choices: small, medium and large. Now let us see how to work with this enum. So let me go down. Let us create a variable of choice, and suppose the choice of the pizza size could be medium. So we can say from my enum of pizza size, I simply want the medium value. Let us print out the value on the next line. So I can say print, and I can say 1 order for. Now in order to get the value, we can say from my enum of choice I want to get the value, and then I can write inch pizza. So let me save this and let me run this file, and we have the output 1 order for a 10-inch pizza. So let us go back. Let us create one more enum for colors of a t-shirt. So I can make a class, and the class is for color. This also inherits from my enum. Let me write some documentation. This is for my t-shirt varieties, and here I can say that my first choice is red, and I can give it a value of red. The next could be blue and green. Let us also try to print out the values. So let me go right over here and let me copy this line. Let me go down, let me paste it right over here, and here we can say 1 order for my colors. Suppose we want to have green dot, we can get the value right over here, and this becomes my t-shirt. That's it. Just save and run your file, and here we have the output 1 order for a green t-shirt. Let us go back. Let us create one more enum. There may be times where you don't require a value. Let me show you one example. Let me create a class called as role. We can inherit from enum. Now suppose you want to create different roles for your staff. It could be a associate, it could be a supervisor and so on, and you don't want to assign values to them. But what we can do is we can automatically give them values. Let us see how to do that. Suppose the first role is for an associate. We can assign it a value by using our imported function called as auto. Now remember, on line number 8 we are importing auto, and that's what we are going to use right over here. So what this auto is going to do is, the first time it is going to assign the value as 1. The next time it is going to assign the value of 2. So suppose we have one more role for a supervisor and we assign it to auto. So this time the value of supervisor would be set to 2. Suppose we have one more role for the manager. Now this time the value of manager would be 3. Let us try and print it out. So I can say print from my enum of role, I want you to go to my manager, and I want you to print the value. Let us run this file, and here you can see that the value of manager is automatically set to 3. Welcome to a brand new section. This section is all about functions. Till now we have used inbuilt functions such as print, and in this section we are going to learn how to create our own functions. But before we can create our own functions, I wanted to talk a little bit about functions. The main goal of a function is for your data processing. You have some sort of an input. This input goes inside your function. Your function processes the data, and finally we would like to have some sort of an output. So this is your ideal function. You take an input, you process it, and you give back an output. But in real life, it's not so simple. So let's try learning more about functions. So let us go back to our code editor. Behind the scenes, I have created a folder called as 05 functions, and this is the file called as greeter.py. Let us see what's going to happen right now. So this is a very simple program for greeting, and the people in Zortan, they greet each other by saying Zola. And Louis wants to write a program where he can greet his friends in Zola. So let's define a function, and the way to define a function is by using the keyword called as def followed by the name of the function. So we can say the name of my function is greeter, and this function accepts one argument, and we can call that argument as anything. In this case, I'm going to call that argument as name, and then you put your colons, and inside of this you have to write the body or the logic of the function. You can also write some sort of a documentation, and you can do that by using your triple quotes. So you can say that this function greets Zortan. Let us go to the next line and let us print out a greeting message. So what we can do is we can simply print out a message. We can use our formatted string, and then we can say Zola followed by the name. Now let us see how we can define the types for this function. We can say that this function of greeter accepts one argument, and we can define the type right over here. So we can say my argument has to be the type of a string, and since this function returns nothing, so we can say that this function is going to return none. Let's create one more function called as main. So you can say this is my main function. This function does not accept any arguments, and this function returns nothing. Here we can create a list of all of the friends. So I can create a variable called as friends, and let me assign some values to it. So these are all of the list of the friends, and we want to greet all of these friends. We can create a very simple for loop, and using the for loop we can call this function. Let me show how it is to be done, but before that let me add the types for this as well. So friends is a list, and the data type is a string. On the next line we can say that for my friend in my list of friends, for each iteration I simply want to invoke the function of greeter and pass a name. So what we can say right over here is for each iteration I want to call the function of greeter, and I simply want to pass the friend each time. Now the reason why we have created a main function is just by sake of convention. We always like our programs to start with a function which is named as main. Now let us see how to use this function. You need to invoke, or you need to call this function in order for our program to run. So on the next line we can invoke our main function, and the way to invoke is by just writing main along with the brackets. So whenever you write the brackets, that means that you want to invoke the function. If you just write like this, it means an assignment, but if you want to run, that means you want to put the brackets. So let me save this and let me try to run this file, and here we have the output. So we have Zola CC, Zola Rocco, and so on. We just saw how to write a function, and in this video I'll show you how we can write a slightly better version of our greeter function. First let us go back to our diagram. Now in an ideal world, we would like to take one input and we would also like to give back an output. But let us have a look at this function called as greeter. We are taking an input, but we are not returning an output. So let us see how we can create a better version of this. So behind the scenes, I've created a file called as betagreeter.py, and let us get started with this one. Let us go back to this file and let me copy all of these things. So let me copy right from here. Let me go back to this file and let me paste everything right over here. Let me collapse my sidebar, and this time let us try and return something. So instead of just printing Zola followed by the name, we can actually return this value. So let me take out the print statement, the bracket as well, and here I can say that I want to return my new string. So what this function is going to do is it is accepting one argument and it is transforming that string into a greeting message, and we are returning that string as well. Now since this function is returning a value, we also need to change the type over here, and the type is string. So what happens is when we were using the print function, we were causing something which is called as a side effect. But this function is a more pure function. It takes one input and it gives back one output. Now it is the responsibility of the caller function of how to handle the return data. Let me show you what I mean by it. But first let me write some comments. So let me go right over here and put me some comments saying that the caller function is responsible for the return data. And here I can say that this function transformed the original string to something useful, and let us change the documentation as well. So this function is going to return a greeting message. Now let us go down and let us see what's happening. On line number 25, we are invoking the function of greeter, and our main function is responsible for calling this function. That means conceptually you can call the main function as your caller function. That means main is calling greeter, and now it is the responsibility of your caller function. That means it is the responsibility of your main function of how to handle the return values. Now this pattern is very useful. What if you wanted to check for the return values? You can check for the return values and you can do something with it. Let us have a small example right over here. Let me put up some comments over here. Now suppose Louis finds Chico to be cute. So what we can do is we can say for each iteration, if Chico is in the output of my function of greeter, so greeter and friend. Now remember, our function of greeter is returning back a string, and if that string contains Chico, then we can print out something like this. So here we can say that friend is cute, or else we can simply print out the message as it is. So here we can simply print our greeter and friend. So what's happening is for each iteration, our function of greeter is returning back some values, and that value is Zola followed by the name of the friend. So for the first iteration, the return value is Zola CC, the second time is Zola Rocco, and the third time is Chico, and so on. But since the function of greeter is returning us data, we can handle that data in multiple ways. So first let me run this file and then let me try and explain you again one more time. So here we have the output that Chico is cute. So what's happening on line number 27 is, let me open up my IPython shell. So here I can say if Chico in Zola Chico, then we have the answer as true. If we say something like this, Louis in Zola Chico, the answer is false. And that is what we are doing on this line. Suppose the output of this function is Zola Chico. That time we simply want to print out a message saying that Chico is cute. So basically what we are trying to do is our caller function is handling the response of greeter in multiple ways. Let's have some more practice with our functions. For this video, behind the scenes I've created a file called as weight.py, and let us see what's happening. Now since Lewis is staying in Zortan, gravity works differently over there, and this time we want to calculate how much you weight in Zortan, and this is the formula to convert the Earth's weight to Zortan's weight. Let me go down over here and let us define a function which is called as calculate weight. This will accept one argument which we can call as weight. We can define the type as a float because your weight can have decimal values. So let me write the type is a float, and this function will also return the float value. Inside the body of the function, we can have one single return statement, and we can say that I want to return, and here we can calculate the weight by using the formula. So we can say the weight plus of 32 divided by 8. Now let us try and print out the weight. So let me write a very simple print statement. We can use our formatted strings. So we can say you weigh, and inside the curly brackets let us invoke the function. So I can say calculate weight, and for example let's pass 60 kgs, and then we can say kgs on Zortan. Let us save this and let us try running this program. So here we have the output saying that you weigh 11.5 kgs on Zortan. Let us go back. I wanted to show you one small trick. What happens if we want to display exactly 2 decimal places or 3 decimal places and so on? The way to do that is right over here. So here we can say that I want to display my 2 decimal places for the float. Just save your file and try running it for the last time, and here we have the output. So you can see we have 2 decimal places. Let us have a look at the next example. This time I am working on this file called as fly.py, and let's see what's happening this time. Now we just saw that gravity in Zortan is much less as compared to Earth. So what happens is if you weigh 15 kgs or less, then you can actually fly on Zortan. So what Lewis wants to do is Lewis wants to see which of his friends can fly. So let's see how to work with this one. And there is one very important concept which is called as single responsibility principle. And let us see what do I mean by this principle in this video. So as a convention, let us create our main function first, and from there we will create functions as we require them. So let me define my main function. So I can say my define and main. This function does not take anything and it returns none. So I can write none over here. Now inside of this function, let us create the friends of Lewis. So let me create my dictionary of friends and let me assign some values to it. So here we can see that we have a couple of values. CC is weighing 54, Rocco is weighing 88, and so on. Let us also write the types for this one. So friends is my dictionary, the keys are strings, and the values are integers. What we can do over here is instead of just declaring integers, we can also write a float. So in case if we have a decimal value in the future, we can easily handle it if we declare it as a float. Next, let us create a function called as flying friends and see which of the friends can fly. So I can say my function of flying friends, and we just have to pass the dictionary of friends. Now let us go up and let us start creating our functions. So as you can see, there is one small constraint, and that constraint is you have to weigh 15 kgs in order to fly. So what we can do is we can create a constant. So let me call the constant as maximum flying weight, and we can assign it a value of 15. Let us also define the type for this one. So since this is a constant, it has to be declared as final, but before we can write final, we need to import it. So here I can say that from typing I want to import final, and here we can use the keyword of final. So our maximum flying weight is a final, and the type we can define it to be a float as well. Now let us go down and let us create the function for flying friends. So here we can say that define flying friends. This takes one argument. Let us call that argument as friends, and as you can see on line number 28, we are passing the argument of friends, and the type of friends is this one. It's dictionary, string and float. So let me copy this right from here and let me go back to my line number 18. So we can define the type right over here. So this friends is going to be a dictionary, and this function is not going to return anything, so I can just write none. Let me also write some documentation for this function. So what this function is going to do is, this function is going to display all of the flying and non-flying friends. Now remember that this function is creating a side effect. This function is not going to return anything. That's why we can say that this function creates a side effect. Now let us go down and let us define the body of this function. So here what we can do is, we can use a for loop to iterate over the friends and see which of the friends can fly or not. So I can say for the name and earth weight in the dictionary of friends, we want to get all of the items. Now remember that the keys are the names. So if you see right over here, the key is the name. That's why I'm naming this parameter as name, and the values are the weight. So that's what I'm calling as earth weight right over here. So for each iteration, the first thing that we want to do is, we want to calculate the weight in Zortan. So let me create a variable called as Zortan weight, and here we need to calculate. But for calculation, let us create another function called as calculate weight. So let me write the function first and then we will create it. So calculate weight would be my function, and I need to pass my earth weight to it. Now let us go up and define this function. We have defined this function in our last video. So let me open up that file right over here. So the file was called as weight.py, and I just have to copy this, go back to my current file. Let me collapse my sidebar and let me go to the top, and we can paste it right over here. Let me also add some documentation. So what this function is doing is, this function is calculating your weight in Zortan. So this is an example of data transformation. It is taking a weight in kgs and it is returning the same weight but in Zortan in weight. You can also say that this function is a pure function since it takes one input and gives back one output. Now let us go back to our function of flying friends. So on line number 36, we are able to calculate the weight in Zortan. Now the next thing to do is, we just need to check if we can fly or not. So here we can say that if, and here we need one more function to check if we can fly or not. So first let me write it and then we will create the function. We can call that function as can fly, and we need to pass the weight in Zortan. So let me pass my Zortan weight. Now let us go up and create this function as can fly. So just let me go right over here and I can define my function as can fly. This function accepts weight and the type would be a float, and this function is going to return a boolean value. Let me write some documentation for this as well. So the only responsibility of this function is, it is going to say if you can fly or not. That's why we have the return value as the boolean. So this function is also a very nice example of data transformation. So you can see that we are accepting a data which is of the type of float, then we are transforming that data and we are transforming from a float value to a boolean value. Let us see how we can write the body of this function. Now the body of this function is very simple. We just have to say that we have to return if my weight is less than or equal to our constant of maximum flying weight. So what we are doing is, we are basically composing functions where each function has only a single responsibility. For example, this function of can fly, the only responsibility of this function is to say you if you can fly or not. Now, the only responsibility of this function, calculate weight, is just to transform the weight from the earth to the Zortanian weight. Now let us go back. On line number 47, we have created this function can fly. Now this function is returning a bool value, so we can use it with our if and else blocks. Let me take it a little up. So here we can say that if the friend can fly, then we can simply print out a nice statement saying that here we can put the name and then we can display the weight in Zortan, and then we can say kgs can fly on Zortan. Else, that means the friend can't fly. In that case, let us print out another statement saying that the name followed by the Zortan weight can only walk on Zortan. Let us save it and let us try running this file. But before we can run this file, we have to invoke our main function. So let me go at the bottom, and here I can say that I want to invoke my main function. So I can say main followed by our brackets. Let me save it, and now let's run this file. So here we have the output. CC, the weight is 10.75 in Zortan, so she can fly. But for Nico weighs 16.75, so he can only walk on Zortan, and similar with Zico as well. So getting back to our program, what we have done is we have seen how to create functions which can have a single responsibility principle. Now let us understand one more very important part of functions, and that is how we can work with variable arguments and variable keyword arguments. Let me create a file over here and let me name it as arguments and keyword arguments. That means ARGS and KWARGS for short. Let me put up some comments. The first thing that I want to show you inside this program is all about unpacking. First, we will see how we can unpack a couple of data structures in Python, and once we understand unpacking, then we can move to the variable and the keyword variable arguments. So the first thing that I want to show you is all about unpacking. Suppose you have a tuple like this, Louis and Zappa. You can unpack the values of this tuple in a single line. So on the left, I can say that my Louis would be my first name, so I can write F name, and Zappa would be my last name, so I can say L name, and that's it. This is called as tuple unpacking. Louis would be assigned to this variable and Zappa would be assigned to this variable. Just to confirm, let us print out the values and see what we are getting. And you can see we are getting the right values. Now let's see how we can unpack a list. Suppose you have a list like this and I want to unpack this list. But while unpacking, I only want the first value inside a variable and I want all of the rest into a separate list. We can do this by using a special syntax. So I can say first, then I can say star, rest of the values is equal to my list. So let's see what's happening. The first value, that means CC, is assigned to this variable, and Rocco, Chico and Nico inside a list is being assigned to this variable. You can name the variables whatever you want. Let's try to print out the value and check if we are getting the right output or not. Let me run the file, and here you can check the output. Let me take it up. The first value is CC, and that's what we are getting right over here. Rest is a list of all of the remaining values, Rocco, Chico and Nico. That's what we have right over here. Next, let us see how we can unpack a dictionary. Suppose we have an existing dictionary like this. So this is for specifications, type is dynamic, optional static typing, and it is found everywhere. Let us create a new dictionary and let us try to unpack the existing dictionary into it. So let me call the new variable as lang, and I can say name is Python. Now I can unpack the entire dictionary right over here by using a very special syntax. So I can say star star followed by the name of the dictionary that we want to unpack. So the name of the dictionary is specs. That's it. Let us print it out and see what we are getting. And as you can see, we have the right dictionary. So the name is Python, and here you can see we have unpacked the entire other dictionary as well. Now let's go back to our program. Now let's try to think of a situation where we would use this functionality. Suppose we have a function, and this function has to accept a known number of arguments. At that time we can use this functionality. Now suppose we have a function called as unknown friends, and we don't know the number of friends that we are going to get in the arguments. So here I can say that we are going to receive variable argument, and that variable argument I can declare by writing star and the name of the variable. As a convention, whenever we are getting variable arguments, we name that variable as args. Now let's go to the body and see what we can do with this one. Let's try to simply print out the values. So I can say for my friend in my arguments, I simply want to print out my friend. Oh, it has to be friend, not friends. So this looks good. Now let's see how we can add types to this function. By default, Python is going to pack all of the variable arguments inside a tuple. So essentially what's happening is this argument is going to be of the type of tuple. And since this function is not returning anything, this is going to return none. Let us invoke this function on the next line. So I can say my unknown friends, and here let me pass a couple of friends. So I am passing an unknown number of friends. Now adding type hint to this variable, it's a little tricky because by default args is a tuple, but we can say this tuple is of the type of string, and that's it. This is how we would add type hints to our variable arguments. This simply means that our variable of args is a tuple and the data type inside the tuple is of the type of string. Let us try to save this file and let me try to run it, and we have the right output. We can see all of the friends right over here. So all of these friends are coming from this line right over here, line number 33. Now similarly, we can also accept keyword arguments. Now what do you mean by a keyword argument? First, let me write the program and then I will explain what exactly I mean by a keyword argument. So let me put up a comment. So suppose we have a function called as unknown product, and this function accepts a variable keyword arguments. So that can be denoted by 2 stars, and by convention we always name the variable as KWARGS. That means keyword arguments. Now let's see what we can do inside the body of this function. Now what Python is going to do is it is going to pack all of the keyword arguments in the form of a dictionary. So we can simply print out the key and the value from our keyword args dot items, and let us print it out. I can also write this in a short form, V for value and K for the key, and here I can simply say I want to print out my key and my value. Now let me try to invoke this function by passing keyword arguments. So this is the place where all of the things are going to get cleared. So I can say my unknown product, and the keyword arguments would look something like this. Name is equal to pizza, price is equal to 3.99, topping is equal to olives, and so on. So you can see all of the arguments are in the form of the key and the value, the key and the value. So that's why we call this variable as a variable keyword argument. By default, it's always going to be in a form of a dictionary. Now let's see how we can add types to this one. Now adding types for this one is really very tricky. If you see our keyword arguments, the first one is a string, the next one is a float, the last one is a boolean. So we don't know what kind of argument we can get inside the dictionary. So this time what we can say that the values can be anything. So I can write the type as any, and let me import any from our typing library. So on the top I can say from typing I want to import any. So what this really means is, since we don't know the value of the type of the dictionary, we are going to accept any kind of a value. And since this function is not going to return anything, we can say that the return type is none. Let's try to run our program, and here is the output. Let me just take it up. So for the variable keyword arguments, we have name, price, toppings, and extra cheese, and that is what we have right over here. Now let's see how we can combine both of these concepts together. That means let us combine the variable arguments and the variable keyword arguments in a single function. So let me put up a comment over here. Suppose I have a function called as invoice, wherein I am supposed to generate an invoice for a product, but I don't know what is the product. I don't know the characteristics of the product. Then how do I handle this situation? So let's see how we can define the function. The first argument can be the name of the product. So I can simply write as product. The type is going to be a string. After that, since we don't know what the product is all about or the different varieties of the product, we can simply write that we can also accept a variable argument right over here. Now suppose the user gives an argument in the form of keywords. We can handle that situation as well by using our keyword argument. So we can say double star keyword and args. And this time let us simply print out our product arguments and our keyword arguments. So I can say I want to print out my product. Let me copy and paste. Then I want to print out my arguments. Then I want to print out my keyword arguments. Now since this function is not going to return anything, so I can say that it's going to return none. Now let's try to invoke this function. So let me go down over here. I can say invoice. My product could be sneakers. Now suppose the sneakers are available in black and white color, so I can give a variable number of arguments. So I can say black and white. We can also define a couple of keyword arguments over here. Suppose we know the name of the brand, so we can say my brand is equal to, maybe it's Nike. The category would be my Air Jordans. Price could be $899.99. In stock would be a boolean value, and let me assign it a value of false. The sneakers are not in stock. Let me save my file. So as you can see, my formatter, which is black, it automatically formats my file. Now let me save the file and let me run it for the last time. And here we have the output. So let me just take this down. The product is our sneakers, so that's what we are getting over here. Now this arguments, by default this is going to be a tuple, so that's why we have a tuple over here. And the keyword arguments, this is always going to be packed as a dictionary, so that's why we have the last line as a dictionary. There is one more important concept that I want to cover, and after that we can move on to our game. This concept is called as your local and global variables. For this, I want you to create a new folder right over here, and I want you to call that folder as Scratchpad. You can utilize this folder for writing small programs and for doing small experiments. I always create and use a Scratch folder. Let's create one file inside of this folder, and let me name it as variable scopes. Let me put up a heading right over here. So we are going to talk about global and local scopes. Before that, let us try to understand one more concept. All of these files that we are creating, These files are technically called as modules. So in the world of Python, all of these files are modules. Now let's go back to our file. Inside our module, if we declare a variable like this, num is equal to 10, that means this variable has a global scope. That means anyone inside our module can use this variable. Any function or any functionality or any variable inside the module can use this variable. So let's create a function called as print global num, and this is simply going to print out our number. Let me save it and let me invoke it right over here. So I can say print global number. We can do a slight improvement over here. We can use a formatted string and we can say global number is, and this is my number. Now let us try to execute this file, and we have an output saying that the global number is 10. Now let us see what happens if we declare one more function and if we declare the same variable inside that function. So let me create a new function by the name of print num. This does not accept anything, and inside this function let me assign a value of 20 to the variable of num, and let us try to print out and see what values we are getting over here. So I can use my formatted string. My local number is num. Let us invoke this function and let us see what we are getting. Let me run this file, and here is the output. Now watch closely what's happening. On line number 8 we have declared that the num is 10, and on line number 16 we are saying that num is equal to 20. Now what happens is, whenever Python sees we have the same variable, Python is going to create a new variable called as num, and this variable is available only inside our variable of print num, and that's it. So this is also called as variable shadowing. Now please keep in mind that this variable shadowing can introduce a lot of bugs, and these bugs can be really difficult to debug. Just to demonstrate, let me go right over here and let me say I want to print my num. Let me save it and let me try to run it. So here you can see the global num is 10, but on the second line the local number is 20, and this 20 is coming from our line number 17. So this variable is accessible only inside this function, and it is not valid outside. Outside, only this number that we have declared on line number 8 is visible. That's why we are getting the output of 10 right over here. Now let us see how we can access this global variable and how we can do some operations on it. Let us create a new function by the name of increment number. Here we simply want to increment our number by 2, so we can say my num plus equal to 2. But what's happening right over here is Python is seeing that we are doing some sort of an operation on num. So Python is going to create a new variable. We want to increment the global num. So we have to explicitly tell Python that, hey Python, I want you to use the global num, and that's it. Let me put up some comments. So I have a comment for this one, and this one is my function or my local scope, and this one for my global declaration. Let me save it. Now let me increment the number and then we can print it out. So let me say that I want to increment the number. Let me save it and let me try to run it. So this time you can see the global number is 12. Now let's see one more behavior of the global number. So here let me create a new function by the name of increment my local num, and here I am saying that my new number is equal to my existing number plus of 10, and Let me print out my new number right over here. Now can you tell me what is going to be the output of line number 30? Well, we don't have to guess, we can simply run the program and let's see what output we are getting. So let me invoke the function right over here. So I can say my new function, I want to invoke it. Let me save the file and let me run it. So as you can see, I'm getting the output as 22. Let us see what's happening right over here. So as you can see on line number 29, the value inside num is 12. You can see that's what it is. And since we are creating a new variable and we are trying to assign value to the new variable, Python is taking this num from the global scope. In the global scope, the value is 12 and we are trying to add 10. That's why the new number is 22. In the next video, we will go back to our game and let us see how we can divide all of the logic into small functions. Now let's see how we can use functions inside our game. So I want you to just copy this file from folder number 4 to our folder number 5, and I want to just rename this file from number 2 to number 3, and that's it. And let me also change the documentation for this module. In this video, we are going to concentrate on two main things. The first concept is called as dry. That means don't repeat yourself. What this means is whenever we have some kind of a logic that is repeating, at that time we want to take the logic out and put that logic inside a function, and we can keep on using that function wherever we require it. The next one is what I've already shown you. This is called as single responsibility principle. That means we want to define our functions in a way that one function will ideally do one job at a time. Let's see how we can do all of these things. Let me go down over here. So here you can see that we have a list of all the superheroes and all of our supervillains. So what I can do is I can create a function that will return the list of all of these superheroes and supervillains as well. Now, why do we need to do this? The answer is we want to isolate parts of our program. Suppose you are working in a team and you don't want any other developer to add or subtract from your list of characters. So that's why we need to have some sort of an isolation. So let us create a function for superheroes and supervillains as well. Let me put a comment right over here. So this block is going to be for my superheroes. Let me define a function called as get all superheroes. This is not going to take anything, and let me take all of these things inside my function. And since I'm going to return a list of superheroes, I will also cut my line from 51 and I'll put it inside my function, which is right over here. I also need to return my list, so I'm going to use the keyword of return and I want to return my list of superheroes. Now since my function is returning a list of characters, so the return type of my function would be like this. So this function is going to return a list of characters. Till now I have been using this keyword of final because I just wanted to show you that whenever we type everything in capital, that symbolizes a constant and we don't want to change the value in the future. But these days your code editor and MyPy is smart enough to infer that if we write everything in capital, we can actually skip writing final. So I'm just going to take it out. What I can do is I can just leave final on this line number 40 just as a reference for you, and let me take it out right over here, and this one and this one. Let me save my file. If you just hover over any of the variable, you can see that we have the word of constant. That means MyPy and your code editor, they are able to correctly infer that this is a constant. Let us create one more function to get a particular superhero. In this function we can get all of the superheroes, but what happens if we want to get a particular superhero? And remember, this is a list of superheroes, so we can get a particular superhero if we know the index. Suppose the index number is 1, so we can return Black Widow. If the index number is 3, then we can return Hulk, and so on. So let's create a function to return a single superhero. Let's create a function right over here. So I can say define a function called as get superhero. This function is going to accept one parameter called as index of the type of integer, and let us see what this function is going to return. This function is going to return a character, but what happens if we can't find a character? In that case, we also have to return none. So this function is either going to return a character or it is going to return none. Let's see how we can implement the logic. Let me add some documentation right over here. But before we can get a superhero, we need the list of our superheroes. But that's pretty easy. We just created an entire function for this. So I can just say that my superheroes is equal to the function get all superheroes, and that's it. We have the list of all our superheroes. Now let's see the logic of getting a single superhero from the list of superheroes. We already know how to work with indexes, but this time we have to be a little more careful. What happens if we get an index number which does not exist? That time our program will panic and it will exit, but we don't want this kind of a behavior. Let me go to my IPython shell and let me show you what I'm talking about. Suppose I have a list called as my characters would be A, B, C and D. Here you can see the length is 4. So I have 4 characters, so the length is 4, but my index number stops at 3. So this is my index number 0, index number 1, index number 2 and index number 3. We don't have a index number 4. Now what happens if I say I want to get characters on my index number 4? This is going to cause an error. Let's see what's happening. So as you can see, we have an error, and the error is the index is out of range, and we want to avoid this situation inside our program because we don't want our program to panic and exit. So let's go back, and here we can say if my index, so if my index is less than the length of my list of superheroes, only then I can have the right index number. So here I can say I simply want to return from the list of superheroes the superhero at the given index. Else we have some issue, and here I can return none because we can't find a superhero. Let me just save my file. Let's do the same logic for our supervillains as well. Let me put up a comment. These blocks are for my villains. Let us define a function get all villains. This is going to return a list of my characters, and let me take all of these things inside, and then I also want to return my list, so return villains. Then we want one more function to get our single villain, so let me copy and paste this block. So this goes right over here. This becomes from superheroes to villain, and that's it. So now we have a way of getting a particular character and how to get a list of our characters. Now let's see where we can use this logic. The place where we want to use this is right over here on line number 98 and 99. Here you can see we first generate a random index, and after that we want to get a superhero given that index. Let me use the function right over here. But before we can use this function, as you can see we have a block for the attack. We can create a function for the attack, and we can isolate this functionality as well. So let's start doing that. So let me add a comment saying that this is the main logic for the game, and I can define a function called as attack. This is going to return nothing, so I can say none, and let me take all of these things inside my function. So all of these things goes inside my function. Let us change this logic. So this becomes I want to get superhero from the given hero index, and this becomes get my villain from the given index. Just save a file, and you can see we have a bunch of errors. Let's start addressing these errors one by one. First thing that I want to change is this variable. What I mean to say attack is the attack number, so we can improve the name of the variable from attack to attack number. Let me change right over here as well. So as you can see inside my print statement, I'm using this variable. So this also needs to be changed from attack to attack number. There is one more finer point that I want you to think. If you see at the definition of our get superhero, we are returning a character or none. So what happens if we don't have a superhero or if we don't have a villain? In that case, we can't have a fight. Let's create some logic to handle this as well. So here after this line, I can say if I have a superhero and if I have villain, so my current villain, only in that case I can do something. Let me write a comment over here. So if we have a superhero and we have a supervillain, in that case we are going to have the attack. Else, that means we don't have a superhero, we don't have a supervillain. That means we have an error. So let me print out a message saying that error, no superhero or villains to fight. Now let us go to this line number 104. What happens if we have a valid hero and a valid villain? Then we need to have an actual attack. So all of this logic from line number 108 to 117 should go right over here. But we are going to create one more function to simulate the attack. If you're wondering why do we require so many functions, the answer is for flexibility. If in the future you have some more characters, if you are fighting scene changes, then you can change only a single function and the changes would be reflected throughout your program. So we want to have our program as modular as possible. That's the reason why we are creating so many different functions. First, let me invoke the function and then I will define the function. So the function would be called as simulate attack. Simulate attack. Now let's see what we need to pass to this function. The first thing that I want to pass is my attack number. Remember, we can have only 3 attacks, so that's why we have the range of 3 over here. So I can say the first parameter I want to pass is my attack number. Then obviously we need the superhero and we also need the supervillain. Now let's go down to line number 107 and let's create this function. So let me copy all of this. Let me go down, let me create a function. Let me say that define function, put my quotes. Let me add a comment. I also need to adjust the spacing because this is out of format. Now let's work on this function. So here I don't need the word of current. This has to go, this also has to go. It has to go from everywhere. So let me do a multi-select. So this looks good. Let me save my file. Everything is looking really good. Let me put a comment right over here. So this is a place where we are setting the live. This is where we print some nice message, and this is the place where the actual attack is taking place. But I'm not really happy with this logic. Here we are manually adding and we are manually decrementing. Let us create functions for this as well. You must be thinking that I have gone crazy. Why do we require so many functions? Let me ask you a question. Suppose tomorrow the logic of the game evolves and you have some bonus attacking power or you have some bonus life. Then what do? So at that time you simply have to change the logic in a single function and that's it. So let's develop this habit of making the logic inside different functions as possible, and let us try to stick to the principle of single responsibility function. That means I want my function to do only one job, and also in the future when we learn testing, at that time testing functions becomes a much more simpler job. So let's see what functions we are going to require. We are going to require one function to increment the life of the superhero, one to increment the life of the villain, and then one more to decrement the life of the villain and one more to decrement the life of the superhero. So we require 4 different functions to do all of these things. So let me go to the top, and here just below the characters, let me put up a comment. So this block is for the life. Let me go below, and I want to take these variables to the top as well. So let me paste it right over here, and here we can start creating our functions. The first one was to increment the hero life. So this function accepts life, which is of the type of integer, and it returns nothing, so it has to return none. Let me put a comment. Now let's see how to use the logic inside of this. Here I have to operate on this variable, and if you remember the last video, this variable is defined on a global scope. That means I have to use the keyword of global to reference this one. So let me go down over here, and let me say that I want to use the global variable of hero life, and let us increment the life. So I can say hero life is equal to plus my life, and that's it. We can also use the shorthand syntax, so I can simply say plus equal to. So let us copy and paste this one, and this time let us decrement. So I can say decrement, this becomes decreases, this becomes minus equal to, and let us do the same thing for our villain as well. So let me copy all of this and let me put it over here, and my hero becomes villain. So let me do a multi-select, and this becomes my villain. Let me copy and paste this one for the last time. So this one to decrement, so this becomes decrement, decreases, minus equal to. Let me save my file. Everything is looking really good. Let us go down and see what we are supposed to do next. Now once inside our function of simulate attack, let's see how we can use this functionality. But first let us set the types for our function definition. So the attack number is my integer, my superhero is my character, villain is also of the type of my character, and this function is going to return nothing, so I can say none. Now let's use the newly created functions. So we can use the function right over here. So I want to increment the life of superhero, so let me grab this, let me take it out and write the name of the function. This was to increment the hero life. Same thing will happen here also. Let me take it out, put it inside my brackets. I want to increment my life of the villain. Let us do the same thing. So here first I want to decrement the life of the hero. So let me put this inside my brackets, and I can say I want to decrement the hero life, and let us do it here as well. And here I can say I can decrement the villain life. Just save your file, and we can see we have a couple of errors. So let's see what's happening. So what's happening is MyPy is complaining because of incompatible types. For now you can ignore the error, but let me try and explain what's happening. All of these errors will go away when we convert all of the characters into classes in the future videos. But right now what's happening is, if we go to the definition of our character, here you can see the values can either be a string or an integer. This is the thing that MyPy is trying to complain. It's saying that we can't add or we can't subtract strings right over here. So that's why it is showing this error. So let's move on and let's go to the next block. So this is the place where we are seeing if we have lost or if we have won the game. We can create a function for this as well. So I can put up a comment saying that this is for my final game status, and let us define a function called as win or lose. It's not going to accept anything, and it is going to return nothing. Let me take all of these things inside. We can slightly improve the code as well. On line number 164 and 166, we are printing a statement. So let us get those variables inside our function. So here they are. Let me take them out and let me paste it right over here. They have to have the right formatting. Let me put up some documentation right over here and little space. Let me save and see if everything is all right or not. Everything looks good, and we have a very nicely typed program. The last thing to do is just to define our main function, and we simply have to invoke it. Writing the main function is the most simplest thing, so we can just say, let me define my main function. This is also going to return nothing. So this is the place where we would start the game. First thing is we want to have an attack. The next thing is we want to check if we have lost or won, and that's it. The last thing to do is we simply have to invoke this function. So I can just say main, just save your file, and let me just browse if we have some errors or not. We can ignore this error as I have just explained, but let me check if we have some errors. No, everything is looking beautiful. Alright, so let's go down and let us try and play this game. Beautiful. It looks like I have defeated Thanos in the first try itself. It's amazing. Hi, we are officially at the end of this section, but I have decided to add one more bonus video. Now this bonus video is all about teaching you higher order functions. Now learning higher order functions can be a little bit challenging for beginners. So I want you to just sit back and relax and just watch as if you are watching a movie. If you can understand the concept, then it's really amazing. If you can't, there is nothing to lose. And normally it will take you multiple attempts, maybe twice or thrice before you can understand the concept, and which is perfectly fine. I don't blame you for that. The concept itself can be a little more challenging. So just enjoy and see if you can get it. Welcome to the world of functions. Let's start by understanding what are functions and how they are managed inside our memory. So suppose we have a couple of functions. So here I have defined two functions. One is hello and the next one is good morning. So these are pretty simple functions. Now let's see what's happening inside our memory. So this green area would be our memory. Now please keep in mind that this is a very simplified version. In actual life, things are much more complicated. Let's see what's going to happen now. When Python comes across this line number 3 and 4, it is going to create a function called as hello inside our memory. So this is what is happening. We have a function called as hello inside our memory. Now the next question is, how does Python know how many functions it has created inside the memory? The answer is Python gives each and every object a unique ID. Now what do I mean by an object? Object is a generic term. Just like all of us are human beings, but we are also animals. Same thing, anything inside the world of Python is an object. A variable is an object, a class is an object, a function is an object. Anything is an object inside the world of Python. So let me say Python is going to create an object which is of the type of function inside the memory, and the way Python is going to keep a track of all of the objects inside the memory is by giving each one of them a unique ID. It's just like us. Every one of us has a unique passport number. So you can say each one of us has a unique ID as well. The next question would be, how does Python know where does the object live? It knows because it allocates some address to the object. It's just like us. Every one of us has an address. Similarly, inside the world of Python, every object which is created inside the memory also has an address, and this is how it looks like. Now this format is a very special format. It is called as hexadecimal format. You can see this address always starts with a 0 followed by an X. So whenever you see this format, it means it's an hexadecimal format. It is just a way of representing the memory inside our computer. Now what happens when Python goes to next line, line number 7, it sees that we have another function. So it goes back to the memory and it creates another function by the name of good morning. Now good morning also has a unique ID and it also has a unique address. So for example, we can say good morning has this address right over here. We can see this in action inside our IPython shell. So let me open up my IPython shell. So here it is. So here I can say my definition of hello, it's simply printing out hello world. So here I'm just creating a very simple function. Let us see the ID of this function. So I can simply type, I want to see the ID of my function called as hello. So this is the unique ID of our function. You can also ask Python to reveal the type of this object. So you can say, I want to see the type of hello, and the type is a function. If you want to see the address, then we can say, I want to see the hexadecimal of the object which has an ID of hello. And here it is. So this is the address of hello inside our memory. Let us create one more function. So let me define a function called as good morning. And on the next line, I can say I simply want to print good morning. So we have another function. Let's see the ID of good morning. Now you can see we have a different ID. This ID ends in 144. The ID of hello was 032. Let us also check the address of this one. So I can say hex ID of good morning. So you can see we have a different address. So this is F7F0 and here it was B370. So that means hello and good morning are two different objects with two different ID and with two different address inside our memory. Let me clear my terminal and now watch closely what happens. If I create a variable called as greet and if I assign it the value of hello and if I try to invoke greet, we have an output called as hello world. So what's this? What's happening behind the scenes? Now let us go back to our diagram to understand what's happening. What's happening is Python is actually playing a trick with us. So this is the variable which we just created, but if you check its address, it has the same address as hello. So in short, what Python is doing is it is just creating a reference to hello. So the greet variable is just referencing the function of hello. It's just like sharing your house. And when we invoke this function by using brackets, so when we use the bracket, that means we are invoking. Here you can see I don't have the bracket. On line number 33, I'm just assigning the function of hello to greet. And on the next line, I'm using brackets to invoke the function. And when we invoke the function, we get the output of hello world. So what happens is when we invoke greet, it goes back, it sees that greet is actually referencing hello, and behind the scenes, it's this function which is being executed. But on the scene, it looks like it's the function called as greet which is being executed. Now let's get back to our code editor and start writing some code. What I've done is behind the scenes, I have created a new file called as HOF. This stands for higher order functions.py, and I have created a couple of comments for us. The type of function is also called as callable. Because this object can be called, we can give some arguments to it and we can get some values from it. That's why in the world of Python, functions are also called as callables. If you're thinking, why do we need this kind of a functionality? The answer is, till now we have been passing data to the functions, but sometimes it can be very expensive. So what's the solution? The solution is passing the function to the data. You have to just start thinking in reverse. So what we are going to do is we have some data and we would be passing functions to it. Imagine you have terabytes and terabytes of data. It would be so expensive to transport all of this data from one server to the another server just for the sake of computation. Instead, we can simply pass a function to the data and we can get our job done much more easily. So let's start by creating the same function called as hello right over here. So this is the function that we created. The next point, I again want to reiterate that function is just a regular object of the type of function. There is nothing special about it. Now let us also try to print the ID of hello, and let us also try to print the type of hello. Let me run the file. So here it is. Let me take it up a little bit. Okay, so when I'm saying I just want to print hello, so hello is a function which is present at this address. The ID is this one, and the type is actually a class of the type of function. Let's get back and see what else we can do. Now let's try to create a variable and assign the value of hello to that variable. So let me put a comment and let us create the variable called as greet, and let me assign the value of hello to it. Again, remember, I'm not putting my brackets over here because I'm not invoking the function. I am just assigning the function hello to the variable of greet. Now let us try to invoke the function of greet. So let me write greet with the brackets. Let me save the file and let me try to run the file. So here we have the output of hello world. Let us go back and see how we can add types to all of these variables. I just explained that hello is also called as a callable inside the world of Python. So the type of greet is actually a callable type. Let me go up and let me say that from typing I want to import callable. Now let us go down. Let us start adding our types right over here. So greet is of the type of callable. Now if you see the function of hello, it is not taking any arguments and it is returning none. So what we can do is callable. Let us put some brackets. This means that greet is of the type of callable, and inside these brackets we have to specify the input arguments and the output of the function. And here inside the square brackets, the first argument is always a kind of list, and the second argument is the return type of this function. Now let's see how we can add the types. Hello, it is not accepting any arguments, so the first argument to callable would be empty. Next, our function of hello is returning none. So here after the comma I can say it's a callable which returns none, and that's it. We have a nicely typed function as well. Let me add some comments just for the sake of reference. So here we are just assigning the values, and here we are invoking the function. Let us see what else we can do with our functions. Let me put a separator and let me put some comments. So this time we are going to create a universal greeter. Remember, I just explained the concept that we can also pass the functions to the data. That's what we are going to do right now. I am going to create a universal greeter that takes two arguments. The first argument would be for the name, and the second argument will actually take a function. Now suppose you want to greet Zola, then our universal greeter function will greet as Zola. If you want to greet as good morning, then our function will greet as good morning. If you want to greet as goodbye, then our function will greet as goodbye. Sounds so awesome, isn't it? So first let me type all of the functions and then I will try to explain all of them. Let me create the first function called as Zola. So what this function is doing is it is simply taking one argument and it is returning a greeter in the form of Zola followed by the name. Let's create one more function for good morning. The next would be for goodbye. Now let's create our universal greeter function. So let me put up a comment over here and I can say my universal greeter. So this function is going to accept two parameters. The first parameter is the name, and let me get the spelling right, string. The name is of the type of a string. Now what should be the next argument? The next argument is of the type of a function. Let me name it as greeter. The type of this is callable. Now let's see how we can define the types inside callable. Look at all of the functions which I've created. Zola, good morning, goodbye. The function signature is common. All of these functions accept only one parameter, that too of the type of string, and all of this function returns a single argument which is also of the type of string. So that's what I'm going to pass right over here. Let's see how we can define the types. So the first argument is a list and the second argument is the return type. All of the functions are returning strings, so I can just write string over here. And all of the functions are also accepting a string, so inside my inner brackets I can say string. So this is called as a function signature. All of these functions accept one string and return one string. Same thing we are saying over here. Our callable accepts one string and returns one string. Now let's see how we can define the body of this function. Let me add some documentation. Now here you would be amazed, it is just 2 lines function. The first thing that we want to do is, let us take the function of greeter and pass it the argument of name. That's it. That's the entire logic. Let me assign the output to a variable called as message, and on the next line let me simply print it out. Just save a file. Let me try to run the file, and after that I will again try to explain what's happening. But before that I want to comment all of these things. Let me comment out all of this. I don't need all of these things. The greet function as well. Let us invoke our universal greeter function and then we can have a nice output. So let me go right over here, and here let's see how we can invoke the function. So let me say universal greeter, my name is Octalium. Now let's see what we can pass as the second argument. If you see right here, my IDE is telling me that greeter is also a type of function. This brackets, it denotes a function, it takes a string and it returns a string. So basically we can pass any functions that satisfies this signature. And luckily all of our functions, Zola, good morning and goodbye, satisfy these conditions. So we are going to pass one by one inside the universal greeter. For the first one, let me pass simply as Zola. Now remember, I don't have to put brackets because I am not invoking. I simply have to pass my function and that's it. Let me copy and paste. Let me take a little up. The second one would be good morning. The last one would be goodbye. That's it. Just save a file and let's try to run it, and hopefully this time we should have a nice output. Wow, it's so amazing. Single function can produce multiple outputs. Now let's see behind the scenes what's exactly happening. For example, let us take just this line number 65. So Zola is actually a function and this is how it looks. Now let's go back to our definition right over here. This Zola comes as a function called as greeter inside our function. Now this greeter is just a reference to the function of Zola. Let me open up my diagram one more time. So imagine this to be our greeter function and this to be Zola. So greeter is just a reference to Zola, and whenever we invoke this function, behind the scenes the original function is being evoked. So let me go back to my code. So you can see on line number 61 we have a new variable called as greeter. So this greeter is actually a reference to Zola. We pass one argument of name to the function. This name goes right over here, and if you see the function definition, we are returning a string called as Zola followed by the name. We are saving this string inside a variable called as message, and we simply want to print it out. This is happening with each of the functions. The second time what happens is we are passing good morning. Now the second time this greeter over here, this references good morning, and what good morning is doing is it is simply returning a string good morning followed by the name. We capture this output inside this variable right over here, and we are printing it out. And the same thing goes with goodbye as well. That's the reason why every time we have a unique output. First time greeter was referencing Zola, so we have Zola Octalium. Second time it was good morning, so we have good morning Octalium. And the last time we had goodbye, so we have goodbye Octalium. Sounds pretty neat, isn't it? Now let's get back and let's try to learn a little bit more about functions. Let me put a separator. A function, as we saw, can accept a function, but a function can also return a function. Now this part really took me a couple of attempts to understand, so if you can't get it, don't worry, you will eventually get it. So let's go down and let's see how we can create a function that accepts as well as returns a function. Let me put up a comment. Let us see how we can create a function that will return us a function. Let me define a function called as add by 5. This takes one argument number which is of the type of integer. Now since this function actually returns a function, so we can say this is going to return a callable, and we would define the types a little later on. Right now just go ahead and let us type the body of the function. Let me add some documentation. Now what I'm going to do is I'm going to create one more function inside this function. So let's create one more function. Let me create a function called as by 5, and this actually does not accept anything, and this function returns an integer. Inside this, let me say I want to return the number that we get right over here. So I want to return that number plus of 5. So this is the function inside this one, and since our outer function, it has to also return a callable, so we need to have a return statement, and this time I am simply going to return my function, which is going to be this one called as by 5. First let us see the type hinting, and then we will try to understand what's happening. So let me go back to this line. So we know that this function is supposed to return a callable type. Now this callable type is actually this function. So now we can start adding types to it. So here goes my brackets. The first one is for the inputs. After the comma is for the output. This function is returning an integer. So let me write int over here. And this function is not accepting anything. So this argument remains blank. Just save your file. So this is also called as your higher order function. Let's see how we can work with these functions. Let me say that a new variable called as sum is equal to my function of add by 5. Let me pass an argument of 5. If you just hover over right over here, so your IDE is also telling you that the return type is a function which accepts nothing but returns an integer. So what's happening is our variable of sum, now this is referencing to this variable which is inside. We can also invoke sum, and let's see if we are getting the right output or not. So I can say print and sum, and that's it. The reason why we are not giving any input right over here is because sum is referencing this function right over here, and this function does not accept any argument. That's why it is blank. Let me just save it and let me try to run this file, and here we have the output of 10. So this 5 plus this 5 is equal to 10. Well, we can also return a function that accepts an argument. That means we can create a function which can actually accept something and do with the data. So this time let us create a new function called as universal adder, but this adder is going to be a little unique. This adder is going to add two numbers and subtract by 1. It's our own adder. So let me go down over here. Let me take it up. Let me add a command, and let us define a function called as our unique adder. Now this accepts one number, so this is going to be our first number. So let me call it as num1, the type is integer. This also returns a callable. We will add the types shortly. Let me add some documentation. Now let us create one function right over here, but this function is going to accept another number, and we are going to return this number plus another number minus of 1. So I can say define our adder. This function also accepts one argument. Let me call it as num2, type of integer, and this one returns an integer. And let us place our logic right over here. So since this is a unique adder, what we want to do is we want to add the first number, the second number, and minus of 1. Let us go below and complete the function by adding our return statement. So we can say this function right over here, this is going to return a callable, and this time this callable is going to be adder. So we can say return adder. Let us define the typing for this one. So our brackets, one more brackets inside for the input argument, and the next one for the return argument. Let us see this function. This function is returning an integer, so we can say integer right over here, and this function is also accepting one integer, so inside this brackets I can say integer. And that's it. We have a beautifully typed function as well. Let's try to invoke this function and let us see if it is doing its job or not. So my adder would be my unique adder. Let me pass one argument of 5, and as you can see, this is returning one more function, and the function signature is integer returning an integer. Let us print out the value. Let me use my print statement adder, and here I want to give my next number, so I want to add 5 and 5. Let us see what output we should get. So I want to add my 5 with my 5 but minus of 1, so the output should be 9. So let me save my file and let us try running it, and here we have the output of 9. Let us go back and let us try to study what's happening. So what's happening is our function of unique adder is returning another function. So this adder is referencing the return callable from this function, and the return callable is this function right over here. So in short, adder is referencing this adder over here. Let us try with one more example. So let me add 4 and 3. The output should be 4 plus 3 is 7, minus 1 6. Let me save it and let me try to run it, and here we have the output of 6. Let me put it back to 5 and 5. Now let us move to the last part, which is called as a lambda. Let me put a separator line over here, and let me put some comments. So we are going to learn about lambda. Now lambdas are pretty simple, but they are often neglected. Trust me, they are not really complicated. It is just a different way of declaring your functions. Let me first type and then I will show you what's exactly happening. Let me go to the top right over here. Now this is a function called as hello. Let us see how we can define this hello using a lambda. So I can say my new function called as hello number 2 would be a lambda. Lambda simply means a function. Now this function is not accepting any arguments, so we can just write colon, but this returns a string, so we can say this is going to return hello world, and that's it. It's so simple. The entire function can be condensed into a single line. Let me copy this and let me go back to my IPython shell and let's play over there. So let me paste it right over here, and I can invoke my hello2 just as a regular function, and we have the output of hello world. So lambdas are just your regular functions, but they are declared in a different way. Suppose this function accepts one argument, then that argument will come before this colons. Let me take it out and let me show you one more example. Let us go right over here for Zola. So I can say my Zola number 2 would be my lambda. Now this function of Zola accepts one argument as name, so I can write name, and this returns a formatted string. So let me just copy and paste it right over here, and that's it. We have a lambda function ready. Let me copy this and paste it in my IPython shell. Let me paste it, and that's it. Let us invoke this one, Zola 2 octallium. I forgot to close the string. Let me close it, and we have the output of Zola octallium. It's pretty simple, isn't it? Let me again take it out. So just for the sake of practice, let us create one function which will act like a calculator. Now just imagine your calculator. It's a single calculator, but it can do multiple functions. It can do addition, subtraction, division, and so on. So we are going to try and mimic the same functionality by using lambdas. So here, let me create my first lambda by the name of add. So I can say this is going to be a lambda. This accepts two numbers, so my number 1 and my number 2, and this is just going to return the sum. So I can say number 1 plus number 2. If you notice, we don't use the keyword of return inside the lambda, because whatever value that comes after the colon, it's automatically returned. Let me save this one. Now as a convention, the arguments for lambda functions are written as x and y, but you can write num1 and num2. But right now, just for the sake of simplicity, let me convert this to x and y. So let me do my multi-select. This argument becomes my x, and the next argument becomes my y. Let us see how we can add types to our function. So as we know, lambda is nothing, is just a function, and we know the function is also called as a callable. We can say it is of the type of callable. Now inside, the first brackets are for the inputs, the next one is for the output. Now let us see what's happening. Our function of lambda is accepting two inputs. This is the first one and this is the second one, and we want to say that both of the inputs should be of the type of integer. So let's go back right over here, and we can say the first argument is an integer, the second argument is an integer as well, and we are returning a single value. So we can say this function is going to return a single value of the type of integer, and that's it. Let us create one for subtract and one for multiply. So let me just copy and paste. This would be for subtract. I just have to make a very small change. This has to be x minus, and this one would be for multiply. Again, this is x into. So you can see it's so simple. Let's define a calculator on the next line. So I can say define calc. Now let's see the inputs. So obviously we require two numbers. So I can say my first one is an integer, the second one is also an integer, and the third one is going to be a function. Let me call that function as operation. So we are going to operate on both of this number. That's why I'm going to call this function as operation. You can call anything that you want. The type of this one is exactly the type of this one. So I just have to copy and paste from here to here. Now let's go to the return type, and this is going to return an integer. So what's happening is we have a lambda, it is taking two integers and it is also giving an integer in return. So this is what we want to return. So this integer comes from here to here, and inside let me put some documentation. Here the return statement is extremely simple. We simply want to execute the operation on both our numbers. So number 1 and number 2, that's it. And we simply have to return the output. So I can say return, save your file, and we have a nicely defined calculator as well. Let's try to invoke our function and let's see if we are getting the right output or not. Let us try adding 4 and 5. So I can say I want to print the output of my calculator. I want to add 4 and 5, and the operation here is going to be this add operation. So I can just pass that function right over here. I can say add. Next, let us do subtract and multiply as well. So this will be subtract and this would be multiply. Save your file and let us try it running for the last time. And here is the output. 4 plus 5 is 9. 4 minus 5 is minus 1. 4 multiplied by 5 is 20. Well, that's it for this video. I hope you really enjoyed working with functions. More you start practicing with functions, more you will start loving them. And once you are hooked to functions, you may never want to go back again. And if you want to learn the functional approach of programming, then perhaps Python may not be the right programming language, because Python is an object-oriented language. If you want to learn more about the functional aspect, then you can learn languages such as Elixir, Haskell, and Scala. Those languages are built around the functional approach. Welcome to a brand new section. This section is all about object-oriented programming. Even though the name sounds pretty big, but the concept is not so difficult. Some of the main aspects of object-oriented programming are classes, instances, inheritance, and polymorphism. So I would be covering all of those inside this series. Let's go to our code editor and let's start creating some classes. Behind the scenes, I have created one more folder called as 06 oops, and inside of this folder I have created a file called as basic.py, and I have posted some documentation right inside this file. First, let us create a class and then we will see what is it all about, and after that I will come to all of this documentation. So let me collapse my sidebar. So let me go below and let us create our very first class. So we can use the keyword of class followed by the name of the class. Let me just call it as some class. I don't care the name right now. The next line is for the documentation of the class. So let me add some documentation saying that defines an empty class. And inside of this, I don't want to pass any logic for now. I want to keep the body as empty. So I can simply say pass. And that's it. We have created our very first class. Let's try to print it out and see what output we are getting. So I can say I want to print out some class. Let us save it and let us try to run it. And here we have the output underscore underscore main underscore underscore dot some class. Now this output looks a little bit cryptic and we will take care of these things in the future. But what this is trying to say is in the main file there is a class called as some class. So this some class means this class, and this underscore underscore main underscore underscore simply means the main file. Now this is just a naming convention. Whenever we execute some Python module, Python behind the scenes names the main module as underscore underscore main underscore underscore. So this double underscores are also called as dunders. Python makes a lot of use of these dunders and we would be seeing them shortly. Let us go back and create some more classes. Let me put a separator. Let us create a class which represents a person. So I can say class followed by the name of the class. Now remember, the name of the classes are in Pascal case. That means the first alphabet of each word has to be capital. If you check this class, my S was capital and C was capital. Just make sure you always follow this convention whenever you want to define a class. Now let's go right over here and create a class of person. Let me add some documentation that this class defines a person. Now let's try to imagine a structure of a person. Every person has a first name and a last name. So let us give these properties to our class of person, and we can do that by using a dunder method which is called as init. Now don't fuss over what is this method, what is a class, and whatever I'm going to show you right now. This video is just to show you what is a class, and in the next video I will explain you all of the things which are happening behind the scenes. Right now just go with the flow. The first function inside your class always has to be a special function by the name of dunder init. So this is how you define it. Define dunder init dunder. This is just a naming convention by Python. We have a dunder in the front and dunder at the back. There is nothing special about this function. This is just like your regular function, just that we have a different naming style for this one. Now since this init function belongs to a class, the first argument should always be self. Self actually acts like a reference. It means the instance of this class. Again, don't worry, I will explain all of these things in the next video. This function of init is going to accept two more parameters. The first one would be for the first name of the person. The type is going to be a string. Next one would be the last name, again a string. And always remember that this init method returns nothing. So the return type is going to be none. And inside, let us see how we can construct a person. Here we have to say that self dot first name is equal to first name. So what I'm trying to do is I'm just taking the first name and I'm creating an instance variable called as first name. Now this can be anything. I can also name it as fname, and I can write this as fname. It doesn't really matter. The same goes for this one. You can call this ABC. It doesn't matter. But if you're writing ABC over here, then this also has to be ABC. But as a convention, it is normally self. And let me change this to my first name. Let us create one more instance variable for the last name. So I want to say for my instance of a person, so that means for self dot last name is equal to last name. So the same thing, I'm taking the last name from my init method and I'm creating something which is called as an instance variable right over here. Now let's see how we can work with this class. So I want to say my first person is a type of person. The first name is Louis. The last name is Zappa. Let me save this and let us try to print first person. That's it. Let me comment this out. I don't want this one. And let me run this file. And here we have one more cryptic output saying that it is main.person object at so and so address. If you have seen my last lecture about higher order functions, you can make it out that this is a hexadecimal address for this object. Let us go back and see if we can improve this one. Let us create one more dunder method. And this time the name of the dunder method is called as underscore repr. So this stands for representation underscore and self. Always remember the first argument by default inside a class should always be self. Now this is going to return a string. So I'm going to put a string over here and let me just say return, and I am going to return a string. So I can just say inside my quotes that this is a class of the type of person. That's it. Just save a file and try to run it. So this time we have a much better output. So this underscore init and underscore repr, these are also called as magic methods. Python is always going to look for this magic methods whenever it has to create an instance of the person class. Let me add some documentation over here. So this magic method of REPR is also known as the official representation of your class. Now let's see one more magic method. Let us open up the terminal one more time. And to be frank, this output doesn't make much sense, except that this is saying it is just a class of the person. It is not giving any details of which is the person, what is the first name, what is the last name, and so on. But we can improve this by using one more magic method, and this time the name of this magic method is __str. So I can say define my str. So this str simply means for the string representation of the class, and as a convention it has to accept self as the first argument. This method also returns a string. Let me add the documentation saying that this magic method provides string representation of an instance. I will explain all of these things in the next video, instance and classes. Right now just go with the flow and complete this video. So here I can say I want to return a string. Let me construct one string by using our string formatting. So I can say person. The way to get the first name and the last name is using this syntax, self.first name. Inside this curly brackets, I simply have to say I want to get the first name of this instance. So self is acting as a reference. It is telling Python I want to fetch the first name of this particular person only. So let us have the last name as well. So we can say self.last name. Let us save the file and let us try to run it. So this time we have a much better output, and this output also makes some sense that this is a person and the name of the person is Louis Zappa. Let us create one more person. Let me put up a comment first over here. So what we are doing is we are creating an instance of the class of person. Let us create one more person. So I can say the second person would be person. The first name could be CC. Let me get the C capital, and her surname could be Neutron. Let us print it out. Let me print out my second person. Save your file and just run it, and here we have the output. The second person is CC, the first person is Louis. So I think we have learned enough for this first video. In the next video I will explain all of these things, and hopefully you would have a better understanding of classes. Now let us try to demystify our classes. So this is the class of person that we have created in the last video. For this slide I had to slightly compress the syntax, so you can see some of the namings are different from the names that we gave the last time. So just go with the flow. So this was the class that we created last time. The name of the class is called as a person, and we have a couple of magic methods inside of this one. Now let's see what's happening inside our memory. So as usual, this is our memory, and let's see what's going to happen next. Python will see that we have a class called as person, and it is going to create a class inside its memory. Now this class doesn't hold any data. This class that you can see over here, this is just like a design, or rather it is just like a blueprint for a building, but we don't have the building yet. And how do we know what is the design of this class? We can see the design of this class with the special method called as init. This method is also called as the constructor or the initialization of our class. So let me repeat. This is just a class. It does not hold any data. It is just like a design or a blueprint. Now let us see what's going to happen on our line number 15. Whenever we are creating an object of the type of person, that time we say that we are creating an instance of the class of person. So let's see what's going to happen. Python is going to take the design of person from our __init method. So it's going to take the design. So we have the design, and it's going to create an instance by the name of person1. So as you can see, we have an instance by the name of person1. So that is being constructed inside our memory. The same thing happens with person2 as well. Python is going to take the design of person and it is going to create an instance of person2. So here it is. So this is the basic difference between a class and an instance. Class is like the basic blueprint or the design, and an instance is an object of the type of class. So person1 and person2 are called as instances. The design is called as the class. Now if you have seen my earlier video about higher order functions, you must be knowing that different objects have different memory address. So person number 1 and person number 2 are completely different objects and they have a completely different memory address. Just imagine that this is the memory address for person 1 and this is the memory address for person number 2. Now let's see what's happening behind our constructor or our dunder init method. So this method is just acting like fill in the blanks. So you can see our constructor, this is for the first name and this is for the last name. And you can see right over here, first name and the last name. This init method just acts like a fill in the blanks. So it's going to take Louis from here and it is going to put it right over here. It's going to take Zappa and it is going to put it right over here. So that's what is happening. So if you see inside the memory, when the first instance is created, the init method is going to assign the first name to Louis and the last name to Zappa. Same thing is going to happen with person number 2 as well. Whenever we are creating this instance, the init method is going to assign the last name, sorry, this has to be first name, not last name, the first name to CC and the last name to Neutron. The last thing that I wanted to explain is all about this keyword of self. Now self only acts as a reference. That means it tells Python on which instance do I populate the data. Or if you want to get the data, it simply tells Python from which instance do I have the data. Let me show this in action. Let us go back to the previous class, which is right over here. And on the next line, let us print out the first name for both the persons. So I can say I want to print out my first person's first name, and let us do the same thing for the second person as well. Just save a file and let us try to run it, and you can see we have a different output. Let me take it up. The first person's first name is Louis. The second person's first name is CC. The way Python can keep a track of this is because of the keyword of self. So this first name belongs to the instance of this one. So let me show in the diagram. Whenever we are printing the first name of the first person, the self references to the instance on this memory address. So Python can correctly retrieve the data of Louis, and that's what we are seeing on our terminal. So let me open up the terminal, and this is what we get. And similarly, when we say we want to print out the first name of the second person, let us go back to the diagram. The self is telling Python that this time the person is actually this one and this person can be found at this address. So the first name this time would be CC and not Louis. I hope now we have a much better understanding of classes, instances, objects, constructor, and so on. Now let us move on in the next video. We just saw that instances have different memory address. Let me go back to the diagram. So here I explained that this instance has a different memory address and this instance has a different memory address. Now let's see that in action. Let us go back to our code, and here let me put up a comment, and I don't want this one, so I can take it out, this one as well. And let's print out the memory address of our P1 and P2 as well. So I can say print my formatted string, and I can say P1 is located at memory address And if you have seen my video on higher order functions, we know that we can get the memory address from hex, and then inside we require the ID of the object and we require the ID of P1. Let me copy and paste it. This time it has to be P2. This also has to be P2. Just save it and let us try to run it. So here we can see P1 is located at this address. So here you can see this is 4763F and P2 is 479ED. So you can see we have two different instances at two different memory locations, and both of them have taken the design from the class of person, and the constructor was our init method. Let's create one more function inside our class. So let us create a simple function for greet. So I can say define greet, and as you know, the first argument should always be the self. Self always acts like a reference, and this one actually does not return anything, so I can say none. And here I can say print formatted string. Let me put the first name self dot first name, and then I can print a message saying that first name says hello. That's it. Just save your file. Now just one small technical detail. All of the functions that we create inside the class, they are called as methods. So let me put up a comment over here. So this is a method that prints a greeting message. So methods and functions is the same thing. The only difference is that methods are always tied to some class. That's why they are called as methods. Now let's see how we can call these methods. So let me go right over here. Let us get the first instance. So we can say P1, and we can call the method by dot and the name of the method. So we can say I simply want to invoke the method of greet on the first person. We can do the same thing on the second person as well. So I can say second person, and let me put up a comment. That's it. Let me save and let me run it, and here we have the output. Louis says hello, CC says hello. If we go back to the definition of class, you can see we have four different methods: init, representation, the string representation, and greet. What differentiates between this dunder methods and the regular method is that Python by default is going to search for this dunder methods so that it can implement its own magic. If you change the name from init to something else, then the class constructor is not going to work. So always make sure you get the naming convention right. Init is for the construction, REPR is for the official representation, and this is just for your reference, this is called as a string representation. Now, even though the name starts with an underscore, you can use them just as your regular function. Let's see how to do that. Let us go right over here. Let me make some space, and let me print out p1 dot underscore underscore str, and that's it. So what we are doing is we are simply calling the method called as str on the instance of p1. That's it. Let me save and let me try to run the file, and here it is. We have the output of person Louis Zappa. So this is absolutely possible, but this is not the recommended way of doing it. So let me put up a comment: possible but not recommended. Well, that's it for this one. In the next video, we will convert the character from our game to a class. Now let's see how we can convert the character from our game to a class. What I've done behind the scenes, I have created a new file called as character.py inside my 06 folder. Let us go back to the folder number 5 and inside the game. So this is how our character looks like. Our character has a name, attack power, and life. We can use these parameters to create our own class. So let us go back to our character.py file. Let me collapse my sidebar, and let's start creating a class for our character. So the first is the keyword of class followed by the name character. Let us go inside. the first method is always going to be the constructor. That means our underscore init method. So we can write like this: define my init. Remember, the first argument should always be self. For reference, here we can accept 3 different arguments. Let us go back to the game. So we need 1 argument for the name, 1 argument for the attack power, and 1 argument for life. So let us go back to our init method, and here I can say I want to accept a name, type is string, next is attack power, type is an integer, life, the type is an integer, and this method always returns none. Let us create some variables inside. Again, you have to follow the conventions. You have to write self.name, and let us take the data from this variable and put it right over here. So I can say name. Remember that you can name this anything, so I can just call this as n, but you have to change over here also. But as a convention, normally we would like to keep it the same names. So let me go back. The next is for the attack power. So I can say self.attack power would be my attack power. The next would be self.life would be my life. Let me add some documentation right over here saying that this method creates an instance of character. Let me add some documentation for the class as well. So this is for the documentation of the class, that this class defines a character. Now let us create an instance of this class. So let me create a villain first. So I can say a villain. The first one would be a character. The name would be Thanos. His attack power is 400 and his life is 1500. Let me print out the villain number 1. Let us save the file and let me try to execute this file. And here we have the output. But as you know, this is a little cryptic output. So what Python is telling that this is a character object at this and this memory address. But you already know how we can improve this. So let's start adding some of the dunder or the magic methods. The first one I can say is my REPR. The first argument is self and this returns a string. I can say return. So this is my class of the type of character. Let me save the file and let me run one more time. So this time we have a little better output. My villain is actually a class of character. Let us improve further by using our str method. So we can define it right over here. Str. First argument is always the self. This returns a string, and let us construct a string right over here. So I can say the name. It would be self.name. Next would be the attack power, and this would be self.attack power. Next would be life. So this would be self.life. That's it. Let me save it and let me try to run it. So this time we have a much better output. The name is Thanos, attack power is 400 and the life is 1500. Let us go back and let us create some more characters. Let me put up one comment over here. So while constructing a class, you can actually use key and value pairs. So let us create one more villain and let's see how we can do this. So this is my villain number 2. It is a character, and here we can use the key value pairs. So I can say the name, maybe this time it is Red Skull. The attack power is 300 and the life is 800, and that's it. Let me try to print out the second villain as well. So I can say villain number 2, just save it and try to run it. And here we have the output: Red Skull, attack power 300, life 800. Now the beauty of this key value pairs is you don't have to specify the arguments in a given sequence. You can mix up the sequence, but still we can have a proper instance. So let me show you. Maybe I can just take this out and put it here. And let me save this. Let me try to run it one more time. And still we have the right output. Let us go back and let us try to create some more heroes. Let me create one hero. So this is Iron Man, attack power is 250, life is 1000. Let me create one more. So this time it is Black Widow. The attack power is 180 and the life is 800. And let us also print them out. Let me run the file for the last time. And here we have the output: Thanos, Red Skull, Iron Man and Black Widow. Before we can move ahead, let us take a small pause and let us think, do we really require classes? Let us go back to the earlier program that we wrote. So let me go back to my file called as basic and let me collapse my sidebar. So let us ask a very fundamental question. Do we require a class? The answer is it depends. Whenever you want to have a structure and a behavior together, at that time using a class makes much more sense. If you require just the data, then you can use any of the data structures. You can use a list, you can use a dictionary or some other custom data structures as well. But whenever the structure and behavior is tied together, that's the best place to create a class. For example, in this file we have a class of person. Now let's see what's happening. Person has a structure and that structure is defined by the first name and the last name. Now this person can also have a behavior. A person can greet another person. So we have a method called as greet. So greet can be imagined like a behavior of a person. A person can have different kinds of behaviors. A person can walk, a person can talk, a person can eat. So all of this can be imagined as behaviors. But all of these behaviors is tied to a structure, and that structure is a first name, last name, and maybe you can have multiple other parameters such as your age, your location and so on. So just keep this in mind. Classes are not the solution for everything. Make sure you use the right data structure or the right classes only when it is required. Let us learn more about classes, and this time let us learn about class membership. Till now we have been creating variables inside our constructor. So for example, in our class of character, so you can say self.name is a member of the instance of this class. Same thing, attack power can also be called as an instance variable. Let us create a new class and let us try to study what is this all about. So behind the scenes, I have created a file called as members.py, added a couple of comments. So let's try to see what's happening inside. Let us try to create a class called as box and let us define an init method. This box has two sides. This is my side number 1. I can say the type is integer. My next side, also the type of integer, it returns none. Let us create the variables inside. So I can say my side A is equal to my side A and my side B is equal to my side B. Now what we have done is we have created variables inside our constructor class. Now remember what this method does. It actually creates an instance and fills in the value. So if we refer this diagram, our constructor is simply filling the values of the instances. So the variables that we create inside, they are called as instance variables. Let me put up a comment right over here. Now if you go back to the diagram, the data is different for every instance. So for example, the first name for person number 1 was Louis, and for person number 2 it was CC. Now let us see how to create class members. Let me put up a comment. So these class members are defined on the class scope. So these class members are defined outside our constructors. So let us define a couple of class members as well. Let us create a variable and we can say box type, and this is going to be a packaging carton, and the color for this one would be brown. So these variables that we have created, box type and color, these variables would be accessible to all of the classes. Please note that we don't have self over here because we don't need reference to an instance. This data is available to all of the classes and all of the instances. Let us create a str method. Here I can say define my str, again self. This always returns a string, and I can say return my side A would be my self dot side A, and my side B would be, sorry, it has to be self dot side B. For this example, I am going to skip the REPR, but you can write it on your own. Let us create an instance called as the first box, and I can say the box side A, maybe it's 3 and the next is 4. Let us try to print out my box. So I can say I want to print my box. Let me save it and let me try to run it. So here we have a box, side A is 3 and the side B is 4. Now let us try to print the class variables from an instance. Remember, this class instances are available for all of the instances. So I can simply say I want to print my box first dot box type, and let us print the color as well. So I can say the color. Let me save it and let me run it. So we have the output, it's a packaging carton and the color is brown. Let us go back and let us try to solidify this concept of class members. Now these class members are available on the classes itself. You don't have to create an instance. That means if you go back to the design, we can get back the data from the design itself. We don't have to create an instance to get back the data. Now let's see this in action. What we did till now is we created an instance of the box and then we printed these variables right over here. But we can simply say I want to print the box type from the class of box. Let me copy and paste. We can also say I want to see the color. That's it, just save it and let me try to run it, and we have the output packaging carton and brown. So this time what we did is we simply accessed these variables from the class. We did not create an instance. So this is what I mean to say when all of the class members are available to the class itself and also to the instances. Let us create one more box and print it out. So let me print my box number 2, and just for the sake of confirming, we can say my b2 dot box type and my b2 dot color, and we should get the same output. Let me save it and let me run this file for the last time, and here it is. We get the exact same output. Let us try to study the next concept in our object-oriented programming, and this concept is called as inheritance and polymorphism. What I have done is I have created a file right over here called as inheritance and polymorphism, and let us try to see what's going on. Just to give you a very simple example, we are all human beings, but we are also animals. That means we inherit a lot of properties from animals. For example, all of us have eyes, ears, hands and legs. But all of us human beings, we don't speak the same language. Now that's polymorphism in action. Inheritance means we inherit all of the features of an animal, and polymorphism means even though we have the same properties, but we exhibit different behavior. Now let's create some classes and see this in action. Let us create the first class called as animal. So let us create a class of animal, let us define our methods over here. First is the self, and let me accept one argument for name, one for the age, and one for the number of legs. This returns nothing, so I can say none. Let me put up a comment that we are going to create and initialize the instance variables. Let's start creating some of our instance variables. So I can say my self dot name is equal to my name, then my self dot age is equal to age, then self dot of legs is equal to my num of legs. Let us also create the str method. So I can say define my str, it takes a self, it returns a string, and here I can return, let's say we can just return the name for now. So I can say name, and this would be self dot name. Let us try to give animal some kind of behavior. So let us create a method called as talk on animal. So I can say define a method called as talk. The first parameter would be self, and this is going to return nothing, so none for now. Let me put up some documentation saying that this method makes the animal talk. But let's see what we can do right now. Since we don't know what kind of animal it is, that's why we can't talk yet. So let us print the same thing right over here. So I can say print my formatted string self dot name can't talk yet. So let us go down and let us create one animal. So this is my first animal. So I can say I want an instance of the class of animal. The name is Robin, age maybe is 10 years old, number of legs is 4. Then let us print out the animal, and let's also try to make the animal talk. So a1.talk, just save a file and let me run it. So here we have the output. We have Robin, and Robin can't talk yet. Now let's go back and let's see how we can create some sort of inheritance. Let us create a dog. Now remember, dog is a kind of animal, so you can say that dog inherits from animal. Let me create a class and then I will try to explain what's happening. So let me create a class called as dog. Now here inside the brackets, we have to specify from which class we are inheriting. So dog is inheriting from the class of animal. So this is how it goes. Let us create our constructor right over here as well. So define init self. Now let's see what happens. Since the dog inherits from animal, dog also needs to accept all of these parameters: name, age, number of legs. So let me just copy and paste. And here we can accept some more arguments as well. So let me create one more argument for breed. So we can accept one for breed. Let me get the spelling right. Let us go down and let us start creating our instance variables. Here at this point, Python can do a small bit of magic for us. Since dog is inheriting from animal, we don't have to create all of the instance variable manually. Instead, what we can do is we can pass the common data to the class we are inheriting from. So we are going to take all of this data and we are going to pass this data to animal. So technically animal can be also called as your parent class, or it can also be called as your super class. Let me put up a comment. So we want to take all of the common features and pass it to the parent or the super class. Python provides a keyword called as super. So this super means the class of animal, and now we want to pass all of this data to one method, and that method is called as init. Now remember, init is just like any other function except it has underscores at the beginning and at the end. So we can call that method as we can call any other method. So we can say super and underscore underscore init underscore underscore, and let us pass the common features, which is the name, age, and the number of legs. Now it is the responsibility of the superclass, that means the class of animal, to create instance variables for the name, age and number of legs. The only argument that is remaining is for the breed. So inside dog we can create one more instance variable called as self.breed, and we can assign the value. We can also create extra instance variable even though we are not accepting parameters right over here. So let me give you a small example. So I can say self.type is equal to dog. So you can see we can create instance variables wherever we want them. So let me save this. So this is what I mean by inheritance. Dog is a class which inherits from animals and they share a lot of common functionality. That's why we are passing the common functionality to the superclass, and we can create some additional instance variables as well. Now let's see how we can introduce polymorphism in this class. Remember the superclass of animal has a method of str. So let's override this method and let us create a different str method for dog. So let's see how we can do that. The syntax is going to be exactly the same. So we have to say define str, takes in a self, gives back a string, and let me print out a message over here. Let us use the formatted string. So we can say self.type followed by the self.name, and let us also print out the breed. So I can say the breed of the dog is self.breed. Oh, sorry, we can't print because remember the str method always has to return a string. So thanks to our typing, my code editor is catching an error. So this has to be return, not string. Let me take out the brackets. Now everything looks good. Now let's create a dog. So I can go right over here. So I can say my first dog is an instance of the class of dog. The name is Whiskey. The age, I can use my keyword arguments as well. So my age is 5 years old. Number of legs is obviously 4, and the breed, maybe the breed could be Doberman. Let's try to print out our dog. So I can say print my dog. Let me save it and let me try to run this file. So here you can see we have a Doberman by the name of Whiskey and the breed is Doberman. Now let us try and explore some more benefits of inheritance. So you can see we have created a class of dog which inherits from animals. Since dog inherits from animals, it also inherits all of the behavior of animal. The class of dog does not have a method for talk, but the class of animal has it. So we can actually make the dog talk as well. So we can say d1.talk. Let me save it and let me try to run this file, and we get the output that Whiskey can't talk yet, but we can use our polymorphism and we can make Whiskey talk. So let's see how to do that. So inside my class of dog, we are going to create a new method called as talk, and the new method is going to override the method inside the class of animal. So it's just like creating another method. So we can say define talk. It always takes self. This is going to return nothing, and here let's print out. So I can say self dot name says woof, and let me save the file and let us try running this, and now we have the output. Whiskey is saying woof. Let us go back and let us see what else we can do. Let me take out this space. This class of dog, it can have its own behavior. Now since this is a dog, our dog can also sniff different items. So let's create a method called as sniff on dog. So let us go down over here. So I can say define a method called as sniff. The first argument is always the self. Now these methods are just like your regular functions. They can also accept arguments. So let me take an argument for the item that the dog is supposed to sniff. It is going to be a string. This method is also going to return nothing, so I can just say none, and let us print out a message. self.name is sniffing out the item. So please note that here we don't have to use self dot, because item is not an instance variable. Item is just a regular argument on a regular function. Let us go down and let us try to sniff. So let me say D1, I want you to sniff for ball. Save a file and let us run it. So here we can see we have the output. Whiskey is sniffing out ball. Let us create one more class for cat. And since cat is also an animal, cat is going to inherit animal as well. So you can see we can have multiple classes that can inherit from other classes as well. Let me put a comment saying that this method of talk, this is the place we are altering the method and we are adding some polymorphic behavior. So let me go down and let me put a separator and let us create the class of cat. And creating that class is pretty simple. I just have to copy all of these things. So let me copy, let me go down and paste it right over here. Let's change the name from dog to cat. The type also is a cat this time. We don't want the comment now, and the cat says meow. And we don't want this method because cats are not so good at sniffing. So let me take it out. Let us create one instance of our cat. So I can say my cat number 1 is my cat. The name is Jess. Suppose she is 2 years old. Number of legs is 4, and the breed could be a Persian cat. Let us print out the cat. So I can say print, and let us also make the cat talk. So I can say c1.talk. That's it. Let us run the file and we have the output. So we have a cat named Jess. The breed is a Persian cat and Jess is saying meow. So now you get the idea. Just for the sake of practice, let us create one more class for a dinosaur. Now this dinosaur is also going to inherit from animal. Let me copy and paste this separator. Let me copy all of this as well. And let me go down and let me paste it right over here. So since this is a dinosaur, I can just say dino, and this has to be dino as well. And since we don't know what dinosaurs can talk, put some random text. Now the dinosaur can also hunt. So let us create one method for hunt. So let's create one method called as hunt. It accepts a self and returns a none. Here I can say print self.name is out for hunting. Let's create one dinosaur. So I can say my dino1 is equal to my dino. Suppose the name is Adam. Age could be 8 years old. Suppose the number of legs are 2 and the breed could be T-Rex. Let's print out the dino. Let us also make the dino talk, and also let us make the dino hunt. That's it. Let me save and let me run the file, and we have the output. So this is a dinosaur. Adam is saying something. Adam is out for hunting. So now you get the idea. We can have multiple classes inheriting from a single class, or you can also inherit from multiple classes as well. But we are not covering that in these tutorials. Let me put a separator and let me show you one nice trick. We can also ask Python if a certain class inherits from other class or not. So let's see if the dog and the cat inherits from animal or not. So I can say print, and we can use an inbuilt method called as isInstance. The first argument is the object that we want to compare. So let me pass my dog, and the next argument is the parent class that we want to compare with. So suppose I want to see if the dog is of the type of animal. So let me save it and let me try to run it. And here we have the answer. It's true. And that's because the class of dog is inheriting from animal. Now here I want you to understand one point. all of the dogs are animals, but all of the animals are not dogs. So please keep this in your mind. Let us check if D1 is a kind of dog. So I can say is instance D1 and dog. Let me print it out. And yes, it is. Let us do one last time for our cat. So let me copy and paste. So this becomes C1 and this becomes cat, and let us see the output. So here it is. C1 is an instance of cat as well. Now let's try to learn about decorators. So these decorators are like the higher order functions, but these higher order functions are already built into Python. These decorators can give some additional behaviors to our classes. So we are going to have a look at a couple of these decorators. Some of the decorators that we are going to see are property, static methods, class methods, getters, and finally setters. So I have created a new file called as decorators, and I'm going to work inside this file. For this example, let us imagine that we are working for a store and we have to write a software that will manage our staff. Now since all of the staff members are also persons, so first I'm going to create a class of person, and then I will create a class of staff that inherits from person. So let us start with the person first. So I can say the class of person, our constructor init self, and suppose we want to accept the first name. This is a string, the last name, this is also a string, and this returns nothing. Inside, let us create some instance variables. So we can say self dot first name is equal to my first name, and self dot last name is equal to my last name. Let us also create the string method. So I can say str self, and this always returns a string. So I can say return this is a person, and then I can say my self dot first name and self dot last name. Let us create one person and print it out. So I can say this is going to be, sorry, not permission, I want a person. The first name would be Louis, the last name would be Zappa, and let us try to print him out. Now let me try to run and see the output. So we have the output of Louis Zappa. Till now you are familiar with everything. Now let's go to the example. Now suppose you want to retrieve the full name every time. Now instead of creating one more instance variable over here saying that self dot full name is equal to something something, instead of this we can create a property, and that property will create a full name for us, and we can retrieve it just as we would retrieve any other instance variables. So let me take out this line and let me show you how to use our first decorator. So let me go down over here. The way you use a decorator is by this symbol @ and then you name the decorator. So this time the decorator that I want to show you, this is called as property. So this is our decorator, and after that let us create the function. So I can say define full name. This takes self as the first parameter and returns a string. Next line we can simply create the full name and let us return the full name. So we can just say self dot first name and self dot last name. So what we have essentially done is this full name right over here, this would act just like your instance variable. So just imagine that here we had one more instance variable called as self dot full name. So this property will function exactly like this. Let me show you this in action. So let me take it out. Let us go down and let us try to print the full name of the first person. So I can say print first person's full name. That's it. Now since this is a property, we don't have to use brackets after this one, because remember full name is just like your instance variable. Let me try to execute the program. And here we have the output, Louis Zappa. Now let us go back and let's start working on some other classes. But before that, let me put some separators. So this is one separator and this is another separator. Now let's create the class of staff, and this staff will inherit from person. But let us try to expand our knowledge over here. Suppose there are different categories in the staff. There could be an associate, there could be a manager, and so on. So we can have multiple roles, and each of these roles can have different salaries. So suppose if you are an associate, then your salary could be $15 for an hour. If you are a supervisor, it could be $20. If you are a manager, it could be $25. So what we want to do is, whenever we create a new class, we also want to dynamically give that person a different salary based on his role. Sounds a little complicated, but don't worry, let me show you how to do this. Now, since we have to define different roles, at this time using an enum is the best option. So if you have not seen my video on enum, I would highly recommend you to go back and see that video. So that was in my section number 4, and I think that file was this choices.py. So we are going to use this enums in this file. I want to use enums because I want to define different roles. Let's see how to do that. Let me go to the top, and first let me try to import a couple of things. So from my package of enum, I want to import enum, and I also want to import my auto. So now we can define an enum. Let me create one called as class role. So this inherits from my enum, and inside this let me put some documentation that this role is for our staff members. Now let's create a couple of roles. Suppose the first role is for an associate, so I can say associate, and let me write auto over here. The next one could be a supervisor, again is equal to auto. The last one could be a manager, so I can say manager is equal to auto. Let me just save it, and let us go down and let's start creating our class of staff. Let me put some separators here as well. Okay, now let us go down, and here let us start creating the class, and the class is of staff, and this class inherits from person. So here let us first define our constructor. So I can say define my init. The first argument is always self. Now let us see. Now since staff inherits from person, person requires two arguments, first for the first name and for the last name. So let me just copy and paste right from here. So I can take this and put it right over here. Now the next argument that we want is for the role. Remember, we want to take the role, and we would be dynamically creating the salary depending on the role. So I can say I also want to accept a role, and the type would be role. This method always returns nothing, so I can say none. So inside this we want to pass the data to our super class. So let me put a comment, and then I can say I want my super to initialize with my first name and my last name. Now let us create some more instance variables. Maybe we can accept one more parameter for the staff ID. So let me write it right over here. So I can say the staff ID would be an integer. Now let us go down and let us start creating the instance variables. So the first variable would be for the staff ID, and this is equal to the staff ID. Let us create one more instance variable called as is staff, and let us put it to true. So remember, we can always create instance variables even though we are not accepting them inside our constructor method. Next, it could be for the role. So I can say self.role is equal to role. Now for the next one, I also want to record the date of joining for the staff member. So let's see how we can do that. So I can say self dot date joined, and this time the value has to be in the format of date and time. Fortunately, Python has an inbuilt library for doing exactly this, and the name of the library, as you can guess, it is called as date time. So let me go above and let me import it. So here I can say from my library of date time, I want to import date time. Now let us go down and let's see how we can assign the value of date time. So here we can simply say date time for now. So what's happening is the moment that we are creating this instance, we can have the date time automatically assigned to our variable. Before we proceed, I want you to wait and I want you to think. Once we have a staff member, I don't want anyone to accidentally change the date joint. So what's the solution? Let us try and make this variable a private variable. Now there is no real concept of private and public, but we have a convention. So whenever we put an underscore, this means that we want to keep this variable as private. You can also write double underscore or a single underscore. It's up to you. Normally, whenever we want to enforce that it's a strictly private, then you can use double underscore. But a single underscore also means that we want to keep this variable as private. So let me write a comment right over here. So this is going to be our private member and all of this are public variables. The next thing to do is we want to assign the salary, but this salary has to be dynamically assigned depending on the role. If the role is of an associate, then the salary has to be $15. If it is a supervisor, then the salary has to be $20. If it is a manager, then the salary has to be $25. Let's see how we can dynamically assign a new instance variable called as salary and assign values to it. So let me put up a comment that we want to dynamically create and assign values. So let's see, we can use an if and else statement, so we can check if the role is for a supervisor or for a manager and so on. But we can also use our match statement. So in this example, let us use the match. So I can say let us match for the role. The first case that I want to match is for my role.associate. So in case this role is for an associate, then at that time I want to dynamically create an instance variable called as salary and I want to assign the value of $15. Let us also add some type hinting. So instead of 15, it can also be 15.5, 15.75 and so on. So let us declare this instance variable as a float. Now you must be wondering, why do I need to have a type hint right over here, but here we don't have? The answer is it's because we have declared the types right over here. So this first name is a string. So by default, this first name is also going to be a string. Staff ID is an integer. So here the staff ID is also going to be an integer. And MyPy is smart enough to infer all of these things. But here, since we don't have this instance variable declared anywhere, we have to be explicit and let us declare the type is going to be a float. Here again, let us think about the visibility. I don't want anyone to change the salary. Salary has to be privately managed. So we can say I can put an underscore or I can put a double underscore. Let us go to the next case. Suppose the role is for an supervisor. Then I can say self dot underscore salary would be $20, and then I can say if the role is for a manager, then I want to assign the salary of $25. Let us also define the string method for this one. So I can say define my str self, this return a string. So let me return, so I can say this is a staff member, the name is self. Now here I can use the property that we have defined for full name. If you scroll a little up, we don't have an instance variable for full name, but we have declared a property, and that's what I'm going to use right over here. I want to display the full name, so I'm using self.fullname. Next, we can also display the ID, so I can say ID is my self.staff ID. Let us go down and let us try to create a staff member this time. So I can say my staff member is my staff. The first name is Chico, the last name is Jonas. Staff ID can be 3245. Let's give her a role of manager, so I can use my enum. I can say the role is role.manager, and let us try to print it out. So let me print my staff. That's it. Let me run the file. So we have a new staff member. So you can see right over here, the name is Chico Jonas and the ID is 3245. Let us go back and let us see what more we can do with our classes. The next decorator is called as the class method. Just imagine the scenario that we already have a person in our database and this person is joining our shop as a staff member. So what we can do is we can simply take that person as an argument. If you see right over here, we are taking first name and last name as an argument. Instead of this, we can take a person, and from that person we can create another class for the staff. So let us go down right over here, and this is called as class method. Now always remember, this method is used to create another class. Till now we have been working with instances, but what this class will do, it will return another class which is of the type of staff itself. So let's see how to do that. Suppose we want to create a new staff member from an existing person, so I can say define new. So new is just the name of the function. You can write anything that you want, and since this is a class method, the first argument is called as a class. Till now we have been taking the first argument as self, so we can see it was self. But since the class method works on the class, that's the reason why the first argument is a class. If you are still confused, then let me go back to my diagram. So this is a class and this is an instance. The class method is going to work on the class itself. That means we can create a new person from a design of the person. That's what it really means. Let us write the different arguments. So obviously we want to create a new staff member from an existing person. So we need to accept a person. Next, we also need a staff ID. So this is going to be an integer. Then we also need a role. The type is for the role. Now here, this method is going to return another instance of the class, and that instance is of the type of staff itself. So this function returns a staff. Let me add some documentation saying that this is going to create a new instance of the staff itself, and let's see how we can create a staff. In this case, this class actually means staff. So here we can say I want to return a new staff member, and the first name is going to be the first name of the person that we are accepting. So I can say person dot first name. The next argument is the person dot last name. Then we have to give the staff ID, and then we also have to give role. Now unfortunately we can't write this syntax, but what we can do is, since this class means staff, we simply have to replace staff with class, and it's the same thing. Now the return value is of the type of staff, but what's happening is we are trying to return the staff member before we have defined the class of staff. So in order for this code to work, we have to do something. So we have to go a little up, and we have to say from future I want to import annotations. So what do I exactly mean to say is, since this method right over here, the method of new, is returning a staff, but at this time Python does not know what is the staff because Python has not yet created this class. But by importing this functionality from futures, we can tell Python what's exactly happening. So let us go down and let us add one person to our staff member. So since we already have a person called as Louis Zappa, Maybe he joins our store. So let us create a staff member from Luis Zappa. So let me say my staff number 1. So here let us create a new staff member by using this class method. The first argument, as you can see, it's for a person. So let me pass my first person. The staff ID could be 1, 2, 3, 4, and the role could be the role of a supervisor. Now let us try to print it out. Let me say I want to print my first staff member, and this I can say this is my second staff member. Just save your file and try to run it. So we have the output. The first staff member is Luis Zappa with ID 1234, and we have one another. If you are a little confused, then just keep in mind that class method is a method that returns an instance of the same class. Now let's try to move on and let's learn a little bit more about classes. Now since we have defined this instance variable as private date joined, but what happens if anyone wants to see what is the joining date? So we can create another property that will display the joining date. So we can go down and let me create a property. So here I can use my decorator called as property. Let me define the property called as joined on. This takes the self, and this is going to return a string. Let me put up some documentation saying that this is for the joining date of the staff member, and since this has to return the joining date, we can simply say I want to return, and here I can say myself dot underscore date joined. Now if you're wondering why do we have to do all of these things, and the answer is since this is a property, we cannot assign values to a property, at least not yet. In technical terms, this is also called as a getter. In short, we can simply get the value from here, but we can't set the value over here. Later on, when I teach you about getters and setters, at that time we can actually use properties to get as well as set different properties. But for now, let us go with the flow, and let me try to save the file and let me try to run it. Let us try to see the joining date of Louis. So I can say print dot joined on, and that's it. Let me try to run the file, and we have a joining date. Now this joining date looks pretty complicated. It's in a different format, but fortunately we can also have the output which we can understand. So let's see how we can do that. Suppose I want to see the date in a format of month, day, and the year. So let's see how we can format this. Fortunately, there is one inbuilt method for our date time, and that is called as string format, and we have to use a couple of keywords right over here. So let me paste it over here. So this capital B stands for the month, the lowercase d stands for the day, and obviously Y stands for the year. So let me save this and let me try to run this file, and here we have a much better output. So the date of joining for Luis Zappa is July the 6th, and the year is 2022. Let us see the last concept that I want to teach you in Decorators, and this concept is called as getters and setters. I have already partially explained that this property right over here, this property acts as a getter. That means I can always get a date, but I can't set a date. But let's see what happens if we want to set a value. Suppose we promote an employee. Suppose an associate becomes a supervisor, or a supervisor becomes a manager. That time we also need to increase their salary. So let us see how we can do that by using our getters and setters. Now if you remember, we have declared the salary as a private member. But what happens if our HR department wants to see the salary? So first let us create a property or a getter to see the salary, and then we will see how to use a setter to set the new salary. So let us go down and let us create one property for the salary. So I can say property, and let me call it as salary. It takes the self as an argument, and this returns a string. I think I have declared it as a float. Yeah, it's a float, so this has to return a float. Let me put a comment. So So this acts like a getter of the salary, and we simply have to return our self dot underscore underscore salary. Let us see the salary of Louis. So let me say I want to print staff1 dot salary, and that's it. Let me run the file, and here you can see the salary is $20 for an hour. Now let's see what happens if I try to set the salary. So if I say my s1 dot salary is equal to 17, let me save it, we have an error. So if you just try to hover, it says that property salary is defined in staff is a read only. So what this is trying to say is we can only get the value, we can't set, and we can't set because this is just a read only property. So this is the beauty of getters and setters. We can't accidentally change the values. But what happens if we do want to change the value? At that time we need to create another method which is called as a setter. Let's see how to do that. Normally you would use a setter when you need to do some kind of validation before you want to set the values. Now in this case, let us see what kind of validation do we require. If you remember, if the role is for an associate, the minimum salary is $15. For a supervisor, the minimum salary is $20. Now if the role is for a supervisor, but if we try to set the salary which is lower than $20, then we don't want that to happen. So this is a part of our validation logic, and we can use that inside our setter method. The way to declare the setter method is kind of weird in Python, but let me show you how it is. So the syntax is I want to say for my salary, this is the setter. So this is a syntax for the setter. This simply means that we are declaring a setter method for the property of salary. Let us create the function for salary. Obviously the first argument is for the self, and the next argument is for the amount. That is the amount of salary that we want to give the employee. So I can take one more parameter called as amount. The type would be of a float, and since this is a setter, we are not going to return anything, so I can say none. Let me put up a comment saying that this is our setter method, and inside of this let us see how we can use our validation logic and how we can set the new values. Let's start with the associate. The associate cannot have a salary which is less than $15, so we can say if my self dot role is role dot associate, and if the amount is less than $15, that means it is going to fail our validation because we can't give an associate a salary which is less than $15. So let me print out a message saying that error, associate cannot have a salary less than $15. Now what happens inside any of the methods, you have access to all of the instance variables. So if you see, I'm using this instance variable called as self.role, and we have defined this self.role right over here. So this is where it is on line number 60. But since we are inside the same class, we can have access to all of the instance variables. The same thing is happening everywhere. So for example, in this property of salary, I can access the salary. In actual, this salary is being declared right over here, either on line 66, 68 or 70, but we can still access all of the instance variables. Let us go down and let us create the next validation logic. So this was for an associate. Next, let us create one for the supervisor, and the last one for the manager. So we can say else if the role is for the role of supervisor, and if the given amount is less than 20, then we need to print an error message. So we can say supervisor cannot have a salary which is less than $20. Let's go to the next one. We can again check if the role this time is for the role of a manager, and if the amount is less than 25, then let us print one more error saying that manager cannot have a salary less than, so this should be $25. dollars for an hour. Now let us go down. Now what happens if we pass all of this validation? That means we have the right role and we also have the right amount. In that case, we can assign that amount as a salary. So here I can say else. If everything is fine, then my salary is equal to the given amount. And let me print a nice message saying that self.full name now has a salary of dollars and self.salary, and I can write per hour. So remember that this salary is a property. So as you can see, the Visual Studio Code is telling you that this is a property and this is a getter method. Now let me save the file. Now let me try to run it. If you see on line number 120, I am assigning a value of $17, but the role is for a supervisor. And if you see inside our validation logic, supervisor cannot have a salary of 20. That means we should get an error. Let me save the file and let us try to run it and see if we can get an error. And that's it. We have the right output. So it's saying that error, supervisor cannot have a salary less than $20 for an hour. What happens if we try to set the salary which is valid? So I can say s1.salary is equal to 20, or maybe I can say 22. So let me save it and let me try to run it, and we have the right output. So on the next line you can see Luis Zappa now has a salary of $22 for an hour. Let us go back to the file, and this time I want to show you the final decorator in this section. Now we have been inheriting classes. For example, here the class of staff is inheriting from person. In some of the earlier examples, we were inheriting classes such as animals, dogs, and so on. But what happens if I want to say that you can't inherit this class? Whatever class I've created, this is the last and final class, and no one can inherit it. We can do that by using a different decorator. But first let me import that. And that comes from our typing library. So I can say right over here, from my library of typing, I want to import final, and just before the class that we want to declare as final, we have to use it. So suppose I want to say my class of staff is a final and no one can inherit it. So I can just say @ and this is going to be my final class. Let me save it and let us give it a try. So suppose let me put a separator over here. Suppose someone creates a class called as HR, and let us try inheriting from staff, and we can keep the body as empty. So let me just write pass. Let me try to save it. Now you can see the code editor is highlighting that we have some issue, and it is saying that the class of staff is marked as final and it cannot be subclassed. So let me just comment it out, and I think we have done for this video. Let us start converting our game into classes. So the first thing that I want to do is, let me just copy and paste it inside this folder. Let me rename from 3 to 4, and let me change the documentation. So this is where we are trying to improve our design by using classes. So let's see how we can start using classes inside our game. Till now we have been using an alias, but now what we can do is, instead of using an alias for the character, we can actually create a class for character. So let us go right over here and let us create our class for character. So we can say class character. Now let's see what instance variables do we require. Now each of the character has 3 main things. You can see right over here: name, attack power, and life. So we can define these as our instance variables. So let us do that. Define init self. The first is the name, is going to be a string. Attack power, integer. Life is also an integer. This returns nothing. let me write some documentation saying that this creates an instance of character. So here I can say self.name is equal to the name, self.attack power is equal to the attack power, self.life is equal to the life. Let's also create a nice str method. So we can say define a string method for this one, self, and this always returns a string. And inside, let us make a nice string representation for the character. So I can say the name of the character is self.name, the attack power is going to be self.attack power, and the life is going to be self.life. Let me save it. Next, let us see how we can create superheroes and our villains. Now superheroes can inherit from our character, and our villains can also inherit from our characters. So let's see how to do that. So let's create a class called as superhero. So you can say my class of superhero, this inherits from the character. Let me put some documentation and let us write the init method. Now since this is inheriting from character, I can simply copy and paste all of this. Just copy and paste, and this returns nothing. Now inside, since we are inheriting, we can use the super keyword, and we can say super dot init, and we can simply pass the name, attack power, and the life. So the super class of character would be responsible for creating all of these instance variables. Next, we can also create one more instance variable called as a role. So this instance variable can say that this is a superhero or this is a supervillain. In order to define a role, again let us go back and create a nice enum. So let me go to the top, and first thing that I want to do is I want to import. So from enum I want to import my enum, and also I want auto. I can say my class of character type, this inherits from enum. Let me add some documentation. Then I can say superhero and assign it to auto. Then I can say villain and assign it to auto as well. So let me save this and let us go on below. Here I can create one more instance variable. I can say self.role, and this would be equal to my character type dot superhero. Let us also create the str method. So I can say str self, this returns a string. Let me copy and paste all of this. Let me put it here. Now just before the name I can say that this is a superhero. So I can say this is a superhero and put a nice arrow. Now since this line is really long, so we can do one small trick. Let me take it down, and I want to have brackets around this. So this is my opening bracket, and right over here I can put my closing bracket. And what I can do is let me cut this portion out for the life, and on the next line I can simply again say F and paste it over there, and that's it. So this is also a valid syntax. Next, let us create the same thing for our villain. So I can simply copy all of this, paste it down. So from superhero it becomes my villain, and this has to be my villain, this has to be again my villain. Let us go down, and we don't need all of these things because we already have a class for character. So I can take all of this out. I don't want any of this. Now let's see what we can do with life. With life, I'm going to do a very small trick. I'm going to create a class for life, but all of the methods would be static. That's because I don't want to create an instance of life. It makes no sense. I just want access to hero life and villain life. So let me create it first and then I will try and explain. So here I can say this is going to be a class of life, and what I want to do is I want to take all of these things inside. So till here all of these things goes inside my class. Now let's start changing them one by one. Now what happens is you can see these two variables. These are outside my init method, or rather I don't have an init method over here, and that's also perfectly fine. These two variables belongs to the class, so they can also be called as my class variables, and that's what I want. There is one other alternative approach. Let me paste it right over here. That approach is called as data classes, but I'm not going to cover them inside this course. You can use this link to study more about data classes. Now let us continue with our journey. I'm going to use a new decorator which is called as static method. So let me copy and first let me paste everywhere, and then I will try and explain what's happening. Since this hero life and villain life belongs to the class, I no longer have to use the keyword of global and hero life, so I can take it out. And now what happens is this hero life is actually a class member of the class of life. So I can simply say life dot hero life plus equal to life. So this means that this hero life variable references exactly this one. Let me save it and then I will try and explain what this new decorator is doing. Now if you see, I'm not taking the argument as self for static method. That's because this decorator works on the class directly. It does not have to create an instance. Let us go back to our decorators file, and there I will try and demonstrate what's happening. So this is our decorators file. Now let me go back to the diagram itself. So here is our diagram. Again, whenever I'm saying that this is a static method, means that we can call that static method from the class itself. We don't need to create instances. For example, here in our decorators file, you can see that we have this one, datetime.now. No matter whatever the class, you don't need an extra instance. We can have a common functionality. That's what I mean to say by a static method. So basically, static method is just like any other method, but it does not take a self argument because it works directly on the class and not on the instance. Suppose we can create a static method called as describe, and that static method will just describe what this class is going to do. So let's create it and see it in action. So let me go down, and just after this property joint on, I can create my static method. So I can use my decorator of static method. The name would be describe. So again, this is not going to take self, neither this is going to take a class, because this is independent of everything. This is going to return none. Let me write some documentation what's happening. So this method is just going to describe what this class is all about. So I can just print out that this is a class to create a staff member. Now let me go down, and here I can simply call this method on my class. So let me call it at the top. I can say staff dot describe, and since it's a method, I need to use my brackets. That's it. Let me run this file, and here we have the output, class to create a staff member. Now using this same concept, let us go back to our game. Now here what happens is we have two class members, hero life and villain life. I want to get access to this variables, and that's what I'm doing right over here by using a static method. You can get a little bit more clarity when we use this method later in this video. For now, let us change all of the syntax. So this one also becomes my static method, and I don't want global, and this becomes my life dot hero life. Same thing for this one. This also becomes my static method. I don't need the global. I can say my life dot villain life, and same thing for this one as well. So this also becomes my static method. I don't need the global, and this is my life dot. That's it. Just save a file. Let us go down. So here what we can say is this is a list of superheroes. So instead of just character, I can say this is my superhero. Next, what I can do is I can create instances of my superhero by using the newly created class. So I can say my Iron Man is a superhero. The name is obviously Iron Man. Next, the attack power is 250 and the life is 1000. So similarly, let us create instances for all of the other superheroes as well. So here we have a Black Widow, Spider-Man and Hulk. Now since we have everything in classes, I don't require this constant, so I can just take them out. They are not required. This becomes a list of superheroes, and I have to change this as well. So Iron Man, Black Widow, Spider-Man and my Hulk. Let us go down. So this, instead of character, we can say this is going to return a superhero. The rest everything remains the same. So let us go down to villains. This is going to be a list of our villains. Again, let us do the same thing. Let us create instances. So I can say my Thanos is equal to my villain. The name is Thanos. My attack power is 400. Life is 1500. Let us create the rest as well. So we have all of them. Let us take out all of this. It's not required. This becomes my villain, and we need to change all of this as well. First is Thanos, then is the Red Skull, and then is Proxima. Let us go down. So this becomes my villain and everything is looking good. Let us go down and let us see where we need to do some more changes. This becomes a superhero and this becomes a villain. Now let's see where we are going to use the class of life and the static methods that we have created. We are going to use exactly right over here for the set life and for the actual attack. So here I can say from my life, I want to access the static method called as increment hero life, and I simply want to pass the life of the superhero. So I can say my superhero dot life, and we can use this syntax because life is just an instance variable on superhero. So this is the beauty of working with classes. Let us go down. Again, we can do the same thing. We can say from my class of life, I want to access the static method of increment villain life, and I want to pass the life of my villain. We don't need all of these lines. We can take them out. We can do the same thing right over here as well. So I can say life dot, I want to decrement my hero life, and let's pass the attack power of the villain, and same thing below, life dot decrement villain life, and let's pass the superhero attack power. We don't need all of this. We can take it out. Let's save our file. Now let us go to this line. It seems that we have some error. So let's see what's happening. Value of superhero is not indexable. Oh yeah, that's right. Now since this is a class, we have to say superhero dot the name, and here also villain dot name. And now the error is gone. Let us go down, and here what we can do, since hero life and villain life are now the class variables of life, so we can simply say life dot hero life, and here it becomes life dot villain life. And now we have a beautifully typed object oriented game design. So let me save my file and let me try to run this. Now that's really amazing. Everything is working perfect, and it seems that I have also won the game. Welcome to the last video in this section. This video is all about the different magic methods that we can use inside our classes. Till now we have seen only 3 magic methods. One was init, second one was repr, and the third one was str. But Python provides many more of these magic methods. So let me try and cover some of the most commonly used magic methods. What I've done is, behind the scenes, I've created a file called as box, and let us start working with this. As you can see, it's completely empty. So let's create a class, call it as box, and the init method, this box is going to have 2 sides. So I can say my side A, the type is an integer. Similarly, we have side B, type is an integer. This is going to return nothing. And my instance variables, so my side A is equal to my side A, and my side B is equal to my side of B. So let's create the wrapper method. So you are already familiar with it. I'm just returning a new string called as class of box. Now let me create the str method. So till now there is nothing new to you. Inside my str method, I'm just returning a nicely formatted string saying that this is a box and side A and the value of side B. Let us create 2 boxes. So this is my first box and this is my second box. Let us also print them out. So I can say print my box first and print my box number 2 as well. So let me save the file and let me run. So till now there is nothing new to you. Let us go back. Now suppose what happens if you do something like this. I want to add both of them together. So if I say b1 plus b2 is equal to my b3, and then I want to print my b3. Let us save and let us try to run this file and see what's happening. It's saying that this is an unsupported operand, and that's because Python does not know how to add one box with another box. But we can implement this functionality by using different magic methods. So if you go back and if you say minus, again if you try to run, again we have some sort of an error because Python does not know how to minus these boxes. And the same thing will happen for all of the different operations such as multiplication, division, less than, greater than, less than, equal to, greater than, equal to, and so on. But what we can do is by using different magic methods, we can implement this functionality on our class. So let's see how we can do this step by step. The first thing that I want to show you is how we can use the in operator. So let me give you a small example. This is my IPython shell. If I say O in octillion, so we get a true. So let us see how we can implement this syntax of in for our box. We can implement this by using another magic method, and the name of this magic method has to be specific, and the name is underscore underscore contains underscore underscore. This takes self as the first argument. The next argument is what we want to check. So let me name that argument as number. For now, let us skip the type and I will come back to it a little later. Let us see what this type has to return. Let us go back to my IPython shell, and here you can see the return type is of the type of Boolean. So that's what is going to be the return type. So this function is going to return a Boolean, that is, it has to return true or false. The logic for this is pretty simple. Let me again go back to my IPython shell and let me show it first over here. Suppose we have a list, so let me call it as L, and this is 1 comma 2. Now if I say 1 in my list of L, we get the answer of true. If I say 3 in my list of L, we get the answer of false. So what we can do is we can simply create a list of both the sides, so side 1 and side 2, and we can simply compare that the other argument is inside that list or not. So let's see how to do that. Here we can simply say return if the given number is inside my list, and I can say the first list member is my self dot side of A and my side of B. Now this method works, but this is not foolproof. What happens if this second argument is not a number? If someone provides a boolean value or some other value, then how we can say the user that we have an error? So for this, let me show you some new syntax. So let me go down, let me put a comment. Now if you remember, when I was teaching you about classes and instances, we used one method which is called as isInstance, and there we could check if the dog is an instance of animal, if the cat is an instance of animal or not. So we are going to do the same thing right over here. We are going to check if this number is of the type of integer or not. If this number is not of the type of integer, then we can simply throw a number. So here what we can say number, it can be any object. We don't know beforehand what the user is going to provide. So object is a generic term, and if you remember, everything inside Python is an object. So we can say number could be any object. And now let's try to see if the number is an integer or not. So we can say if, then we can use the inbuilt function called as isInstance. Then we can say is my number an instance of my integer, and if not, so let me go up and I can use the word if not. Here I want to throw an error, so I can say raise not implemented error. Now since this number is not the type of an integer, we don't know how to do the comparison, so we simply raise an error. In the next section, I'll be teaching you more about errors. Right now, just try and understand if in a situation we don't know what to do, we can simply raise an error. So that's what we are doing right over here. Let me save it and let me show you it in action. So we don't want this one. Here I can say is 4 inside my box of 1, and I can also say is 6 inside my box of 1. Let me save it and let us run this file. So here we have the output. Let me take it up. 4 in box number 1, yes, and that's true. 6 in box number 1, false. Let us see what's happening. So this is our box number 1. We don't have a 6 over here. Now watch closely what happens if I write something like this. I can write A over here. Let me save it and let me try to run it. And this time we get an error, and this error is of the type of not implemented error. And that is what we have coded. If you go back to our line number 15, since A is a string, but we want an integer. So what's happening is in this line, we are raising an error. If you try to evaluate isInstance number is a type of instance, it's going to fail because here the number is actually the string of A. So if not an instance of integer, then we want to raise an error, and that's what we are doing. So if we just open up the terminal, we are throwing an not implemented error. So this error, which is called as not implemented error, so this is a standard way of throwing an error inside this method. Let's see some other operators. So if I want to say is my box 1 is equal to my box 2, let us see how we can do this syntax. Right now, let me take it out. And since this line is always going to fail, let me take it down and let me comment it out. So let me go right over here, and I want to copy and paste till this one. Let me go down and let me paste. Since we want to see if both the boxes are equal or not, the magic method is called as equal, short form EQ. Let me write the proper documentation. So this checks if both the boxes are equal or not. And this line is the standard check that we want to have. Now let's see what to do right over here. This time we expect a box, so let me change the name of the variable from number to a box. Let me go down, so this also has to be box. Here we want to check if the given object, which we call as box, is an instance of the class of box or not. So instead of integer, this has to be my class of box. So if the another object is also a box, only then we can have a comparison. But there is a small limitation of Python. We can't use this syntax directly, but we can use a small hack, and let me show how we can do this. Again, let me go to the top and I can say from my future I want to import my annotations, and now we can use the syntax which is right over here. Now let us see how we can compare both of the boxes. Now what happens is the box has a side A and a side B. If both of the boxes has to be equal, that means both of the sides should match. So that's what we are going to say right over here. I can say that return self dot side of A is equal to the box dot side of A. Maybe we can rename this variable. We can call this as the other, or we can say the other box. Right now I'll just write this as other. So right now we are comparing the self dot side A with the others side A. Similarly, we also need to compare the side B as well. So here I can say I want my side A to be equal, and I also want my side B to be equal. So I can say self dot side B has to be equal to the other dot side of B, and this also needs to be changed from box to other. So let us go down, and here we can say I want to print if my box 1 is equal to my box 2. Let me save this and let me run this file, and here we have the output false. Box number 1 is not equal to box number 2. Let us go back and let us try to implement some other methods. Let us try how we can check for less than and less than equal to. So what I mean is how we can implement this behavior b1 less than and b2, or less than or equal to b2. So let us go up right over here, and let us start creating our method. Let me copy till this line and let me paste it over here. So whenever we say that we want to compare if it is less than, the magic method is called as LT, which stands for less than. Let me also write the proper documentation. So instead of this, we want this one. Now let's check if the other box is smaller or not. One simple way of doing this is by calculating area, or you can also use this syntax, but I think using the area is a much more cleaner method. Now since we already have the side A and B, we can define a property for area, and we can use that property right over here. So let me go over here and let me create a decorator for my property. I can say this is for my area self, and this returns an integer. So I want to return my side A multiplied by my side of B. Now this makes things much more simple. So here simply what I can do is I can go right over here and I can say return self dot area, is it less than the others area, and that's it. Let me save my file. But what happens is this magic method is only for less than. We also want to compare for less than and equal to. So if you go to this line number 44, we have an equal operator as well. So let's see how we can implement that, and that's pretty simple. Let me just copy all of this and paste it. Now this magic method is called as less than or equal to, that means L and E, and on this line we simply have to add equal to, and that's it. So let us start printing all of these things. So let me go down over here. Here I can say I want to print if my b1 is less than b2. One more beauty of this magic method is we have simply defined a magic method for less than and less than equal to, but Python can infer how to implement greater than or greater than and equal as well. It simply has to reverse the logic, and Python does it behind the scenes. We don't have to create another methods since we already have these two methods in place. So here I also want to check if my box of 1 is greater than my box of 2. We can also use the less than and equal. So we can say if this is my less than or equal, and we can also use the greater than and equal. So this one, let me take out this line, let me comment all of this, let me comment all of this, and let us try to run this one. So here we have the output. Let us check if the output is true or not. The first one is my box number 1 less than my box number 2? Let's see what's happening. 3 multiplied by 4 is 12, 2 multiplied by 5 is 10. So that means my box number 1 is larger than my box number 2. Let's see the statement. So this is exactly opposite. My box number 1 is larger, so this becomes false, and that's what we have over here. In the second line, yes, my box number 1 is larger, so we have the output of true, and so on for the line number 53 and 54 as well. Let us go back and let us see some other methods as well. Now let us see how we can implement some basic operations such as addition, multiplication, division, and so on. Luckily, writing all of those methods is just a matter of copy and paste. So let me show you. First, let us create a method for addition, so where we can add 2 boxes. Let me copy and paste. Since this is for addition, the magic method is called as add. Let me change the documentation, and let me also get my spacing right. And here we simply have to add the areas. That's it. Let's check what's the error. Oh yes, now it's saying that it got an integer as the return type, but it is expecting an boolean. So let's see what's happening. Oh yes, here we have written boolean as the return value, but that's not what is happening. Area is an integer, so let us update this from boolean to an integer. So you see there are so many benefits of having a very well typed code. Let us implement other methods for subtraction, multiplication, and division as well. Let us create one for subtraction, and since it is a subtract, we can say that this is subtract. Let me change the documentation, and this becomes minus. Let us do for multiplication, and since this is multiplication, this becomes mul for multiplication. Let me change the documentation, and this becomes multiplied. The next one for division. Now this becomes a little tricky. If you think for division it would be just div, you are partially right, but that's not what is happening. Let us go back to our IPython shell and let me try and explain what's going to happen. So suppose if I say 1 divided by 2, we have the answer of 0.5. This is called as true division. Now if I say 2 divided by 3, we get an answer of 0.6 as well. Again, you can see this is a true division. But if you watch closely, we have 2 integers and the output is a float. What happens if we want to have the output as an integer as well? In that case, we have to use / and then 3. So this syntax is called as float division, and this syntax is called as a true division. The return value of a true division is always a float, and the return value of float division is an integer. So let us go back to our code and see how we can do this. The first one can be our true division, so I can just say this is my true division and this becomes my true division. Now remember that the return type is going to be a float this time. Since this is going to be a true division, let me copy and paste this for our floor division. So here I can say I want to have my floor division, and here I want to have one more slash, and that's it. Let us go and let us print out all of these things. So let me go right over here and let me put all of my print statements. Let me comment all of these things out and let me try to run this file, and here we have the output. So b1 minus b2 is 2. Let us check if that is the case or not. So the area of first box is 12, the area of the second box is 10, and that's what is happening. So 12 minus 10, we get the answer of 2. And if you check the answer of all of the other methods, obviously all of them are going to be right. When I was going through the code, I realized that we have a small mistake. It's not really a mistake, it is just about following the best practices of Python. So let me try and explain. Everywhere we are trying and throwing this error called as not implemented error, which is absolutely fine. But the guidelines in Python suggest that whenever we have a binary operation, that time we simply have to raise an error which is called as not implemented. So this and this are two different things. Please keep that in mind. So let me rectify all of these things. So let me just copy and paste it everywhere. So all of this, let me do my multi-select. This becomes my not implemented, this one and this one as well. So let me save the file. What I mean by a binary operation. So all of these operations, minus, plus, multiplication, division, etc. all of these are called as binary operations. But this one, when we are checking 4 inside B1, this is not a binary operation. So in this case, we are using not implemented error. And whenever we have a binary operation, at that time we are using just not implemented. Well, that's it for this video, and now we are officially at the end of this section, and I will see you in the next section where I will try and expand your knowledge of error handling in Python. Welcome to a new section. This section is all about error handling in Python. Now, errors in Python can be divided into a couple of categories. The first category can be thought as your syntax errors. That means whenever you make some errors in typing, those errors are called as your syntax errors. Now fortunately, these errors are very easy to catch, and these days we have much better tooling inside Visual Studio Code and our plugin MyPy, or if you're using an IDE such as PyCharm, all of these tools will help you to catch syntax errors. The second category can be thought as your runtime errors. That means these errors are not reflected inside your code, but whenever you try to run it, these errors will pop up. These errors are a little bit difficult to debug. So as we saw in our last video, whenever we can't handle a situation, we were raising some kind of errors. So when we raise those kind of errors, at least we can have some idea what's going wrong during our runtime. And these errors in Python are called as exceptions. So let's see one by one all of this. The first thing that we are going to see is the most common one, and that is called as your syntax errors. So let me go back to my code editor, and what I've done is behind the scenes I've created a new folder called as 07 error handling, and this is the file called as maths.py. Now let's see what's happening. There is some red line right over here, print x and y. This is an example of my syntax errors. So at least I need to have a comma right over here, or I need to have like my formatted string, so something like this, and this has to be inside my curlies, and this as well. And now if you try and save, your error will go away. So this is one of the most common errors called as a syntax error. Now let me try and show you what do I mean by a runtime error. So what I've done is I've created another file called as divider, and let's see what's going to happen this time. Let's create a function that divides two numbers. So I can say define divide. The first number could be an x, the next is an y, and this does not return anything, and we can simply print out my x divided by y. So till now everything looks perfect and we don't have any errors. Now let me go down and let me say I want to divide my 4 by 0. Now what's going to happen? We can't divide any number by 0. It's just not possible. So what is going to happen is our program is going to panic and it is going to exit. So let me save and let me run this file and let me show you this in action. So here it is. Our program panicked and we have an error which is called as 0 division error, division by 0. So this is an example of runtime errors. There are no visible errors inside the code, but whenever we are trying to execute this code, we have some errors. So let me put a comment over here. So this throws or raises an error, and the type of the error is 0 division error. If you open up a terminal, that's what we have. So this is a type of error, or rather this is a type of exception in the world of Python. Let us try to expand our knowledge of errors. So in this program we saw that when we panic we get an error. This error is a very specific one and the name of this error is called as 0 division error. Now Python gives us an error handling mechanism in the form of try and except blocks. So let us see how we can use that syntax to catch this 0 division error. So let me go back and let me create a new file, and I can name the file as smart divider.py. So let us create our function called as smart divider. Again it's going to accept x, which is integer, y is also an integer. This is returning nothing. Now let's see how we can do a very smart division. Last time we saw that when we divided by 0 we got an error, and that error was 0 division error. We can catch that by using our try and except blocks. So this is how the try and except blocks goes. So inside the try, this is the code that we want to try. So trying the code, and in case this code fails, then we can say except, and this is the place we are going to catch the specific error, and we have that error, then do something with the error. Let us see how we can fill these blocks. So inside try, let us see if we can divide or not. So I can just say my number is equal to x divided by y, and I want to print out my number. Now what happens if we get the same 0 division error? So we can tell Python that whenever we are going to have that error, I want my except block to catch it. So I can say except my 0 division error. So that means whenever I get this error, I want to catch that error, and after catching that error I can do something with it. So let me just print out some message. Can't divide by 0, use some other number. Now let us go back and let us try dividing by 4 with 0, and let us try to run this. So this time we have a much better output. Our program is not panicking. Instead we get a very helpful message saying that can't divide by 0, use some other number. So as you can see, we can handle our errors. Now imagine one more scenario. Instead of 4, I write as a. Then what happens? Let us run and see what's happening. This time again we have some other error, and this time the error is called as type error, and unfortunately our program is panicking and it is terminating midway. Let's see how we can handle this situation as well. So let me go back and let me create another file. This time I will name it as really smart divider, and let us start writing the code for this one. let me copy and paste the code from my smart divider. So let me take all of this and paste inside my really smart divider. So since this is a really smart divider, I can say this is my really smart divider. Let us have a look at the error one more time. So what's happening is, let me take it down. So what's happening is, we were trying to divide by A. Now A is of the type of a string and 4 is of the type of integer. So both of them are essentially of different types. So that's what this error is saying. So we have a type error. Let us see how we can catch this error as well. We can chain our except blocks. So we can say, if we have a zero division error, then I want to catch it right over here. But if there is a type error, so I can say except my type error. Let me catch it right over here. And this time I can print out both x and y needs to be a number. But what happens if we don't know what kind of error we are going to get? That time we can use some other syntax, and this is called as exception. So now this exception class is the base class for all of the different exceptions. So just as we saw in our classes, dog was a subclass of animal. So same thing, all of these errors, zero division error, type error, and all of these things, all of these errors inherit from exception. Now the same logic goes over here. Dog is an animal, cat is an animal. Same thing, any errors that we get is also an exception, and that's what we are trying to catch over here. Here we can also add an alias. So we can say, I want to catch my exception as a variable called as e. Then we can simply print out what happened wrong. So here I can say, oops, something went wrong, and let me print out my exception, which we are calling just as e, and that's it. This time we have a really smart divider. Let's try to invoke it. So I can say, my really smart divider, can you divide 3 with 0? Can you divide 3 with 4? Can you divide 3 with a? Now let me try to save and run this file, and this time we have the output. So the first time we have a 0, so we have the output can't divide by 0. Second time everything looks good, so we have the answer. Third time we have a string, so we have the output both x and y needs to be a number. We are making really good progress with errors, and let us learn the last missing pieces for our error handling. So let me create a new file. Let me call it as try else and finally.py, and let me copy all of the code from my really smart divider and let me paste into this file. Let us call the function just as divider. So let me take this out. There are two more pieces for this puzzle. So till now we have seen the try block and the except block. Now let's see the else block. Now what happens is, if this condition succeeds, then the code inside the else block can be executed. So inside my try block, I'm just trying to see if I can divide x with y. If this succeeds, then I can say that I want to print right over here. The naming is a little weird, but we can't really help it. So whenever a try block succeeds, we can use an else block to execute some other code as well. Let me add a couple of print statements just for the sake of clarity. So else is executed only when try succeeds. So we are trying to see if x can be divided by y or not, and if that succeeds, only then we want to print out the number. Now the last piece is called as finally. Now no matter what happens, if the try succeeds or it fails, this finally block is always going to execute. So let me write a print statement right over here. You may not appreciate the beauty of this block finally, but just imagine a scenario that you're writing a web application and you want to write something to the database, or suppose you're interacting with some other APIs and you want to do some kind of a cleanup operation maybe you want to delete some files, maybe you want to insert some files. So no matter the outcome, if the operation succeeds or fails, we can have that logic inside the finally block. Now let me save this file and let me run this file. So as you can see, we always have this output of finally. So no matter the outcome, we always have this block. Let me comment one of this so that we have much more clarity. Let me try and run the file. So we have a 0 division error, and since we have some error, the code inside the else block did not execute, but the code inside our finally block executed, and we have this output right over here. Now let me go back and let us try with the second one. Let me comment this out and let me try to run this. So now see what's happening. Since this operation is succeeding, we go to the else block, and inside the else block we first print these 2 lines. So that's what is happening. We have those 2 lines right over here, and after that we are printing out the number, so which is 0.75, and this block finally, this is always going to execute. So that's what is happening. So if you try with this one, you can have the same output. So let me uncomment this. So since we have an error, our else block will not execute. Let me run this file for the last time. So here it is. We have a statement saying that x and y needs to be number. The code inside the else block is totally omitted, but the code inside the final block is executed, and we have the output right over here. Let us have a look at the next kind of error, and this kind of error is called as assertion error. Now this assert statement that I am going to show you, these statements are very useful in testing. Now we are not going to learn testing in this series, but I just wanted to show you the assert statement. So what I've done is, behind the scenes I've created a file called as find Zohan. So what's going to happen right now is, Louis has a list of friends, and let us try to see if we can find a particular friend in that list or not. So let me name the function as find Zohan, and this accepts a name of the friend that we want to find. So this returns nothing, so we can say none. So this is the list of friends, so I can just copy and paste it right over here. Now let us create our try and else blocks. So normally you would write as name in my list of friends, and this would give you a boolean value of true or not. But what we can do is, we can also use the keyword of assert. So what I mean to say that I want Python to assert if the name is inside the list of friends or not. If the name is not present, that means we can have a kind of error, and this time the error would be assertion error. So let us use the except block to catch our assertion error. So we can say, oh, not arithmetic, I want assertion, and then we can say, let us print out the name not found. Now in case we get a match and this statement succeeds, then we can also write the else block, and we can print out saying that found followed by the name. We can also include the finally block. Remember that this is always going to execute. Let us print maybe goodbye. That's it. Let us try searching for a couple of friends. So I can say find Zohan, and let us try to find for Zohan himself. Let me copy and paste, and let me try to search for Sarah, and let us run this file. So we can see in the first case we found Zohan, so we are printing out find Zohan. The final block always executes. We have goodbye as well. The second time we could not find Sarah, and it threw an assertion error which was caught inside this except block. So we have the output of Sarah is not found, and the final block again executed, so we have the output of goodbye. Till now we have been seeing how to catch an error, but now let us see how we can actually throw an error. So let me create a new file right over here. this is going to be my find Zohan part2.py, and let me copy and paste all of this code from here. Now let's get working on this file. Now since I am not catching any errors, I don't require this try and else blocks, so let me take it out. Now if we can't find the name inside the list of friends, at that time we want to raise an error. So we can say that we can't find the given value. That means we can raise a value error. Here we can say if the name is not inside my list of friends, then I can raise an error, and I can raise a value error, and I can also give a custom message saying that the name is not found. And we can also say else, in case we find the match, we can simply print it out. We can say found and followed by the name. So let me save it and let me try and run this file. So the first time we have a match, so our program will not panic, but the second time we don't have a match and our program will panic with a value error. So let's see that in action, and here we have it. The first time we could find a match, so we have an output, but for the second time our program panicked and it threw the value error, which you can see right over here. So we have a value error followed by our message saying that Sarah is not found. Well, this brings us to the end of this section as well. If you want to learn more about errors, you can go to this link. So this is all of the files from GitHub. Go inside this folder, error handling, and go to this file readme. I have put up a reference right over here. You can visit this link to learn more about errors. That's it for this one, and I will catch you in the next section. Welcome to a brand new section. This section is all about learning packages. Packages are used to organize our code. So let's see how to create some packages. But before that, let us see a couple of examples where we have used them. For example, inside our game, we have been importing a random int from random, and also enum and auto from enum. What this means is we are importing something that is useful from us from a package or a module. And you can see this gives a very nice organization. So it's very clear, from my random module I'm importing something random, from my enum I'm importing something as enum. So you get a lot more clarity inside your code. So let me go inside my 08 packages folder, and inside of this let me create a new folder. The name of this one is 01 local modules. For the sake of clarity, I'm going to open this newly created module inside a new code editor window. So I can just go inside this. I can say 08 packages, and I want my code editor to open 01 local modules in a new window. So here we are. If you just hover, you can see I'm inside my folder 01 local modules. Suppose you are taking a maths class and you have to do a lot of calculations, and these calculations involve squares, rectangles, circles, and so on. So let's see how we can divide all of this functionality by using our modules. Let's say we have to do some operations on a circle. So let's create the first file. Let me call this as circle.py, and let me create a class of circle, and let us create the init method. So I can say define my init. This takes a self, and this also takes a radius. Suppose the radius can be a float value. This returns nothing, and inside we can say self dot radius is equal to my radius. Let us also create the str method. So I can say my str would be my self, and this returns a string. Here I can return saying that my radius is my self dot radius. Now in the same class you also have to deal with rectangles. So in order to organize our code, we can create another file called as rectangle. we don't have to club all of the functionality inside a single file. So let's do that. So right over here, let me create a new file called as rectangle.py, and let us create the class for rectangle. Let us create one more file for dealing with squares. So I can create another file called as mysquare.py, and let me just copy and paste from rectangle. So let me paste it. This becomes my square. This becomes just my side. I don't need this. And my side is equal to my side. This becomes my square, and I can just say that this is my side by my side, and that's it. Oh, I forgot to put a colon. So what we did is we segregated all of the functionality into different files. Now technically all of these files are called as modules inside Python. We may call them as files, but they are identified as modules. So what we can do is we can import functionality from these modules. So let's say we have a file called as geometry, and from that module of geometry we can import all of these functionalities and we can work with them. So let me show you all of these things in action. So let me create a file called as geometry.py, and here I can say from my module of circle I want to import the class of circle. Same thing we can do for rectangle and square. So I can say from the module of my rectangle I want to import my rectangle, and the last one, from my module of square I want to import square. So what we are doing is we are simply importing the things that we want to work with. Now this file, circle, rectangle and square, they can have multiple functions or they can have multiple classes, but we just need to import the things that we want to work with. So let us create a circle. Maybe the radius is 5. Let us create a rectangle. So I can say my rectangle. Let me give some random values. Then let us create a square. Let me give some random value as well, and then we can simply print them out. So this is my C, and this is my rectangle, and this is my square. Let me save it and let me try to run this file. So as you can see, we have the right output. First one is a circle with a radius of 5, then we have a rectangle, and then we have a square. So in this example, what we did is we created different modules. But if you look closely, square, rectangle and circle, all of these things belong together. And we can create a package, which I will show you in the next video. We just saw how to create different modules. And in this video, I will teach you how to take all of the common modules together and how to create a package out of it. You must have noticed that we have a couple of additional files. Let me take it right over here. So this was the folder that we created in the last video, and you can see we have multiple different folders. One of the first folder that you can see is for this one. This is called as py-cache. You don't have to touch this folder. This is just a mechanism by Python to speed up your code. Just let it be there. Now for this video, let me just copy and paste this folder, and let me rename this to 02 package. And also let me open up the folder inside a new window, so I can say code 02 package. So here we are. So this is the exact same code that we created in our last video. Now what happens is circle, rectangle and square, all of this are similar. All of these are shapes, and we can organize our code in a much better way. So let's create a package which is called as shapes. So packages are nothing, they are just a special kind of directory. So let me create my directory and let me name it as shapes. After this, I'm just going to copy my circle inside my shapes. Yes, I want to move. Same thing for my rectangle and my square as well. So let me just drag all of these files inside my folder of shapes. Yes, I want to move. Now we need just one more file to declare that this folder is an package and not just an ordinary directory. The way to do that is by creating a file, and the name of the file is very important. The name of the file is __init__dot_py. When Python sees this file, it considers your directory to be an package. Now let's see how we can import all of this circle, rectangle and square in our file of geometry. So here you can see we have a couple of errors, and that's because we have moved all of this code inside a new package, and the name of the package is called as shapes. So here we have to say that from my package of shapes, I want you to go to the module of circle, and you can say that by putting a dot. So this means from my package of shapes, I want you to go to the module of circle, and inside the module of circle, I want you to import my class of circle. Same thing will go with the rectangle. So here I can say shapes.rectangle, and this also goes to my shapes.square. Just save a file, and that's it. If you try to run the file, here you can see we have a proper output. There is one more concept that I wanted to explain in this video. So what's happening in this video is shapes is an isolated directory, or you can say it's an isolated package which has certain functionality, and we have created a file called as geometry, and this file is interacting with our package of shapes. So conceptually you can call this file as your client and the package of shapes as your API. So what we are doing is we have created a client file which is interacting with our API. It's a very simple concept. Now let us see how we can import functionality from within a package itself. So let me copy and paste this folder, and let me call this as 03 and local package, and let me open this folder in a new window. So I can say code 03. Now suppose you are inside your package of shapes, and inside this package, if you have to work with any of the modules, how would you do it? Let me show you with a small example. Suppose we have a file called as shapes.py, and inside this file we want to import circle, rectangle and square. You must be thinking that we can simply say from rectangle I want to import rectangle. Well, you are partially right, but not entirely right. The way to do it is by putting a dot right over here. So this means that from my current package, so this dot means my current package. From my current package, I want you to go to my module of rectangle, and from that module I want you to import rectangle. Let's do the same thing for circle. So I can say dot circle, I want to import my circle, and also I can say from dot of square, I want to import my square. Now let us go to our client file and let's see how we can interact with this file. So let me go back to my geometry.py. Now this syntax is perfectly fine, it's going to work. But let us use our newly created file. So what we have done is we have created a file called as shapes.py, and we have imported all of the other modules inside this file. So here what we can do is we can simply say from my package of shapes, I want to import the module of shapes. So this shape means this module right over here. And here we can say I want the circle which is inside my module of shapes, and that's it. Let me copy and paste it everywhere. Let me paste it here, and that's it. Let me save it and let me try to run this file, and we have the right output. Let's see if we can further improve our code. So I'm going to copy this folder and paste it one more time, and let me rename this to 04 package underscore init, and let me open up that folder in a new window. So my code 04. Okay, so here we are. So what we were doing in the last video is we created a new module called as shapes, and this module was importing the functionality from all of the other modules. But we can do better. Instead of creating a new module, we can simply take all of these imports, let us copy them, and let us put all of these things inside my init file. That's it. Just save it, and I can get rid of this file. So let me just delete this. It's not required. Now let us go back to our client file. So this is our geometry. Here we can simply say that I just want to import shapes, and that's it. Just save a file and everything should work just as before. So let me try to run this file, and still we have the right output. So what's happening is we are just importing the entire package, and since we have all of the modules which are imported inside our init method, we can have access to all of them right over here. So this init method just acts like a constructor for your entire package. So it's similar to our classes. We were using the same naming convention to have a constructor for our class. The same thing goes over here, but here we are constructing a package instead of a class, and that's about it. I am so excited to see you in the last section. In this last section, we have two projects. The first one is for a cache register, and the second one is obviously is going to be our game. But this section marks a fundamental shift. Till now we have been thinking and writing with our types, but this time we would be seeing how we can organize the code in different layers. Just in the last section we saw how we can create packages. Packages was one way of organizing our code, but now let's try to think beyond our packages. Let's try to think more about in the architecture point of view. Now this concept may sound a little alien, but by the time we are finished with our projects, this concept would be much clearer to you. For now, let us concentrate on the first project. So this project is all about a cache register. But before we can jump in and just start writing our code, I want us to take some time and let us think how we can design this application. So I want you to take back to the concept of VOC-DTP. So this is a very simple concept which I propose for your learning. So this concept stands for your visualize outline code. So this is your phase number one. Once you're done with the first phase, the second phase would be debug, test, and polish. Let us try to see one concept at a time. So this is going to be our problem statement. We simply want to make a simple cache register. Suppose you have a shop and you want to create a software for your cache register. So basically we just want to implement at what's happening at our checkout counter. Just try to imagine what's happening over there. Normally you would hand your items to the cashier. The cashier would scan the item, he will generate an invoice, the cashier would accept the payments, and he will hand over the products to you. So out of all of these things, let us just try to concentrate on the cache register. So let us go to our first phase, which is this one, visualize outline and code. Inside this phase, the first step would be to visualize. Let us try to visualize how our application would look like. Let's try to imagine what's happening inside the cache register. As soon as the cashier scans an item is added to the invoice. Now what happens if the customer wants to change the quantity? The cashier can simply update the quantity. And what happens if the customer changes his mind and he wants to drop an item? Then simply cashier can delete the item from the invoice. The next thing that I want you to think is an item can also have different components such as a discount, offer, tags which can be added to the invoice. Now just to help you visualize how our code will look after implementing our cache register, I have created a nice dictionary. So let me show you. This is how our final outcome should look like. Let me zoom out a bit. Okay, so this is our final outcome. If you watch closely, It's not complicated. It's just a dictionary structure. We have a couple of keys and we have a couple of values. Let's see what keys do we have. The first key is for the customer. The next key is for the invoice total. The next one is for the items, and the last one is for the purchase date. Now let's see at the values. The value for the customer is a dictionary itself. The value for the total is a float. Now here for the items, it gets a little more interesting. This bracket to this bracket, this is the value, and inside this value we again have dictionaries. So these are the different items. So we have one item for an apple, the next one is for an egg, next one for milk, and inside these items we can add different components such as your discount, your quantity, and your subtotal. And for the purchase date, we simply have to display the date of purchase. That's very easy. Now the thing is, I could visualize this data structure just because I have some practice. But the same thing can happen with you. When you practice a little bit more, you can visualize this design even before you can start coding. Let us go to the next step. Let me zoom in again. Let us go to the next step, which is outline. Here what we are trying to do is we simply want to outline our structure. So if you see right over here in this step, we have a couple of different objects. First one was for the customer, for the invoice total, items, and so on. So let us try to outline what components or what classes or what objects we would require inside our application. So here I am inside the next step for outline. Obviously we require a customer. The next thing we require is the item that the customer is buying. And the next thing, which I have already explained, we require an invoice entry. Why do we require a separate invoice entry is because different items can have different discounts or offers, or they could have some kind of taxation. So for the sake of simplicity, let us call this item as invoice item. So this means once we have the item inside an invoice, it will have a slightly different structure. And finally, we have a place called as cash register. So this object keeps a record of everything that is happening on the counter. So let's try to summarize the objects that we are going to require. So we need a customer, we need an item, we need one more for the invoice item, and the last one, obviously we require a cash register. So till now we have much more clarity about our application and the different objects that would be going inside our application. And you would be tempted to just open up your code editor and start writing your code. But I want you to hold your guns. Let's try to do a little bit more planning. So before we can write the code, let us try to describe how our objects, so that means let us try to visualize how all of these objects would look like in the world of Python. So let's see, I have created a couple of diagrams for you. This is how our customer would look like. Our customer would require a couple of instance variable. It could also have some methods and the type of them. And obviously our customer needs a first name and a last name. The type of this one is obviously going to be string. And for the sake of customer, we don't require any methods. Now let us go to the next object or the next class. So this class is for the actual item itself. We need some kind of an identifier so that every product needs a unique ID. So we can have an ID as our instance variable. Then we also need a name for an item. Then we also require a price. In this case, let us keep the type as a float because we may have some decimal places as well. The next one is a little more interesting. We also need one instance variable for the measurement unit. Here the question is, how do you measure the product? It can be in kgs, grams, liters, etc. So we need some kind of a unit that will describe how to measure this item. Now let's go to the next object or the next class. This is our invoice item. This class is pretty simple. It has to accept one item. So I have created one instance variable for the item. And since there can be some kind of a discount, we need one more instance variable for a discount, and the customer can purchase in multiple quantities. So we have one more instance variable for quantity. Now for this class, we require one more method, and that is to have our subtotal. We need some small maths over here. we need to figure out how much is the discount and how much is the quantity. So each item can have a different subtotal, and that's what we are trying to calculate inside this method. Let us go to the next and the last class that we require, and this one is for our cash register. So this class is going to record everything that is happening inside our shop. So let's have a look at the different instance variables. First, obviously it needs to know who is the customer that is making the purchase. It also needs to know the different items that are being purchased. It also needs to record the purchase date. And here you must be thinking that we require one more instance variable to display the invoice total. Well, you're right. But instead of just creating an instance variable, we are going to create a method called as getInvoiceTotal. The reason is we have different items and different items have different subtotals. So let us use this method to calculate the total of all of the subtotals. This is more of a convenience feature. Now let's see what are the methods this class is going to have. Obviously at the cash register you can add an item, you can update an item, you can remove an item, and at the last we can also display our invoice. So till this time we have much more clarity on our application. We have a nice outline in place. We know which classes or which objects needs to go inside our application. We know what instance variables are required, the type of them, the methods that are required for all of these things. So we have a much better design and a much better clarity with us. And now we can think of writing all of these things inside our code editor. But before we can do that, I just wanted to show you one more thing. So the document that I have put together, this is technically also known as a unified modeling language diagram. Well, to be precise, this diagram is a little bit different from the document that I have put, but you can go to Google and check it out. I have left the links in the readme file. And in fact, freeCodeCamp has a full course on unified modeling language. You can click over here to have the link for this one. The next thing is just to translate all of this document inside the code. And I have just shown you, once we are done with our code, the cash register would look something like this. So this is what we are trying and going to code. And this structure that we are going to code can also be imagined to be a data structure. So now we get it. There is nothing big about data structures. It is just a way to represent our data. Here you can say that we have a custom data structure of the type of cash register. In the next video, we will actually start writing the code, and I will see you then. Now let's get going. What I have done is I have created a folder called as 09 projects, and inside this folder I have created one more folder called as project 1 cash register, and I also have this file inside my project. So let me open up this project in a new window. So I can say code, and here it is. So now let's start writing our code. Let us see our outline. Here you can see that we have 4 different objects that are required. So let's start with one of them at a time. Let us create the first file for our customer. So it's going to be customer.py. This is going to be class of customer, and let me define my init method. It's going to be self, and let us go back to the document, and here we can see we already know the instance variables and the type. The 2 variables would be first name and the last name. Let me just collapse my sidebar. So let's create the init method for the first name and the last name. So let me go over here. So my first name is a string, my last name is also a string, and this returns nothing. Here I can say that my self.first name is equal to my first name, and then my self.last name is equal to my last name. Let us create an wrapper method for this as well. So let me say self. This always returns a string, and this can return a very simple string saying that this is a class for customer. Let me add some documentation for the class as well. Okay, so this is the class for the customer details. Now let us create the str method. So this takes in a self and returns a string. So we can say I simply want to return self dot first name, and I also require my self dot last name. Let us go back and see which is the next item. So the next object that we want to create is for an item. So let me open up my sidebar. Let me create a new file called as item.py, and let's see what are the different parameters required. So item requires 4 different instance variables: id of the type of integer, name, string, price, float, and measurement unit, which is going to be a string. So let me go back to my file of items.py, and I can say my class of item. Let me add some documentation. Then let's create our init method. So I can say my init self. The first one was the id, the type is integer. The next one was name, the type is a string. Next one was price, the type is a float. The last one was measurement unit. This is going to be our string. This returns nothing. Let us create the instance variable. So self.id is equal to my id, then self.name is equal to the name, self.price is equal to my price, and self.measurement unit is equal to my measurement unit. Let me add a small comment over here. So our measurement unit could be a kg or ml or so on. Next, let us create the repr method. So I can say repr self returns a string, and I can say return that this is a class of item. Next, let us create the str method. So str self, this returns a string, and we can say return, then we can put the name of the item, and let's display the price. So let's say it's going to be dollars, and it's self.price per unit. So we can say self.measurement unit. Let's go to the document and see which is the next thing that we want to create. So the next thing is invoice item. Things get a little more interesting from here. If you see the instance variable, the first one is an item, but the type is an item. So please keep that in mind. And for this class, we also have a method called as getSubtotal, and this method returns the subtotal after adjusting for the discount and for the quantity. So let's create one more file right over here. Let me call it as invoice item.py. Let me collapse my sidebar, and let's say this is going to be class of my invoice item. Let me add some documentation. Let's create the init file, init self. The first argument is for an item, and the type is item, but this is not going to work because we don't have item in this file. Let us import it from the module. So we can just go right over here, and we can say from the module of my item, I want to import the class of item. Now this will work. The next argument was for quantity, and the type was integer. The last one is for discount. The type is a float. Here we can do one more trick. We can assign the values right over here. So that means if the user does not provide an argument for discount, that means by default the discount would be assigned a value of 0. So this is a very convenient feature of Python. Now this is going to return none. Self.item is equal to my item, self.quantity is equal to my quantity, self.my discount is equal to my discount. Now let's see what else we require. So we also require a method called as getSubtotal. So let's create that method. But before that, let us create our repr and str method. So let me write my repr, takes a self, returns a string, and it can return saying that this is a class of invoice item. The next is for my string, takes the self and returns an str, and let us create a nice string for this. So we can say the item, and let us display the self. Now here I want to display the name of the item, and we can get the name of the item through our type of item. So we can say self.item.name. name. So if you go to the definition of item, you can see we have an instance variable of name. So this is what we are trying to refer right over here. Next, we can say the quantity, and let us display self.quantity. Then let us display the discount. So we can say this is dollars and it is self.discount. We can also display the subtotal. We have not yet created this, but we will create it shortly. So let me write it first and then we will create it. So I can say subtotal would be self.get subtotal. Remember, we have not yet created this method, but we will create it shortly. And let's do one more small trick over here. Let us display only 2 decimal places. We can do that by using the syntax. So we can say colon, and we just want 2 decimal places for our float. Now this line looks a little longer, so let us try to divide it. So let me take this line and let us put a bracket, opening one and the closing one. Let me take it inside and let me cut all of these things till here, and let me go to the next line and let me paste it over here. Okay, so this looks much better. Now this is complaining because we don't have this method till now. Let us go and create this method. So we can say define get subtotal. This just takes the self and this returns the float. Now let us see how we can get the subtotal. What I'm going to do is I am going to use a very simple trick. In fact, I am going to define a private member right over here. So let me put up a comment saying that this is a private member. Let me call it as self._subtotal. Now remember, since I want this variable to be kept as private, that's why I'm using underscore right over here. Now Python does not have a concept of private and public, but this symbolizes to other developers that we want to keep this variable as private. Now let's just calculate the subtotal, which is pretty easy. So we require the price from the item multiplied by the quantity and minus the discount. Now let us go back to this method get subtotal, and we simply have to return it. So I can say self.subtotal. The reason why we are doing all of these things is I don't want any other developer or any other user to accidentally change my subtotal. I want it to be kept as private. That's why I'm using this method. You can also create a property called as subtotal, which is also a valid solution. You can definitely do that. But right now, for the sake of simplicity, I'm just creating a private member. Let us go back to the document and see what is next. So the next one that we want to create is for the cache register itself. So this is the cache register. Note the types that we have over here. Customer is of the type of customer. Then we have the next instance variable items. The type is a dictionary. Then we have the purchase date. The type is date time. And we have a couple of methods on this as well. Let us create a new file right over here and call it as cache register.py. Let me collapse my sidebar and we can say my class of cache register. Let me add some documentation that this is the cache register for each customer. Then we can define the init method. So self. So as we just saw, the first argument is for the customer. The type is customer. We also need to import customer, which we will do shortly. We also need to have one more for the items, and that is a dictionary, and we need one more for the date. But before we can finish all of this definition, let me first go and import customer. So I can say from the module of customer, I want to import my customer. Now let me go down over here. This returns none. Here I want you to wait and think how to create the instance variable in this case. What I'm going to do is I'm not going to accept items over here. Instead, let us create an instance variable directly. First, let us say self.customer is equal to my customer. Here we can say self.items is equal to an empty dictionary. Just imagine, before purchasing anything, the basket is always empty. So that's what we are saying. This has to be items. So that's what we are saying, since we don't have any items inside our checkout. That's why let us assign an empty dictionary to it. But here, how do we define what are going to be the keys and what are going to be the values of this dictionary? Let us write the type hint right over here. Items is my dictionary, but what are the types? Which is the key and which is the value? Let us go back to our design document and try and see what we exactly want. This is a small trick right over here. If you see the design of items, items is actually a dictionary, and inside this dictionary we have the key is of the type of a string. So let us go back to our definition right over here, and we can say the key is going to be of the type of string. Now let's see what is going to be the type of value. So let us go back. The value is of the type of invoice type. So if you remember, inside the invoice item, we have fields for the discount, name, quantity, and we are also calculating the subtotal. So what we can do is, inside the cash registry, we can have the value which is of the type of invoice item. So I can say invoice item. Let us go up and let us also import so that we can use it. So I can say from my module of invoice item, I want to import the class of invoice item. So remember, whenever we are creating these items, the key is always going to be the string. So if we just go back to the design document, here it is inside the items, the key is always going to be the name of the item, and the value is always going to be of the type of invoice type. Let us go back to the class. The next one that we want is for the purchase date. Now we have already seen it earlier. We can automatically create the purchase date by using our datetime library. And that's what we are going to do in this document as well. First, let us go and import. So I can say from datetime, I want to import my datetime, and let us create an instance variable. We can call it as self.purchase date, and we can generate this automatically by using datetime, and we want today's date time. So we can just say now. Let us go down and let us create the wrapper and the str method. So I can say this is my repr self returns a string, and I can say return that this is a class of cash register. Let us also define an str method. We can say self, it returns a string. Here we can just return, and here we can say first I want to display my customer. So let us display my customer. Now what's going to happen right over here is we are simply calling self.customer, and if you go to the customer, so let me open up my customer file. The str of customer file returns a string in this format, first name and the last name. So whenever we are printing this customer, by default we will get the first and the last name together. We don't have to say customer.first name and last name. It's not required. Next, let us also display the total number of items. So we can say total items, and we can get that from the length of our items. So let us go back to the document. Here it is. So items is a dictionary. We have 3 keys: apple, egg, and milk. So that means we have a length of 3. Till now we have been using length with lists, but we can also use length with dictionaries as well. And when you use length with dictionary, it's always going to count the number of items. So that's what we want right over here. So total items is the length of my self.items. Let us now implement the different methods for this one. Let us see which methods we require. So let me scroll a little up. So we require methods to add, update, remove, and so on. First, let us see how we can add items to our cash register. So let us go back. Let us create a new method called as add item. By default, the first argument is self. Now let's see which are the arguments we need to accept. If we have to add an item, we need to know what's the item. So the first argument is going to be an item. The type is going to be an item. Let us go and import item as well. So I can say from my module of item, let me import my class of item. Let us go back to this method. Now since we know which is the item, we also need to know how much is the quantity. So this is going to be an integer, and we also need to know how much is a discount. So discount is going to be a float. We can do one more trick over here. If quantity and discount are not given, we can set some default values. So by default the discount would be 0, and by default the quantity will always be 1. So this returns a none. So let me write none over here. Let me add some documentation, and let us see how we can write the body of this function. Now the first thing is we would like to add an item to a cart only if it is not existing. If we already have this item inside our cache register, we can simply update it. We don't have to add it. So the first check would be for this one. So I can say if my item dot name not in my self of items. First let us type it out, and then I will explain what's happening. So let us go to the next line. Here I want to create a new item, but if you scroll up, the key is a string, the value is an invoice item. So that's what I am going to create right over here. If you find it a little confusing, just go with the flow, and after we are done typing this function, I will explain what's happening. So here I want to create a new item is equal to, the type is an invoice item, so create an instance of my invoice item, and let's see what it takes. It takes an item, quantity and discount that we already have right over here. We just need to pass all of those inside. So the first is for the item, second is my quantity, third is my discount. The next thing that I want to do is I want to set the key and value pairs. Again, let us first type it out, and then I will try and explain. So I can say my self dot items. Now here the key is going to be a string. So this is the part that we are working on. The key is the string and the value is the invoice item. So if you refer the document, I want the key to be the name of the item. So that's what we are going to do right over here. Let us go down, and we can say that the key has to be the name of the item, and the value is the new item which we just created. Now let us go to the next line. What happens if this item is already existing inside our registry? So we can say else. We simply want to print out. We can say item dot name already in cart. You want to update instead. Let me take out one more extra comma. We don't require this one. Now let me try and explain what's happening right over here. Let us go back to this document. Now let's see how the logic goes. So suppose this is my IPython shell. Let me create my cache register. For now it can be an empty dictionary. So this is all good. Now let us go to this line. Our cache register has one key which is called as item, and the value is of the type of dictionary itself. So let us do that over here. So we can say for my register, I want to create one key which is called as items. Sorry, it has to be items, and this is an empty dictionary. Let us try to print it out. So this is how our register is looking right now. We can also use the if and in syntax when working with our dictionaries. Suppose we want to check if our dictionary has one key which is called as items or not. So we can say items in register, and that is true. Let us check for customer in the register. So that's false because we don't have a key called as customer inside the register. We can use the same syntax when referring to items as well. Remember, items is also a type of dictionary. Let us assign some values to these items, and then we can check for the if and in conditions. Let me copy all of this. I just want this one, and we can say for my directory of register, I want you to go to my directory of items. Now what we can do is, since this is a directory, We can also create new keys and new values over here. So here I can say I want to create a new key for my apple, and the value is this one we just copied right over here. So let me just paste it over here. So this is the value, and that's it. Let me just clear all of this. Let us try to see how the register is looking right now. So this is how it is looking. Inside the register we have a key called as items, and inside the items we have apple as of now. Let us copy and paste one more product, this one. So let me copy this, and we can use the same syntax. So I want to say register is a directory. I want you to go and find the key of items. Here let us create another key by the name of eggs, and let us assign a value of this thing to it, and that's it. Let me clear it, and let us see how our register is looking now. So here we have it. First we have an apple, which is right over here, and then we have an egg. Now let us check if a particular product is inside our items or not. So we can say apple in my register. I want to access my dictionary of items, and in this dictionary, so from year to year, we want to see if we have any keys called as apple. We do have, so the answer of this one should be true, and that's it. We have the answer of true. Let us try to search if we have milk inside our items or not. So let me just go and change this from apple to milk. False. We don't have milk inside our items. Now if I just flip the statement, so if I say milk not in, now let's see what we get as the response. So the response is true. Milk is not in my registry. Now since my milk is not there inside my register, only then I would like to add it. If it is existing, then I would simply like to update it. Now let us go back to our code and try to relate what's happening. So let us have a look at this line at line number 24. I am just trying to check if an item is existing in our items or not. On line number 26, so items is our dictionary. The key is going to be the name of the item. So that's what I've taken right over here, and we are assigning this item to the key that we just created, and we have a beautiful structure in place. But this function is not yet complete. The moment we add one item, we also need to update our total, otherwise our logic would be wrong. So let's see how to do that. In order to store the total invoice value, we would also require one more additional instance variable. So let us create one private this time. So we can say this is a private member, and I can say self.invoice total. Initially let us set it to 0. I want the type to be a float instead of an integer. Now what happens right over here, whenever we are adding an item, we also need to increase the invoice total. That's pretty simple. So we can simply say self._invoice total plus equal to, and we can say my new item dot get subtotal. Remember, when we created this invoice item, we implemented this method to calculate the subtotal. And why do we need this method? Because we have to adjust for the quantity and discount, and that's what we are using right over here. So this method gives us the subtotal for the new item, which we simply want to add to our invoice total. But the issue is this method is not reliable. What happens if we have a typo? Instead of plus we have a minus, or we need to do some other validation logic before we can increase the total? The answer is, let us create one function that will increase the subtotal. So let's create one method right over here. So we can say increase the invoice total. The first argument would be obviously the self. Now let's see what argument should we take. If we go down, we can get the subtotal if we have the access to our new item. The type of this new item is an invoice item. So that's what we need to get right over here. So this function accepts an item which is of the type of invoice item, and this returns nothing. Let us add a documentation saying that this increments the total invoice value each time an item is added. Let us go down and let us take this line. This is what we are exactly doing right over here. Let me paste it, and let us change the name of the variable, because the variable we are calling it as just the item over here. So this is the item. Let us go below and use this newly created function. Here we can say I want to self dot, I want to increment my invoice total, and I simply need to pass the new item inside of this, so new item. The last modification that I want to do over here is I want to keep this method as private. I don't want any other developer to accidentally change my logic. Let us go down and let me update this syntax as well. Now we have a beautifully typed and a much more stable code. And while we are here, let us create one more method to decrease or decrement the invoice total. Whenever we are deleting an item from the register, we would also need one method to decrease the subtotal. So let's do it right now. Let me copy and paste all of this. The name changes from increment to decrement. This also changes to decrement, and this becomes removed, and this becomes minus equal to, and that's it. Let us create the next method to update our cart. The logic is somewhat similar to this one, so let me copy and paste all of this. This has to be update. Let me change the documentation, so this becomes to update an existing item, and this one becomes not in the cart, and do you want to purchase instead? Now let's see the logic for this one. We can update an item only if it is existing, so let's do that right over here. So let us change from not in to just in. So if we have that item, only then let us try and update it. But before we can update that item, we need to get the old item back, and we also need to decrease from the invoice total. So here we can say that my old item is equal to my self dot items, and I want to retrieve a specific item, and this item would be my item dot name. So let us go back to our IPython and let's see what's happening over here. We are just trying to retrieve a data. So this is our existing register, and suppose we want to get all of the details for eggs. Suppose we want to update the discount or the quantity and so on. Before we can update, we need to retrieve it first. So I can say my egg details. First I want to go to my register. Now since this is a dictionary, I want to access my key, and the name of my key is items, and inside items I want to access another key. This time the name of the key is x. You can see right over here we have a key called as x. So this will retrieve the value for this one. Let us see what's happening. Oh, there is a syntax error, so this has to be a square bracket. Let us try to print the egg details now, and we have the details in place. And that's what we are doing right over here. We are simply trying to retrieve an item from its key. Now remember, the keys are always string values. So if you go right over here, you can see item is a dictionary and the key is a string. This string is the name of the item. So that's what we want. After we have the old item, we also need to decrement its value. So we can say self, I want to decrement the value, and I simply need to pass an item. So let us pass just the old item. On the next line, we are going to create a new item with the updated quantity and discount, and we are going to add that item back to our register. So all of this logic remains the same. Let us go to the next part and let us see how we can delete an item. But first let me go back to my IPython shell and let me show you how to delete an item from a dictionary. Let me clear all of this and let us print our register one more time. So you can see register has a key of items, and inside these items we have two another items. One is for apple and one is for our eggs. Suppose we want to delete apple. Let's see how to do that. The way to do that is by using a keyword called as delete, and after this we simply need to specify which key we want to delete. So I want to say I want you to go to my register. From register I want you to access my items, and once inside my items I want you to delete my key of apple, and that's it. Now if we try to print a register, and you can see we have deleted apple. Let's use this syntax right over here to delete an item from our register right over here. Let me copy and paste all of this. Let me take a little up. The name is remove. We don't need the quantity and the discount. We just need to know the item that we are supposed to delete. Let me update the documentation. So this is going to be removes item from our cache register. We don't require this as well. Now let's see the logic. We can delete an item only if it is existing, and that's what we are checking over here. So we need this logic in place. Since we are not creating any item, we can delete all of these things. Here we are retrieving an item. The next line we are decrementing the invoice total. Now we simply have to delete it from our dictionary, and we have already seen the syntax. So we can say I want to delete from my items, and the key would be my item dot name. And let us see what else is remaining. Let me go back to my document, and we have to implement these two methods, get invoice total and display, which are pretty simple. Let's create the first one. We can say get invoice total. This takes a self and this returns a float. Let me add some documentation, and here we simply have to return self dot underscore invoice total. The last one is to display our invoice. So let us create some pretty looking output. So I can say display my invoice, takes the self and it returns nothing. Let us try to visualize how our invoice would look like. Now this is the code from my GitHub repository. I'm inside my projects and project number 1. If I run this file, I have a output, and this is how our invoice would look like. So on the first line we would like to have a nice separator, followed by the customer details and followed by the date of the purchase. So let us go back and let us do all of these things. Here we can create a nice separator line by using a print statement, and I would just like to say that this is my separator multiplied by 70 times. So what this is going to do, it is going to repeat this symbol for 70 times. Before this, let us insert a blank line. So we have a nice spacing in place. Next, let us see what we want. We want the customer details and the date. So we can just go back, and here on the next line, I can simply say I want to print self. And if you see our str method, that's what we are doing right over here. So this is our string method, customer, and followed by the total items, and that's what we want right over here. The next line is for the date. So let us go down, and on the next line we can say I want to print my date, and we already have it. So I can say self dot purchase date. Now remember, in some of the earlier videos we formatted this date and time according to the month, day and the year. That's what we are going to do right now as well. So I can use the method called as string format time, and let us give us a format. So this format stands for the month, the day and the year. Let's see what we need next. Next we require one separator, and after the separator we require all of the items. So let's get back and let me copy this line from here. Let me change the separator from plus to a dash, and the next line we want to print all of the items. That's pretty easy, so I can just say for my item in my self dot items dot values. Let us print out the item, and this has to be brackets because we want to get the values out of our dictionary. Next, let us see what we want. So we require one more separator, total price, and one last separator. So let's do that. Let me copy and paste this right over here. On the next line we can see that my total price would be in dollars, self dot get invoice total, and let us display only 2 decimal points. So I can say colon, and I want 2 decimal points for my float, and that's it. Let us go back and check. Oh no, we require one more separator. So let me copy this and paste it right over here. Now we have a way to display our invoice as well. We are using multiple print statements, but if you want, you can use a template, or you can also use a multi-line string as well. But this is much more simple for now. Now let's get back to our document. So we have everything in place. Let us check what's remaining. So code, we have cash register in place. Now we just need to find out a way to interact with our cash register. So that means we just need to create a client that can interact with our register. So let me create a new file. Let me name it as register.py. So this would be our client file, and here obviously first we need to import our cash register. So let me collapse my sidebar, and I can say from the module of cash register I simply want to import my cash register. Then we also need a customer, so I can say from my module of customer I need customer. The last thing I want is the item, so I can say from item let's import item. Let's create the first item. So let us create milk. So we can say milk is an item. Let's give it an ID of 100. The name would be just milk. Price could be $4.5, and the measurement unit can be a liter. Let us create our customer as well. So I can say my customer 1 is my customer. The first name is Louis. The last name is Zappa. Now this customer is going to the store and making an purchase. So let us create a cash register for Louis. So we can say this is my cash register number 1. We simply have to give the customer, and that is our customer number 1. Let us try to print out our cash register right now. So I can say print my cash register 1. Let me save it and let me try to run this file. So right now the customer is Louis Zappa, and the total number of items is 0, and that's true because we have not yet added any items. So let's get back and let's make Louis purchase something. So here we can say that my cash register 1, I simply want to add an item, and the item I want to add is my milk. Now we can give some additional arguments as well, the quantity and the discount. Right now let us go with the default values, and let us try and save and run this file. Now we can see we have one item on our invoice. Let us go back. Let us create some more items. Let us create one as egg. So I can say item, the ID could be 101, the name is egg, the price could be 99 cents for one egg, the measurement unit is for a piece. Then we can make one for rice. We can say item, ID could be 102, name is rice, price could be $4 for a kg. Let's create one last one, maybe For an apple, we can say item, ID could be 103, the name is apple, maybe it is for $5.67 for a kg. Now let us make Louis purchase some other items as well. Suppose Louis also wants to purchase eggs, so we can say cr1.add items. So Louis wants to buy some eggs. Suppose this time he is purchasing 12 eggs, and for a quantity of 12 eggs there is a discount of 50 cents. That's it. Let us save the file and let us try to run this. So this time you can see we have 2 items in our invoice. A little better way to display the invoice could be by using our inbuilt function. So let me take it out and let me say cr1. I want to display my invoice. Now let us try to run this file. So this time we have a much better output. So we can see the customer is Louis Zappa. There are 2 items. This is the date of his purchase and these are the items. Remember, for the egg we specified the quantity was 12 and there was a discount of 50 cents. That's what we have over here. Here you can see we have only 1 item, so the subtotal is 450. For this one we have 12 items minus the discount, and so the subtotal is right over here, and right over here we have the total price as well. Let's try to play a little bit more with this one. Let's try to update one item. So suppose Louis thinks that 12 eggs are like a lot and he wants to buy only 10 eggs. So we can say I want to update my eggs, and this time the quantity is 10. But fortunately the store is in a good mood and the store is offering a discount of say $1. So let us save it and give it a try. So you see we have an updated quantity of 10, discount of $1, and we also have an updated subtotal as well, and automatically the total price also gets updated. Let us go back and let us try to add one more item. Suppose this time Louis wants to buy some rice. Maybe he wants to buy 3 kgs of rice and there is a 75% discount on this one. So let me save this and let us run the file. So this time we have 3 items and we also have rice in our items as well. Let us go back. Now let us see if we try to add an item which is already existing, then what happens. So let me copy and paste this one, save, and let us try to run the file. So here you can see we get the prompt saying that rice is already in cart. Do you want to update instead? So you can see all of our code is working beautifully. And if you see right over here, nothing is changed. Everything is just as before. Let us go back. Now what happens if we try to update an item which does not exist? So suppose we say that we are trying to update an item. Maybe we are trying to update for apple and the quantity could be 10, the discount could be 0. So let me save it and let me try to run this one. So again we get a nice message saying that apple not in cart, purchase instead. And if you see the invoice, it's just as before. There are no changes to our items. So let us go back. So right over here we can say that we want to remove eggs, and let us try to display our invoice after removing as well. So let me copy this and let me paste right over here. Let me run this file. So here you can see this is the earlier invoice. In this invoice we have eggs, and this is the next one. When we remove, we don't have eggs in our invoice. So you can see we can also remove an item from our invoice. I also wanted to show one more trick right over here. We can also create an alias for customers. Suppose there is a big application and there are 2 files, and inside both of the 2 files we have a class of customer. Then we can create an alias. So we can just say that I want to import customer as my customer, and we simply have to update one line over here. So this, instead of a customer, this will be called as my customer. Just save your file, and if you try to run it, everything works smoothly. Let us go back and let us create one more customer just for the last time. So we can say my customer 2 is my customer, and first name is Chico, her surname is Neutron. Let us create a cache register for this one as well. So this is going to be my cache register for my customer number 2. Suppose she's purchasing some milk and the quantity could be 4 liters. Here I can also use my keyword syntax, so I can say my quantity would be 4, and suppose we have a discount of $10. Let us try to add one more item. So this time she wants to buy some eggs and the quantity is 25. Next she decides to update the quantity of eggs. So next time the quantity is 48. Now fortunately the store is offering a discount of $12 on the quantity of 48. Chico also wants to buy some apples, so let us buy some apples as well, and let us display the invoice. That's it. Let me save the file and let me try to run this file. So here we have the invoice for Chico. So Chico has 3 items: milk, egg and apples. For the milk the quantity was 4 liters, the updated quantity for eggs was 48, and for apples it was 8, and this is the total price. Now we have a beautiful program in place. Let us go back. I wanted to mention one point over here. If you see the code inside my GitHub, so this is the code downloaded from GitHub. My GitHub file has a couple of more methods. For example, if you go to cache register, I have a couple of extra methods. So all of this is extra, and I had to create these methods because I wanted to see the output in a dictionary format. So if you go to this document, I wanted to have the output in this format. So that is why I had to do a couple of more work, and that's the reason why you can see all of these methods. But I am not going to explain all of these methods inside this tutorial. If you want, you can give it an attempt and try and study what's happening. But to just give you a short idea, I am converting everything to a form of a dictionary, and finally I am exporting that dictionary to a JSON format. That's why I can have a nicely formatted output. Now if I go to this file register, so this is on my GitHub code. So here I'm using this method to JSON to have a nicely formatted output. Now if you run this file, I can get the output in the way I desired. I hope you learned something new in this video. Now this video had a lot of concepts and it was very densely packed. So if you don't understand any concept, you are not to be blamed. It's quite natural that it will take you some time to understand. Maybe you have to go through this video a couple of times. You will also need to have some better understanding of how to work with your dictionaries before you can understand what's exactly happening in this code. So this project is going to test all of your basic understanding of Python up till now. Now the next game would be much more easy to implement, and I will see you in the next video. I am so happy to see you in the last part of this entire tutorial. The last part is all about our game, saving Zortan, and in this final project we would be actually implementing how to think in layers. First we will write all of the code, and then I will try and explain why we did what we did. So for starters, I have created a folder called as project 2 saving Zortan. As you can see, it's all empty. So let me go and let me copy my file. It's right inside my section number 6. Let me copy this and let me paste inside my project number 2. Let me open up the project in a new window. So I can say I want to open my project number 2, and that's it. We have a nice and clean slate to work with, and this is our existing code. Now let's begin. Till now we have seen how to organize our code in different modules, but for this game we are going to create a package of game, and that package will contain all of the logic and everything that goes for creating a nice game. So here I'm going to create a package called as game, and as you know, making a package is very simple. It's just like creating a directory. So let me create a directory, let me call it as game, and let us create our init file so that Python knows that this is a package. Now let me drag and drop this file inside my package. Yes, I want to move. Now let's begin with our code. So let us get started. Let me open up this file and let's see. The first one we have for the character type. So what we want to do is we want to make our game as modular as possible. So what we are going to do is we are going to take out everything and everything goes inside its own module. So inside my package of game, let me create a module by the name of character type.py. I simply have to copy and paste everything. So right from here, I need the imports. Let me take all of this. Let me cut it out, go to my character type and paste it. Let us see what's next. The next one is our character. So let's create one more module inside our package of game and let us call it as character.py. Again, I simply have to cut all of this. So let me take everything from here. Let me cut it out and go and paste right over here. Let us go back. The next is for the superhero. So again, let us create a new file, superhero.py, and let me take everything from here. Let us cut it out, go to our superhero file, let me paste this, and we can see we have a couple of errors, and that's because we need to import character and character type. So let me go to the top. Now here, since we are working inside a package, we need to say that from the current package, the module of character, I want to import the class of character. The same thing for character type as well. So from the current package, I want you to go to my module called as character type. I want you to import my character type. Now if you save, all of the errors will go away. Let us go back. The next one is for a villain. So again, go back right over here. Let us create a new file called as villain.py and let us take all of these things. Let us cut it out and paste it right over here. Also, let us do our imports. So from character, import character. From character type, import my character type. Let us go back. So the next one is for the life. Let us create a new file called as life.py and let me take all of these things till the last, till here. Let me cut it out and paste it right over here. Let me save it. Let's go back to this file, and if you see, this file is pretty much empty now. So let me delete all of the blank lines from here. I don't require all of these things. Let me take out the documentation as well because we already know what it's all about. We don't require this as well. So let me go on the top. So we have a much smaller file this time, and let's see how we can improve even further. But before we can go a little further, I wanted to add a couple of more classes. The first class that I wanted to add is for a player. It would be so nice to have a player. So let's create a very simple class for player. So let me say my player.py. This is going to be my class of player. I can define my init. The first is obviously the self. Next could be for the first name. This is string. Next for the last name. This is also a string, and this returns nothing. I can say self.firstName is equal to my first name and self.lastName is equal to my last name. Let us create the wrapper method. So I can say repr and self. This returns a string and it can return saying that this is a class of player. Let us create the string method as well. So our self, this returns a string. So let me just return the first name and the last name. So I can say self.my first name and self.my last name. That's it. And this time we are going to have one more class, and that class is for the game state. Just imagine when we are just starting with the game, we can have a different state, maybe initializing. When we are playing, the state changes from initializing to in progress. And at the last, the state can change to either win or lose. So we can keep a track of the state by creating a new class. So let us create a new module right over here. So this is going to be called as my game state.py. For this I am going to use the enum. So I can say from my enum I want to import enum and auto. Then I can say my class of game state, which inherits from enum. Let me add some documentation. First one we can call as initializing, so set it to auto. Next one for in progress, again set it to auto. The last two would be for the win and the lost. Let's take a moment to review what we have done up till now. We have created a module for each of the objects inside the game. But if we have a look at all our modules, they are basically structures for something. For example, character, this is a structure for something. Character type, again a structure for the types of characters. Game state, the types of game state that we can have. For player, again we just have a structure. The same thing for superheroes. So this is just a structure for superheroes and so on. So technically we can call all of these structures as schemas. So schema simply represents a structure and that's it. So let's create another package inside the game of package called as schemas, and let us put all of this functionality inside that package. So inside my game, let us create one more folder by the name of schema, and to make this folder a package, let me create file inside of this. It has to be again init __.py. So let me collapse all of these things. On the top level we don't have anything, we just have a package of game. Inside the package of game we have another package called as schema. Now let us move all of the schemas into the right package. So my character type, my character, game state, life, player, superhero and villain, all of these things will go inside my package of schema. Yes, I want to move everything. So let me collapse my schema right over here. So inside my package of game we have three things. First one is another package of schema, then our init file, and last one is our game file. Now let us go back to our game file. Let's see what's next. Here we can see that we are retrieving all of the superheroes, or we are retrieving a single superhero. Normally in an application you would have a database where you will store all of the superheroes and all of the supervillains, and that database would be controlled by something which is called as a models. So just to get a feel of models, let us create one more package inside game. So inside game, let me create a folder called as models, and inside this folder let us create an init file to make it a package. Let us go back to my games file. Now what happens in an application whenever you want to interact with a database? So you can imagine all of these things to be a part of the database, because this is the place where we are storing all of our data. So normally a model would do all of these things for us. So let's go into models and let us create one model for our superheroes. So this becomes my superheroes.py, and let us create one more model for our villains. So this would be my file for villains.py, and let us start writing our code inside of this. So first let me go to my superheroes. So let us declare a class called as superhero model, and let us create the init method. Now this init method does not take any argument because we don't need anything, and this returns nothing. Now for the instance variable, we can simply return all of the superheroes or a single superhero. So let's see how we can do that. We can declare an instance variable called as self.all, and we can return all of the superheroes. But let's see how to do that. For now let me assign it a blank list. Let me go back to my file of my game. Here I just want to cut out all of this functionality for get all superheroes and get superhero. let me cut it out, go back to my models file, and let me paste everything right over here. Now since this belongs to the class, I want to take it inside, so let me take it inside the class. And since now these are members of the class, the first argument has to be self, and here as well the first argument has to be self. Now let's see what to do next. Now this method called as get all superheroes, it returns a list of superheroes. So this means that this is the schema of the superhero. So let's import it. Let me go to the top. Now what happens is we are inside the package of models, and the schema of superheroes resides in some other package called as schema, which is right over here. So here we can say from my package of game, I want to go to the package of schema, and from here I want to go to the module of superhero, and once over there I simply want to import my superhero. Now you can see all of the errors are gone. Let me save this. The next thing is this is complaining because we have not given the types for this one. So self.all is going to be a list of all my superheroes. Right now it is blank, but we can easily get it from this method. So I can say this is just my self.get all superheroes, and that's it. So what this method is doing is it already has the data for all of the superheroes. On this line it is creating a list, and on this line it is returning that list. So we have access to all of the superheroes. Now what happens here is, since we have an instance variable called as self.all, we don't have to expose this method to everyone, and so we can make this method as a private method. And you know the way to make it private is by putting an underscore. So this syntax has to be updated right over here. So this also becomes my underscore. Now let us go to this one. So this has to be my self dot underscore get all superheroes. And in fact, we don't require this line at all, because this time we already have a class and we already have access to all of the superheroes inside our instance variable called as self.all. So what we can do is we can take out this line, and here we can simply check for the length of self.all, and this also gets updated to self.all, and everything is looking beautiful. Let us also create the string method right over here. So we can say define my str, it takes self and it returns a string as well. Now let's see what we would like to display. Now since this model represents our data, we can simply print out a list of our superheroes. So let's do that over here. So what we can do is we can simply print out the names of our superheroes inside a list. Let's see how to do that. First let us create a list for all of the names. So this can be a list of string, and let me assign it to a empty value. Then let us just populate this list with all of the names of the superhero. So I can say for my superhero in my self.all, I simply want to append to my list of names. So I can say name.append, and each time I want to append the name of my superhero, so I can say my superhero and his name. And let's see, we have an error, missing return statement. Oh yes, we are not returning the list, so we can say return my list of name. Now we have one more error, and this error is because the return type is a string, but we are returning a list. So let's do one thing. Let's use our formatted string. So I can use my formatted string, and let me put this inside my curly brackets. Now everything is looking good. Let us repeat the same thing for our villains as well. So let me copy all of these things from this file, go inside my models, then to my villains, and let me paste over here. So this becomes my villain, this becomes my villain, this also becomes my villain, everything changes, this also becomes my villain. Again, here we have a villain. Let's change this one as well, and this also needs to change, so this will be villains. We don't have this method as of now, but let us go to the games file and let us copy everything right from here. So let us cut all of these things and go inside our villains model. Let me paste everything over here and let me take everything inside my class. Now since this belongs to a class, let us add self. Then this becomes a private method. Then we need to add self over here. This line needs to go. This line becomes my self.all. Same thing over here. This also becomes my self.all, and this is just for our super villains. Everything is looking really good. So till now what we have done is we have segregated our code as per its functionality. Wherever we had only the structure, all of those files went inside my schemas, and where I have to interact with my database or my data, those files went inside my models. Now let us go back to our games file. So this is my game file right over here. Let us start deleting all of these things which are not required. So let me take it up. If you see, we would have a bunch of errors. Now let's try to work on this file. Now this file is all about the game and the actual logic. So this is the place where we are actually implementing the game. So the first thing that I want to do is I want to rename this file. Now since this file is all about implementation, I like to call this file as just IMPL, so which stands for implementation. You are free to name this file whatever you want. You can call this file as your logic, your brain, or anything that you want. But for me, implementation makes much more sense. Now let's see what we can do inside this file. First, let me close this folder and this one as well. And let me only open this file. So this is where we are working right now. Our implementation is all about a game. So the first thing that we require right over here is we require a class of game. This class will keep a track of everything. It will keep a track of which player is playing the game, what is the game state, is the game in progress, or someone has won or someone has lost, what is the state, who are the superheroes and who are the super villains. And this class is also going to control all of the methods that we have defined over here. So it's going to control our attack and our win or lose as well. So let's create a class. So this class is like the implementation of the entire game. Let us create a class called as game. Let us define the init method. It takes a self. Now this init method only requires a player. We will just take one player and we will initialize a blank game in return. So let's accept one player. The type is a player. Now remember, inside our schemas, we already have a player which is right over here. So let's go and import the player from our schema, and we need to do one more change. So this is not a single schema, this is schemas. So let us add an S. Yes, we want to make some changes. Now since we have changed the name of the package, let us go to our models. So by default, Visual Studio Code is going to do this for you. But if it is not happening inside your IDE, then make sure this is schemas, and for villains, this also needs to be schemas. So let me go back to my implementation file. So here on the top, I can say that from my current package. So remember right now we are directly inside our package of game. So let me collapse my models and schemas. So you can see our file of implementation is at the same levels as our models and schemas, and game itself is a package. So we can say from the current package, I want you to go to the package of schemas, then go to the module of player and import our player. Let us go to this line right over here. So our init method returns nothing. Now let's see what kind of instance variables do we require. First, let me write all of the instance variables, and after that we can populate them. The first one would be for the player, and we already have the data that's right over here, self.player. Next, I want to keep a track of the game state, so I can say self.state would be my game state. We will import that shortly. Let us create the next variable first. We also need to keep a track of all of the superheroes and all of the supervillains. So let us create an instance variable for all of the superheroes. Let me get my spelling right. This has to be my superheroes, and we need one more variable for our villains. Now let's see how we can populate all of these things. For the state, we already have a game state defined inside our schemas. So we can say from the current package, go to schemas, go to my game state and import my game state. Now let's see, the first time we don't have any data. So we can assign the state to initializing. So we can just say my state would be game state dot initializing. Now let's see for the next one. We can get all of the superheroes from our models. So let's go and import our models as well. So I can say from my current package, go to my models, go to my superheroes and import my superhero model. Let's do the same thing for our villains as well. So dot models dot villains, import the villain model, and here we simply want to initialize it. So this becomes my superhero model, this becomes my villain model. Now just remember, when we created the model, so if you go over here and if you see the superheroes, you can see the constructor does not accept any argument. So that's what we are doing over here. We are not giving any arguments because it is not required. And with this, we can easily have access to all of the superheroes and all of the supervillains as well. Let us create the wrapper and the string methods for this as well. So we can say my wrapper method takes a self, this returns a string, and let it return that this is a class of game. Next, let us create an string method as well. This returns a string. Now let's see what we would like to return. Maybe we would like to return all of these details on separate lines. So let's see how to do that. So I can say I want to return a formatted string. Let me collapse my sidebar for a while now and let me take it up. So the first thing that we want to display is obviously the player, and we can say self.player. Now we want to display the state on a next line. We can use a small trick over here. We can say backslash and n. So this is going to create a new line for us automatically. And on the next line, I would like to display my state. So I can say the state would be my self dot, let me put a comma here as well. So on the next line, I would like to display my superheroes. Oh, I need a quote right over here. So I can say my superheroes would be my self dot superheroes. Let me get my spelling right. Let me put my comma, and we require one more line. Now since this is getting a little long, let me split this. So let me put a brackets and let me take it down, and let me add one more formatted string right over here, and this would be for our villains. So we can just say that self dot our villains. Let us go below and let us take all of these things inside our class of game. So let me copy all of these things, the method of attack, the method of simulate attack, and we also need this method of win or lose. Till this point, I want everything inside my class. So let me take it inside. Let me save the file, and now we don't need all of these things because right now we are just creating a package, and we will see how to use this package in the future. So let me take it out, and you can see we have a bunch of errors. So let's try and work with our file. So let's work with this one. So this is the place where the attack is taking place. So I can just say this block is for the attack. Now since this belongs to the class of game, we can write self. Same thing will happen with our simulate attack as well. So I can just write self right over here. So let me save this Again, this also has to take myself. Looks good. Now let us go back. Now let's see how the attack is going to take place. Now let's fine tune our attack logic. Let me put some documentation. So whenever we start an attack, we can change our state from initializing to in progress. Inside this, we can say self.state. So when we start an attack, it changes to my game state.in progress. Then let's print out a nice line saying that start in attack. And if you want to check the state, we can simply print out the state as well. So you can just say my self.state. So let us go down. Now let us have a look at this line. At this line, we are trying to get a single superhero, but now we have this method inside our model. So let me open up the file. Inside models, if you go to our superhero, now we have created a class called as superhero model, and inside this class we have a method called as get superhero. So let us try to reference this method right inside our implementation file. So what we can write here is we can simply say that we want to go to the self dot our superheroes. So remember, this superhero is actually the superhero model. Let me show you one more time. So you can see this superheroes is actually the superhero models. So we can access this method right over here, get superhero, and that's the way we can get our superhero. Let's do the same thing for the villain. So I can say my self dot villains dot get villain. Let me collapse my sidebar. Now let's go to this line number 43. So since this method belongs to the class, it has to be self dot. Now what this method is doing, it is actually doing the attack. So we can have a little better naming convention. So we can just change the name from simulate to do the attack. Let me change right over here also. And we can do one more thing. We can mark this method as private because this is all about our internal logic. No one has to know how we are doing the attack. It's up to us how do we implement the logic. This also needs to be my double underscore. You can write a single underscore. It's up to you. So this simply means that this method is just private to this class. Now we have a bunch of other errors for superhero, villain and life as well. So let's import all of this and all of the errors will go away. Let us go to the top, and here we can say from my schemas, from my superhero, let us import my superhero schema. The same thing we can do for the villain as well. So from dot schemas dot our villain, let us import the villain schema, and we can do the same thing from dot schemas dot my life. Let me import my life, and let's see what's happening next. So you can see a lot of the errors have gone. Now this is a pretty easy error to fix. We just have to import final and that's it. But let's not do it right over here. Let us create a new file called as constants. Now let me explain why do we require a new file called as constants. There may be times where we can have multiple constraints for our game. For example, let us go right over here in this method of attack. You can see that we have hardwired the value right over here 3. So we have 3 over here because we have 4 superheroes, and we have 2 over here because we have 3 supervillains. So we can think that all of these are simply constraints for our game, but we can make our game much more modular. What happens if you want to attack 4 times, 5 times, or what happens if we have multiple superheroes or multiple supervillains? We need to have a very easy method of doing all of these things. So for this convenience, let us create a new file inside our game. Inside my package of game, I want to create a new file called as constants. Let me add some documentation. You can imagine this file to be just a helper module, and that's what this is doing. The first one was for the number of attacks. So we can just say the number of attacks, and we can assign a value of 3 over here. Now let us go back to our implementation file, and instead of hardwiring 3 over here, let us import that and let us use that constant over there. So we can say from current package, go to the module of constants and import my number of attacks. So let us go down and let us use that right over here. Now we can increase and decrease the number of attacks as desired. Let's go little down over here. Let us do the same thing for this one. Let us take it out. So these values are never going to change. They are going to be constants no matter what. So let me cut it out. Let me go to my constants. Let me paste over here. Let me fix the indent. Now you already know that we don't require a final keyword, because when we name all of this in uppercase, by default MyPy or our IDE is going to treat them as constants. So we can take this one out and this one as well. And in fact, we don't require string as well, because our IDE would be able to infer all of those things. Let us go back to our implementation and let us import it. So let me go to the top. So from constants, I also need to get my winning message and also my loss message. Let us go down. Now since we already have access to winning and the losing message, we don't have to do anything. Let me take out this line. This is not required. Now let's see what's happening right over here. Here we also need to update the state of the game. Suppose we are winning, then we can say self.the state would be my game state dot win, and in case we have lost, then we can say game state dot lost. So now we can keep a track of the state of the game at any given point of time. There is one last thing to do in this file, and that is right over here. So here if you see, we are using 3 and 2 because we have 4 superheroes and we have 3 supervillains. But what happens if we decide to add a couple of more superheroes or a couple of more supervillains? So let's try to make this code a little bit more modular as possible. So what we want to do right over here is we can simply say I want to have the length of my self.superheroes.all minus of 1. Now remember, your index is always 1 less than the length, and that's what we are doing right over here. Let us do the same thing here as well. So I can say the length of my self.myvillains.all, and I want to minus of 1. The last thing to do inside this package is to create a file, and let us create a file. Let us name it as game.py. Now this file will have a single line of code. So first let me write it and then let me explain what I'm trying to do. So I can say from the current package, I want you to go into my implementation and I want you to import my game as well as my player, and that's it. So what we have done is we have created an API, which means your application programming interface. So whenever some other developers have to interact with your code, or if they want to play your game, they simply needs access to just this one file, game.py. They don't have to import any of these things, models, schemas, constants, implementation. Nothing of those things are required. All of those things are our internal implementation. The clients don't need to know all of the logic. They simply have to consume our logic. That means they simply have to consume our API. So now we are getting the logic. We have been creating our application in different layers. So this was a layer just for our schemas. Models was just a layer for our database, or rather data in our case. And this game, this file acts as our API. Now let us create a client file and let us play our game. So outside the game, let us create our client. So let me call it as main.py. So by convention, main is always going to be the most important file or the place where our program starts. And as a convention, we require a function which is called as main. So this is the place where Python will start all of our execution. So this file can also be thought as your client. Let me put up a documentation. So this file, or rather this module, is just as a client. It is going to consume our API game, and that's it. Let us import our API. So we can say from my package of game, I want you to go to the module of game, and from here I simply want you to import my class of game and player. Now this looks a little odd, game.game, but what we can do, we can improve our design with a small trick. So let us go back to our package of game and let us go back to the module of game. Let me copy this single line and let me put it inside the init file. So this init file is for the game. So I can just put my init file right over here. Now I don't require this module. Let me take it out. Yes, move to trash. Let me add some documentation over here. So since we have this inside our init file, we can simply write from game import game and player. It becomes so simple. Now let us go back to our API file, which is this one. Now the beauty of creating APIs is with time your game is going to evolve, and sometimes you may have some breaking changes. So this was our first version. Maybe you can have a version 2 or maybe you can have a version 3. But at that time the client does not need to update his code. We can refactor all of the code inside, but just keep this API file the same. So you see we have a lot of advantages of breaking our application into multiple layers. Now let's get going to the last part and let us create the main method where we can actually play our game. And fortunately this is the most easiest part. Let me collapse my sidebar. So this is returning nothing, so I can say none. Let me put some documentation. This is the place where our game begins. Let us create the first player. So we can say my first player is my player and Louis. The last name is Zappa. Now let's create a game for Louis. So we can say we want a game for our player number 1. Here let us just check the state of the game, and since we are just starting the game, our state would be initializing. So let us just check if that's the case or not. I want to see the state of my game 1. So game1.state. And the last thing to do is we need to invoke our main method. So let me save the file and let me try running it. Beautiful. So as you can see, we have the state of initializing, and that's what we expected, right? Now let's start with the attack. So here we can say I just want to have my game1.attack. But before that, let us try to print the game itself. So let me say print, I want to print my game1. Let me comment this for a moment, run the file, and this is how your game looks like. The player is Louis Zappa, state is initializing. This is the list of all our superheroes, and these are all our supervillains. Beautiful, isn't it? Let us go back and let us have the attack first. So we can say I want to have my attack, and after the attack I want to see if I am winning or if I am losing. Let me save it and let me try to run the file. Amazing. So we have a very beautiful output. Unfortunately we lost and Thanos killed our Avengers, but it is such a beautiful experience. Let us go back and I want to make one last small change. What we can do is we can create something which is called as method chaining. That means what if we have a syntax like this, game1.attack, and here we can just say .win or lose. So this will look so neat and nice. Let's see how we can do that, and it's very easy to do it. Let me open up my sidebar. Now remember, all of the implementation happens in a single file. So it becomes very easy to find out where do we need to make our changes, and all of the changes happens in this file for implementation. Now since we want to have method chaining, we simply have to return the game. So that means on our method of attack, we simply want to return the game itself. So I can say this method is going to return my game. Let me collapse my sidebar, and I also need to return. So at the bottom right over here, let me go on the next line. I simply have to say that I want to return self. Now in order for this syntax to work, we need to import one more thing. So let me go to the top. The first thing that we want to do is from future, I want to import my annotations. Now we can use this syntax. Let us do the same thing for our method of win or lose. So this returns a game, and at the bottom let me just say let me return self. Beautiful. Let me close this file and let me go to my main file. We can assign the game back to our variable. So I can say game1 is equal to my game1. Now let us print the state one more time right over here. So what's happening is we are starting with an attack, and then we are checking if we are winning or losing. Initially the state would be initializing, and after the game it could either be win or it could either be lost. Let me take this little up. So the first thing that we want to do is we want to print the game, then the status, then we play the actual game, and let us have the state back again. So let me save this and let me play this game. So here it is. So this is our game right here. The player is Lewis, state is initializing, superheroes, supervillains, beautiful. Then we are starting the attack. After we start the attack, the state changes to in progress. This is how the attack is taking place, but unfortunately Thanos has killed Avengers, so our final status is game state lost. So let us play one more time. Let us see if we are winning or not. No, lost. No, lost again. Lost, lost, lost. Oh, this time we are winning. It's so amazing. So here you can see that when we won the game, our state is game state win. It's so damn amazing. Let us create one more player and let us play the game for the last time. So let me go right over here and let me create one more player. This player would be Chico Neutron, and let us go down over here. Now just for the sake of nice printout, let us print a blank line before the next game. So here we can say my game number 2 would be my game, and this time we can say my player is going to be my player number 2, and we can start playing the game here itself. So we can say dot attack, and after the attack I simply want to check if I am winning or if I am losing. This method chaining makes our game so easy to use. So let me save the file and let me play the game for the last time. Oh, I think both of us lost. Chico also lost the game, and Lewis also lost the game. Let us play the game one more time. No. Oh yes, at least this time Lewis has won the game. Before we say we are done, let us have a look at the last time. Now there is no more coding left. I just want to show this file, and this file is called as thinking in layers. So let me collapse my terminal, my sidebar, and let me put this in my preview mode. So this is the last thing that I wanted to show you. Let us try to conceptualize what we have learned so far in this video by making this game. So what we did was we divided our application into multiple layers. Now let's see what we exactly did. You can imagine the first layer was our data layer, and the packages who are responsible for our data layer live inside the folder, or rather the packages of models and schemas. The visibility is private and the role is internal. So what happens is whenever we want to interact with the database, whenever we want to create a structure, all of that code will go only in these packages. The advantage is when we have multiple people working on the same project, all of us can know where to find the data. The next layer can be thought as our business logic layer, and this layer is represented by our implementation, and we have all of our implementation inside this file impl.py. Again, the visibility is private and the role is internal. That means we as the developer of this game or of this library, only we can handle this file. The next layer can be called as an API. The package of game can be thought as our API. Remember, we added a couple of files to our init method, and our client can simply import all of those things from our package. So essentially what is happening is our API is acting like an interface between our internal logic and our consumer. So the visibility of our API becomes public, and our main.py file can be thought as a client because the client simply consumes our API. And I hope this gives you a much better understanding of why we divided our code so much and why we created so many packages. Now that was such an amazing effort, and I would like you to congratulate yourself. This was a pretty tough and a very intense course for a beginner, and you definitely deserve much needed appreciation. You have done an amazing job. Wow, that was one really awesome journey, and I am so happy to see you at the end of this course. Now remember that the course is just ending, but your journey is just starting and you have to do a lot before you can really understand Python. The first thing that you need to do is you need to solve a lot of problems. And I also have a couple of topics that you can see if you want to progress in Python. And here they are. So this is what you should be learning next. Have a look at how to handle files and folders. Iterators and generators form a very important part of Python, especially when you're working with classes and you want to create iterables. So make sure you have a look at them. Then list comprehensions are also very useful. The next point about data serialization and deserialization. Now this is very important when you are working with web applications where you have to convert your JSON data, or if you're working with some other data types, such as if you want to convert your CSV file or Excel files to pandas data frame and so on. The next is decorators. We already had a small look about decorators, but decorators is a pretty big topic. The next is about your object-oriented programming, in which I would like you to have a look at abstract base classes and also OOPs. In this tutorial, we saw how we can inherit from a single class, but in practice, you can inherit from multiple classes. You can also create classes that act as an interface. So there is a lot more to learn about OOPs as well. The next point is about multi-threading and multiprocessing, and the next one would be your concurrency and async IO. Now Python has been a little notorious when it comes to concurrency, but lately there have been a lot of development, especially with the async IO syntax. So if you want to make concurrent applications in Python, I would suggest you to learn a little bit more about concurrency. The next one is testing. Now without testing, none of your applications are going to be complete. Python ships with a testing framework which is called as unit testing, and there are a couple of other testing frameworks such as PyTest. The next would be web frameworks. If you want to create web applications or if you want to create APIs, then I would suggest you to have a look at Django, Flask and Fast API. And last, if you are interested, you can always try learning machine learning and deep learning. So this itself is a very huge topic in Python. And again, I can't stress enough that you have to solve more problems. And finally, before I say goodbye, I would really love to hear from you. You can visit my website or you can tag me on Twitter, or obviously you can check me out on YouTube as well. See you, and let the power of Python be with you.